Good morning, everyone. Welcome to DevSecOps Days 2021 event as DC event. So we will have a live virtual event today. And I would like to go over a couple of logistics first. So what is really DevSecOps Days that we have been doing for years? This is the last DevSecOps Days event in 2021, and we're going to continue in 2022 as well. So let's start a little bit background and how the DevSecOps Days is really started. What is our intent? What we would like to do? What is the our expected things that we're going to go through this whole day event today, and what we learn and what things we are accepting, what we are getting from our speakers. So what is the DevSecOps Days? It's a community event, and if you go to DevSecOpsDays.com, and you will see a lot of information, a lot of good knowledge and about the DevSecOps, about DevOps and adding the security. It's becoming really important as we just waking up. The Log4j event happened last Friday. Now it's getting more important to be readiness for the context of how we respond, how we talk about it, how can we patch, and how can we ready for that type of situation. So that's kind of one of the intent of DevSecOps Days that we do for years. And our purpose is really getting a community, getting a practitioner like you as the participants or the speakers, and share their journeys and share their problem, how they solve, how they're improving their security content in the DevOps realm, how DevSecOps is really helping to improve their security postures. So really creating some sort of a relationship and also sharing information amongst the speakers and participants, we can collectively build a better software in high quality so we can get a security addressing of the application early in life cycle that automate the security principles, automate the deployment practices, automate all the content that we are looking for to improve our postures. So if you go to DevSecOps Days, you get a lot of information and we can get more content, we can follow it. So as the community event, and really we are doing all around the year, and I believe this is the 15th event we did this year, and we are looking forward to a couple more events next year as well as increasing the number. Since we started about 5 years ago, now number is increasing, even though we are in a virtual setting still, and we are doing a lot of community events as the local base, like Boston or Tokyo, or Pittsburgh or LA, or the Australia as well, and Sydney, and many other places as well all around the world. So if you're really interested to have a DevSecOps Days in your communities, just please reach out to us and we can help you to establish your community event. You can get your local supporters, and also you can get your team members and then share their experience. So let's see how it's going to go today. And we will literally like to have you participate through the session, through the LinkedIn. If you go to the SCI YouTube channel, and you can ask the live questions. As we said, this is a platform you are sharing the information. Sharing is about asking the questions and live participants. So speakers will be there. And maybe you can get a chat with your peers and as a participants and sharing some information, exchanging information. Because one of the principles of DevSecOps Days is really exchanging information. If you're in a virtual set, if you're in the physical settings as seen together, we should have more exchange information. Let's use the YouTube channel and for that purpose and share the information amongst each other. We can increase our knowledge and we can share our stories. Again, this is a lesson learning we would like to do. And think about is a kind of a feedback. You're giving a feedback as the learning what you achieved and learning by asking the questions. So if you have any further information you would like to talk with us, and you can reach out to the info@sci.cm.edu for a specific particular question you may have, because we're not able to answer everything to YouTube, but if you would like to follow up question with us, absolutely, we're happy to talk with each of you through the offline. So let's look at our today's agenda, and we have a great speakers today. So we're going to talk about the DevSecOps in a different domain, like a machine learning as an example. We're going to talk about the threat modeling, how it's really changing DevSecOps concept. And we have a 1 hour, a great panel will happen around the noon time. Again, everything is Eastern time zone. So we'll talk about the threat modeling. So we're going to talk about how it's really achieving the DevSecOps context, what is the relationship, what the business impacts are, because we would like to do something and in terms of our organization, that something means the business impact, something means about the delivering the high quality. Let's discuss, let's talk about it. So this is going to be kind of our morning session and talking about the threat modeling, different domains, and lesson learned from the colleague perspective, and also applying to the business context. When we look at the second part of the day and after the lunch break, we're going to have a great speakers from Linux Foundation, and Derek Wicks is going to talk about how we are securing the development for supply chain open software communities. It is becoming very, very important, as I said at the beginning. When we look at the Log4j as an example, we should be ready. Yes, we would like this open source, but we should be ready. So we're going to hear a lot from Derek and how we can do what we should do with respect to open source and a community, what we have to do with secure application through our DevSecOps environment. Then we're going to dive into the more security perspective and looking for the static analysis result. And Chris Neer, he's going to talk about as the actual scenarios, actual work he has been done for years. He will share some results on static analysis survey with various tools and what the relationships are. Then we will dive into the service mesh concept again. How can we achieve the architecture elements or making the continuous deployment, continuous integration practices are using the modern technologies. And we're going to finish up the day and building up a culture elements, because we cannot really ignore the culture and just focus on technology. We have to look at what the culture elements are as going forward. So this is me. I mean, just going to skip quickly. I have been working for SCI for years, and I'm the technical director, and I'm also the faculty member at CMU. I have been teaching DevOps course and DevSecOps course as well here. So Derek Wicks will be our keynote speakers for today, and Derek's from the Linux Foundation, and he's speaking at afternoon and after lunch break. And Derek is a senior vice president at the Linux Foundation, and he's supporting DevOps community, and he's a co-founder of All Day DevOps as well. Derek and I, we have been working in this space almost 6-7 years, and our mission is really supporting to the community, as Derek is kind of pioneering this space, and then he is in the Linux Foundation. He's going to talk a lot and with the DevOps perspective today. So as we are moving forward, we have many speakers, as I said, and speakers from the Accenture, and we're talking about the machine learning implementation with respect to DevOps and how the relationship in between. And then Kayra is going to talk about the COVID era perspective, how DevOps is really shaping up the concept. Then we're going to hear from the Kevin about the threat modeling as the kind of morning sessions. As we are moving forward, now we are focusing more threat modeling as Simone from the Microsoft, Lotfi from the Iowa universities, and Arun and Altaz from Security Campus, and their actual practitioner and creating the threat modeling concept. Actually, especially Simone, and he is the creator of the Threat Managed Studio, was published in a lot of organizations, and people are using an open source version of threat modeling, and you're going to hear a lot what the connections are. How can you use these tools in the concept of threat modeling with the DevSecOps principles and tying to the business perspective. As we move forward in the rest of the afternoon, and Chris, as I said, is going to talk about the static analysis pieces and from Spectra, and then lastly, Louise and Paul will talk about cultural elements and service mesh. And also, I would like to thank our moderators, and Jeff and Doug and Joe will be moderating the sessions and throughout the day. And I know we're looking for the YouTube channels, and we would like to make as possible as engagement. And Joe, and Doug, and Jeff will be helping us to communicate, look at the YouTube channel. That's reasonably important to put some questions into the YouTube channel so we can monitor it and we can respond quickly, and they will help on us. So when we look at the DevSecOps days so far, we have done many, and we have done almost 12, and then it keep coming up. So you can look at the DevSecOpsdays.com. You can look at the previous sessions from Marcus or Tokyo or Boston or Pittsburgh and London. You can get more information what has been done for years. You will see a trend. You will see many other different topics and different contents from different speakers, from local community members, or sharing some stories, and everything is available as a recorded session. You don't register, just go take a look at the recorded sessions. As I said, if you are really interested to get DevSecOps days into your community, please reach out to us and we can help you to set up the communities in your organization, in your community perspective, so we can expose the many peoples, we can increase the awareness of security in DevSecOps communities. That said, if you would like to get more information, and I would like to share a couple of URL, and you can look at the SCI website for DevOps information or DevSecOps blog or webinars and podcasts. You can get more information. It may be specific to your implementation. You may get something about what is the specific problem you may be dealing about it, or you may have some abstract theory, you may hear it. So it's just going to get a lot of information and different cases. including the Docker implementation, to the service mesh or culture or monitoring. You can get so much information from this website as well. Again, our goal, our mission is to help the community, and we would like to share what we learn. And also we would like to hear from you, your experience as well, so you can share your knowledge pieces with us so we can build up the communities to build up the secure system, secure software. Because we strongly believe that that's our job as building. This is not you and I, this is our job building a secure software because we depend on each other. And please welcome and look at any URL and then information on SCI website. That said, I would like to thank our sponsors, and as they say, is one of them, Sonotype is another sponsors of this event. And I know it's a virtual, but I would like to thank our sponsor. They're helping us to build up, and this is such a great live virtual event. Without further ado, I would like to really talk about what is really next, what are we going to do. And so our next speakers will be talking about the DevSecOps on how it's going to have for the machine learning perspective, and how the machine learning is really shaping up with the DevSecOps concept. So we have the speakers from Accenture and Rajendra, Prasad, and Aditi, Kulkarni, and Vijeth Hedge, and they will be talking about this implementation and what the machine learning is widely used and how DevSecOps is helping, and what the problem that we are seeing, what the problem that we would like to solve. So before starting their session, I would like to say a couple of words about Rajendra Prasad. And he's a senior manager director in the global automation lead at Accenture. And Aditi, and she's the global technology solutions lead. And same as for Vijeth Hedge, and he's the managing director and DevOps lead for India Accenture. And without further ado, and I would like to hand over to them so we can hear what they are talking about DevSecOps and machine learning perspective.
Hi, this is Rajendra Prasad. I'm the Global Automation Lead for Accenture. Myself, along with Aditi and Vijeth Hegde, today we'll talk about DevSecOps for enhancing security of machine learning. That is, performing machine learning actions the DevOps way. This paper has 3 distinct sections. We're going to talk about the aspects of the machine learning and the importance of the security. And we'll talk about various security threats and how to avoid them leveraging DevSecOps. We'll then wrap up the paper by providing you practical insights how this will all come together. In the ever evolving world and steady increase of machine learning models and the cloud computing and the technology evolution in the cloud has helped the easy availability of data, thereby impacting the volume of machine learning models that are built today. The cost-effective options to store and retrieve the data, to compute upon the huge volumes of data, and the options to fail often, fail fast, and fail cheaper has added fuel to this adoption. It is predicted that machine learning ML will become implicitly employed in all the leading software in the next few years' time. And this is set to cause massive disruption in the software industry and software landscape for every enterprise. From monitoring existing software landscape to threat modeling from machine learning, security practitioners will have to handful to manage from all aspects of ML. And data is the most important aspect of machine learning systems. Data is the UI of AI. It is the data that helps ensure the accuracy and in prediction of the models. Ironically, the most important category of computer security risk is also data. The malicious input can come through data and make sure the front end, which is AI for the data, can be also impacted. Machine learning is the field where we can choose to build models afresh, use the public models, or do a transfer learning. When you do transfer learning, there is an increased probability of threat and threat attack that can happen through transfer learning process. Very often, machine learning models themselves are poorly understood, poorly described, and impossible to reproduce. So it is even difficult to debug and avoid the attacks. Attacks can happen easily if system results cannot be reproduced and if results are not being regularly monitored. So, if for every organization there is an important need to shift the security to left and make sure that various roles within the organization, including machine learning engineers, practitioner, needs to understand how to shift left the security practices. The security practitioners of an organization need to know the basics of machine learning and understand how ML can impact security of the entire organization. We look at traditional solutions employed to mitigate these issues and the organization's hurdles on the way. Finally, we'll also discuss a centralized defense mechanism to strike a balance between strategic risk of an organization of adopting machine learning on time to reach market demands and the goal of operationalizing machine learning products and services in the safest possible manner. This will then combine with the DevOps principles and provide you a holistic solution. In this process, the first step is to understand the life cycle of ML solution. In ML pipeline, usually it starts with data ingestion from multiple sources. The sources can be local, it can be spread across global, and data from various domains can also be combined to create valuable and contextualized data. Once the data is ingested and pre-processed, a representative sample is selected for training and testing, another representative sample for testing, as you all know. The model can then be in-house model or it can be public model, but in either of the case, it has to be tuned and ready for testing, training and testing of the model using the data. The model is found to be appropriate with respect to its prediction, then it is deployed for everyone's use in a bigger environment and exposed to the live data feeds to serve the customers. These feedback loops will then help retrain and upgrade models according to the changing data of the need. So I just completed for you the context of ML and the ML lifecycle and how it will work. Now Aditi will talk about the 4 types of attacks that surface through the machine learning systems and take it from here. Over to you, Aditi.
Thank you, RP. I'm Aditi Kulkarni. I'm the Global Technology Solutions Lead for Accenture. Let's look at the 4 types of attack surfaces of such a machine learning system. The data, which includes the training, testing, and live data. Second, the model, which includes the learned parameters and the training data. Third, the engineering, which includes the software dependencies. And fourth, the deployment, which includes the model, the API endpoints, the web servers, the infrastructure as a code, and rest. Let us deep dive into few common attacks in this space. False data injection. When data sources are not reliable or credible, attackers can tamper with raw input data and inject false data during the data collection process from the different decentralized sources. Feeding malicious input in very small nudges can cause the model to produce wrong predictions or categorizations. Data theft. AI systems require contextualized data. For example, a car insurance company can get shopping data, driving data, location data, and other data sets that can be effectively correlated and matched to the customer accounts. They require this information to understand its customer driving behaviors. At the same time, this enriched dataset is more appealing to hackers and more damaging to the company's reputation if it is penetrated. Data manipulation attack. A causative or poisoning attack can inject incorrect or false training data. For example, an attacker may post inaccurate data to influence financial time series forecasting models or interfere with medical diagnosis. Organizations are dealing with algorithms that are creating ethical issues such as discrimination against women or minorities. A training dataset that underrepresents some classes of data or is out of date can cause issues for the organization. In fact, training data, validation data, testing data are subject to poisoning attacks. A data manipulation compromises behavior towards future inputs. Model manipulation attack. In many cases, machine learning systems in the real world are built by leveraging a pre-trained public-based model, which is then fine-tuned to perform a more specialized task. An attack occurs when the underlying public model is compromised, allowing an attacker to execute unanticipated behavior. Such attacks are also known as supply chain attack or backdooring. In the deep learning world, it is common practice for models to be released under an open source license, facilitating code reuse and transfer learning. Attackers can easily misuse such models. Input manipulation attack. A manipulation attack on inputs to a machine learning model at runtime or test time delivers an output that is not expected. This is also known as adversarial examples. This attack compromises behavior towards the malicious input. For example, consider an online machine learning system that continues learning and modifying its behavior while in operational use can be turned in the wrong direction by feeding the system inputs that retrain it to give the wrong outputs. Examples of such attack include a stop sign being labeled incorrectly as a speed limit sign, or a spam email being labeled incorrectly as not a spam. Data extraction attack. Data extraction attacks happen when an attacker extracts information about the training data by querying the model or by directly inspecting it. Through training, sensitive data may be incorporated into the model. Real-world machine learning systems involve proprietary data, which can have serious privacy implications. Attackers can extract this information, and it is commonly known as inference attacks. Data or model extraction attack. It occurs when an attacker targets a less than fully white box machine learning system, attempting to open the box and copy its behavior or parameters. Model extraction may function as theft of a proprietary model or enable white box attacks on a formerly black box model. Input manipulation attack. Input extraction is also known as model inversion. It occurs when the model outputs are public, but inputs are private, and an attacker attempts to recover the inputs from the model outputs. For example, inferring medical record attributes from the dosage indicated by a machine learning model. Output integrity attack. When an attacker interposes between a machine learning system and the outside world and directly modifies the output stream, the larger system in which the machine learning subsystem is integrated suffers. Because the models are sometimes opaque, the unverified output may be used with minimal scrutiny, allowing an interposing attacker to easily hide in plain sight. Authorization and authentication. There can be a lack of strong authentication, authorization, least privilege principles, secure connections to backend databases, secure connections to third-party data sources, user interfaces that are not resilient to injection attacks, and defenses in depth, which increases the attack surfaces of machine learning applications. This risk is complex, demanding that machine learning engineers consider data provenance, algorithm choice, and system operations in order to properly address it. Most of the organizations use siloed defenses. For example, they ensure that data sources are secured using conventional security standards, that only relevant data is collected, and that PII information is removed. There is no centralized orchestration technique available to ensure that all these policies are perfectly followed. To tackle these challenges within the organization, a centralized defense mechanism should be developed. Handing over to Vijeth to explain how this can be done.
Thanks, Aditi, for talking about all the challenges in the entire ML development lifecycle. Now, let me talk about what all the different weakest links and how we can bring in DevSecOps solution in entire data and machine learning lifecycle. So today you see data and the silos are the weakest link, ensuring that a secure ML system. When it comes to machine learning and data science, most organizations today work in silos or putting an entire team effort to achieve the results. So now what we need here, how we can bring the defense layer in my entire data development and ML development. What we need here is first is we need to orchestration DevSecOps across the different teams to help to reduce the deployment time from many weeks to few hours for data processing and machine learning application. 3, ensuring that security policies and data governance policies are automated through the pipeline. And fourth, which is quite common, which we have been following in DevOps from day one, is fail fast. And finally, another important area which everybody should focus on allows user to continuously innovate without being worried about the security policies, the security of their application, and the security of their data. So moving on to the next slide is how we can bring in DevSecOps in my entire data and machine learning development ecosystem. So first is what we need here is the security as a culture. So to implement a secure environment for machine learning system, an organization should follow the basic principle of security, like the principle of least privilege, the principle of defense in depth, and securing the weakest link. The principle of privilege indicates that a person should be given the just enough or minimum privilege to their duties. All the users of a product should not be given the root or the admin access if it is not all the necessary for them. So talking about this, what is this weakest link, right? That is actually when you apply the components of security functionality that does not overlap. So if we have a weak component in the overall software landscape of an organization, that component is most likely to be attacked by from the external attackers. Hence, it is this component that we have to secure first. So the defense in-depth principle hints at redundant security measures. It ensures that the total protection offered is far greater than the protection offered by any single component. Any vulnerabilities not addressed by one component will caught by another. Once the foundational security layer in place, I think that is the starting point to securing our entire ecosystem. The next layer that we look up to is the DevSecOps layer. So this is missing or ignored, or nobody has thought about it in the data world. So this is the layer which is the most data companies who are developing in the machine learning products. This layer ensures that the shift left security practices is the culture of an organization So in the development stage of software development lifecycle, the developers are made fully aware of the consequence of their less secure code in the production environment. They are educated, trained on the go, even during the coding phase via their interactive development environment, or in order to implement they're using this to implement the best security practices using this shift left security. And with the continuous feedback in the DevSecOps pipeline, ensure that the developers get instant feedback about the security scans run out of their code. It is worth spending few extra hours during the development phase to ensure the best security coding practices rather than spending millions to pay fines and fix the security vulnerabilities in production. So next is the whole today you all know that everything as a code, right? This essentially means that infrastructure provisioning, security configurations, data governance policies, data processing pipeline code, database configuration code, machine learning model development, and deployment of machine learning models or API endpoint creation, different charts, dashboards, or within the RBAC policies, right? Everything can be versioned as a code today. So this can be referred to as an everything as code. I just start talking about this because today, if you look at in my entire development lifecycle, any infra configuration or policy configuration, everything can be stored within your Git repository. So now how we can bring in everything together through the best DevOps best practices, right? What you know about DevOps today is like CI, that is continuous integration, continuous testing, continuous security, or continuous deployment and continuous delivery. So on top of that, we have this whole continuous feedback, which is the core mantra of DevOps, where Dev and Ops come together. So this continuous feedback enables code to cloud visibility for data and ML engineers, where it helps to know the impact of their code on the production environment and how it impacts business and the consumers of the data or even for the ML prediction. If you see today, the cloud is very essential for these days. The pandemic situation also has told us uh, uh, has put in a lot of focus on the whole cloud today and the importance of being ultra digital. So organizations are today moving towards a very highly dynamic cloud native and microservices oriented framework for their whole software development. And so the whole importance of code to cloud visibility is even more for the developers, either it be beta engineers or ML engineers or even for the DevSecOps engineers also. So DevOps practices also help to automate software patching at the right time so that we ensure that software images that we are using have all major security vulnerabilities also addressed in them. So we include code scans for the external libraries and external software dependencies in an automated fashion. So next we arrive at the data and MLOps layer, if you can see from the slide. So just like DevOps, we have broke these silos between Dev and Ops. So even in the data ops also came into being to help fast track data engineer process by employing the DevOps principle. So the traditional data processing application, so it all relying on multiple teams to move the data from their partner data sources to their ODS or the data warehouses. So as you know, like this is terribly slow. This is what this is one of the big challenge because many teams are involved and even a small change to a particular data entity takes weeks or months to go into production after checking against all data governance policies and regulations. Also, the security measures are also siloed within the team. So traditional ETM systems. So this is also find it very difficult to scale also. Because also the ETL code, the database configuration code, the database scripts or static data upload scripts, or everything is version controlled by different teams and then handed over to the deployment team to be deployed in higher environments. So this gives rise to a lot of deployment issues which any data engineer could relate to. It's not only the pain of the data engineer, but also many companies had to pay a lot of fines or the penalties due to the data quality issue as an outcome of their data processing jobs. So how you can automate? So how automating this whole data preparation through DevOps with the help of data ops help us to version data as a code. The entire history of the ETL pipeline changes our version and hence how it is impacting the data is clear and transparent with the data ops. Since data ops orchestrate across multiple teams, the changes needed to the ETL process can be seamlessly done within few hours time, which also includes code review, unit testing, functional testing, and the vulnerability scanning or the security scan as well. With the pipeline, we can replicate the environment also multiple times for different purposes with all the required security measures through the infrastructure as a code. So now another complexity which has now again on top of all this thing is also going whole data ops also is going multi-cloud. A single data ops pipeline today can be in multiple clouds, leveraging the power that different cloud vendor services have to offer to us. So another aspect that goes along with the data ops is the whole database ops, or we call it as a dev DB ops, where everything around database setup, where to configure the database, how to configure it, what the schemas, users, roles, static table to be pre-populated, right? There are many such activities. So which are all can be automated using the data ops pipelines. This ensures that security policies are in place from day one and the security policies can be replicated hundreds of times as we want without making a single mistake. This level of automation releases a lot of burden and stress from the database administrators as well as the ETL engineers. So next is how DataOps also ensure that many aspects like data quality, data security, encryption on the go, calculating data drift, updating data lineage, and data catalogs on the go, and including the data versioning. So how we can manage this entire thing in the lower environment? Yes, that is also we can done through whole with the DevOps pipelines. And also this also ensures that our data is safeguarded by applying configuration settings in such a way that we follow all the security policies and governance policies. So moving on to the whole ML logs, that is the major topic of the discussion now. So now we have the clean data. Now with the high quality and trustworthy data from DataOps, MLOps essentially empowers data scientists and now machine learning engineer to innovate fast. They are able to experiment with the different algorithms, see their experiments in version controlled manner, that is through the model versioning. And also it helps the people to correctly pick and choose particular version of a model to go into your UAT or then move on to the production and continuously then do the monitoring as well. So here they are able to deploy the whole model endpoints with the needed security layer just through the pipelines. Hence with MLOps, the data scientists and machine learning engineers can seamlessly innovate on the fly without worried about whether security policies are getting violated. If, for example, if they want like model hashing or traditional model security features, all of this can be coded once into the pipeline and then we can execute any number of times. Finally, there is another very important layer we talk about in DevOps, this whole continuous monitoring. Today, that whole monitoring is evolved to this observability, and which is now gaining a lot of focus in the DataOps and MLOps world as well. So observability is understanding the new types of normal without any pre-assumption of what normal should be. Observability also helps us to answer that many questions like why, what, how, when, and then what about the system to find out root cause of our problems. So for example, if a business KPI is not being met, so we can answer why it is not being met, or it is not being met because of some of these data features quality is degrading, or where is the data coming from, and why is this quality is degrading, right? So which partner system applied this data first, and was this data tampered, has the data drifted, or what is the impact of downstream? Is there ML model drift due to this data? So there are many things which we can get through this whole observability. So we can monitor all these outliers, anomalies more effectively than traditional monitoring tools, since we look at all the logs and metrics to avoid any blind spot. So to look at this entire thing, what we can do today here is how we can bring in some of this best practices we have worked all these years to make sure that we can deliver clean data and create the right set of model and applying all the security or compliance as a code into what I delivered to the production today. Finally, to summarize, how we can encourage every data project or every organization to adopt the DevSecOps principle of automation to move ahead to the innovate fearlessly, or fail fast, or finally, or even fail safely. So DevSecOps is more than just an automation today. Also, it is having an edge over traditional data and machine learning frameworks, and it will surely go a long way in securing all our machine learning environments in the future. So finally, my one line, which I want to conclude here with the one line, is do ML the DevSecOps way. That's it. Thank you. Thank you for giving me this opportunity. Happy to answer any questions. Thank you.
Hello, DevOps community. It's my pleasure to welcome our next speaker, Vijeth Hegde. He is the managing director and the DevOps lead for Accenture India, where he helps clients manage their DevOps journey. He leads the co-creation and asset development initiatives, and he has coached large transformation engagements on the state of DevOps, response preparedness for continuous disruption and developing a vision for evolving to the next generation of technology through a culture of continuous innovation. He's going to have a good talk that we're all interested in. It's DevSecOps and AI. Vijeth, the floor is yours.
Yeah, thank you. Yeah, thanks for the opportunity given to me. And so today I talked about the how we can bring in the DevSecOps best practices in your AI development, that is starting from getting the right set of data and then creating the model, and then how we can operationalize this model and bringing in all these DevSecOps practices, and to make sure that how we can fail fast, right? So that is something I talked about today. Thanks for the opportunity once again.
All right, great. One of the big questions we have is, what are the real critical success factors for DevSecOps and AI?
Yeah, so good question, Joe. So first thing is, one thing is we have to make sure that, so bring in this whole DevSecOps, that is what we call it as the culture across the different teams. That is either from the wherever we are getting from the data or even from the AI team. So that is all about orchestrating the right set of tools with the right set of the automation for the continuous integration and continuous delivery, bringing across the teams. That's the one. And also bring in as much automation as possible, starting from the requirement till the deployment, right? So that is actually reducing the whole deployment time from many weeks to few hours for the data processing and even for your machine learning applications. And the third thing, which is extremely important here today, is how we can enforce all the security policies or the compliances or the governances when I'm developing my application. And the fourth thing is, because of the whole automation, what I have across my pipeline, how I can fail fast and fail safe, right, across my life cycle. And finally, which is another important area which we practice day in, day out in the DevOps world, is how users can continuously innovate, right, without being worried about the security policies or security of their applications or the security of their data. So how we can bring in some of these best practices to allow them innovate continuously. So I think these are the 5 things which is extremely important for success of the program.
Well, what do you find is the most difficult thing to get started with here? What is the biggest challenge?
Yeah, so some of the big challenge which I'm seeing today here is these are the best practices we have seen this whole DevOps, how it works, and we have mastered this in the entire software development world. Today, these are some of the new things which we are bringing in data and AI. So organization, I'm seeing this lot of organization finding it little difficult today to adopt some of these best practices, especially in the data and AI, because it all just started. I think there is a long way to go. I'm pretty sure that a lot of organization, I'm seeing that they have already started, but success of their program, or I would say it as operationalizing of this data and AI, I think at certain point of time, I think some of these continuous integration, delivery, deployment plays an important role. And to achieve that, one other thing which they have to adopt now is the whole change management. That is the change culture. That is always we talked about. That is something we have passed through in the software development world. That is something we need to achieve here in the data and AI as well.
I know in our own work here, we struggle with quite a few of these topics. It's a really hot topic right now. How do I validate that the model I'm deploying is the model we built? Do you have any insight into kind of the authentication, the verification that the model is legitimate?
Yeah, so first thing is I talked about today is all about getting the clean data from my data pipeline, right? I spent quite a good amount of time today, like how to do that, because we have the data coming from multiple sources. How we have to ensure that, okay, data is not tampered or in no malicious input in the data, what I got. I think that is an important part. That's the first step. Once I have the data in place, then I think the next step here is selecting the right algorithm, right? For creating this model and having my continuous DevOps pipeline here. So that starting from your developing the model, training the model, and very important here is, which is I've seen in a lot of projects which we are trying to bring this best practices here, is having this versioning of this model. Like this is what we are following in the DevOps world. How can we version this model and then deploying that model, and finally the whole observability part. How can I continuously monitor this model for the accuracies, right? Say, for example, if the accuracy is going down, how can I get new set of data and create the model continuously? So that is what we talk about in the whole DevOps world, that whole inverted 8. I'm just bringing the best practices here.
Fantastic. Looks like we're running out of time for this session. I really appreciate your talk.
Yeah, thank you. Thanks, Joe. Thanks for giving me this opportunity. Yeah, thank you once again.
All right, we appreciate it.
Yeah, have a nice day. Bye.
Too.
I know we are paying that a lot of attention right now, which is a lot of the happening through, especially for the solar wind. A couple other examples. I brought that screen so we can discuss more in the pipeline perspective. So it's a great thing. We typically, as the community, we focus on building the good quality, secure application. We often forget how to build it. How to build is the key point, like where we are building, which is a software pipeline. So if you look at this picture, this is the section, and we typically use right here, this is our pipeline, which has left me a little bit bigger, which has the continuous integration, continuous delivery, other practices that we have. This is our pipeline. But if we don't secure this pipeline, what that means securing a pipeline? Let's say I'm a developer, I'm right here as a developer, and I'm going to use, right there, I'm a development team. I would like to use some of the libraries and to achieve my code, because typical current developers and as an engineers, we are dependent on so much complexity that we have in our environment. Like if I'm going to write a code, I just go to Google it and go to GitHub to get something is available for me. I don't want to reinvent the wheel, because
we are racing with the time. So with this rationale behind it, I can get the libraries put into my pipeline. That's going to be part of my continuous integration example. So suddenly I'm inserting X library here into my build process, which is how we're getting the open source, which is S1 component. Second component is how are we going to securing as the configuring of this pipeline. Let's say we have a continuous integration that we have a continuous deployment. In the continuous integration, we might be using some build server like maybe Jenkins, just to make it more realistic example. In the Jenkins, and I'm giving another one example which happened recently in November, we're using some static analysis tools that we may have for security perspective. So if you don't configure these two tools properly, now we are opening up a vulnerability for the people who can attack it. So now it looks like we are in the perimeters of a network infrastructure that we are protecting. But if you don't configure each of the tools that is part of your pipeline, it's opening up an attack vector. People can take an advantage of using one of the Jenkins configurations back to you. Even though almost every tool vendor are describing here's the best practices to set up your Jenkins, set up your GitLab, set up your Docker, set up your Kubernetes, it exists already. As a practitioner, we just go and download and grab it by default and then try to install an environment without even thinking, all right, how can I make sure that I have a good secure implementation of this component? How are we going to make sure that Jenkins is able to segregate multiple builds in the build steps build perspective? So we have to step back, think about that, how we are thinking about application security. We had to think about as the pipeline itself and how can I secure the pipeline? How can I secure it means how can I configure it properly? And then how can I be ready for any type of outage in the pipeline? One specific example I can give, which actually happened a couple of years ago, one of the smart, I'm going to say hacker people, they used one of the build agents and then put a data mining vulnerabilities into the build agent as part of the build server, doing data mining through the pipeline. It's a great idea because build is keep running and then you don't really pay attention how the build is acting. So you're giving a free resources for adversaries and taking advantage of build agent and running a data mining on the build agent, doing some other process as part of it. How it is get there, which is about the lack of configuration, lack of not monitoring libraries. And then we don't have a monitoring that we discussed at the second question, I believe. If we don't have a good monitoring, how are we doing well, how the system is behaving, there is no way we can capture any type of abnormal activities as part of test scenarios. So we have to configure as a summary, we have to configure our pipeline, make sure that we are following best practices. We have to be ready by monitoring any abnormal behavior of the test or the build stages. And third one, we have to have a full traceability. Who is accessing our libraries, our pipeline, what they are changing. Like we should establish the good, secure, commit process into the repositories. We should have a kind of SSH, or we should have a tokenized, we should have a cryptographic deployment. We're going to make sure that we are accessing the pipeline as an individual. We are following the best practices as well, Shane.
Our next presenter, Ken Van Wyck, is an internationally recognized incident response and software security expert. He has published 3 books on incident response and software security. He has worked at SEI CERT as an incident responder from 1989 to 1993, and he went on to leadership roles at the Department of Defense incident response program, and later in the commercial sector. For the past 18 years, he has been the principal consultant at KRVW Associates in Alexandria, Virginia. Ken, you're going to present on using threat modeling to guide everything in DevSecOps. The floor is yours.
Great, thank you, and good day, everyone. So again, my name is Ken Van Wyck, and we will have a Q&A at the end of this, of course. So, but my topic today is we're going to talk about threat modeling. It's something I've been doing for a long time. Before I even called it threat modeling, it turned out we were doing design reviews and such, and different flavors of threat modeling, perhaps we'll call it, but doing similar sorts of activities. But my focus today in this talk is how to get the most out of threat modeling, because there's so many secondary benefits we get from doing threat modeling. So let's dive straight in. So we're going to talk about things that we can do throughout the DevSecOps process that will come directly out of the threat modeling process. So what's the big deal about threat modeling? Well, you know, most of us that are doing threat modeling or doing DevSecOps, you probably realize threat modeling is a pretty powerful process, a pretty powerful tool. It tells us a lot about a design, and in the spirit of DevSecOps and, you know, agile and the various different components thereof, I find that a lot of my clients are fairly light on design documentation, for example, and we can do a lot to help that along with threat modeling. So there's a lot of goodness going on with threat modeling. Oh, and later today we'll be hearing about some work that's being done towards threat modeling maturity model, for example. So those are all good things. The ball's being moved down the field. That's outstanding. So I've many times told my friends and colleagues and clients, if I was stuck on a desert island and somebody said you can only do one security activity during software development, you know, I know that's a nonsensical thing to say, but even still, if there was only one thing that I could do, it would be threat modeling every time, because there's so many things we learn from that. So if you're new to threat modeling, you're just getting started, at the end of this slide deck there, I've put up a couple of resources that you should take a look at, starting with Adam Shostak's book on threat modeling, outstanding stuff. But in my view, to get started, what you need is a knowledgeable and motivated team, first and foremost. If you got the right people, you can do a lot of really excellent things with threat modeling. I'm old school on this, but I like to have a huge whiteboard available. So when I'm in an engineering space, I look for entire walls that are whiteboards, right? So with good, fresh pens to work with, you can accomplish a lot with that. You probably want to also have the ability to record that, you know, cameras or whatever, you want to be able to record the contents. Oh, and you also probably want some way of tracking your work, right? So I find that a simple spreadsheet works really well. So you don't need to go fancy on the tools, at least in my experience. We can accomplish a lot of really excellent things without having to get expensive and fancy tools. Now, that said, I'm not saying don't use tools. There's a lot of good tools coming out there. The market is maturing. It's getting better. There's a lot of neat work being done. But sometimes those tools kind of drive our focus to just looking at one thing, and that is a prioritized list of flaws or weaknesses or potential weaknesses, if you will, in a software design. And there's a lot more to it than that. So I see a lot of tools and processes that focus on that prioritized list of problems, and they lose track, in my view, of some of the other things. That's not to say you shouldn't do these things. You know, integrate them into your bug tracking. All of those things are important, but in my view, there's a lot of secondary benefits to threat modeling that I want to talk about here, and that's kind of the main focus of what of my talk. So when we just look at building a list of things, and face it, you know, the stride and dread approach out of Microsoft pretty much pushes us down that process to look at a prioritized list of things. But DevOps or DevSecOps or Agile, whatever you approach you want to subscribe to, we embrace reusing and reviewing things once and then making good use of those. So what I'm saying is let's take that conceptually anyway, and try to get as much benefit as we can out of our threat models. So obviously I'll describe that in more detail, but everything from code reviews to testing and even deployment and even incident response. You know, I spent a lot of time doing incident response myself. And even though that's not my focus here today, even incident responders can greatly benefit from the results of a threat model. So let's move on and let's talk about some of the things specifically. And I have examples here too. I want to spend a few minutes talking about some examples that I've encountered in doing threat models with my clients. So code reviews, right? So DevSecOps, most people at this point in time, 2021, you're probably going through a process where you're doing static analysis at the very least with every code push, right? So every update, every time we put code into our repository, we're probably having some static analysis done on that. It's automated, it's pretty good, we're collecting all the results. All of those things are awesome, and I'm not for a second saying don't do them. What I want to say, though, with regard to things like code reviews or focusing attention on code, don't lose sight of that threat model. Go back to what you did during your design processes. And yes, this is a continuous process. I get that. But when you did the threat model, and maybe that threat model is evolving and growing as you build your software out, that's perfectly fine. Focus some attention on new areas of functionality, focus some attention on where we're handling the most sensitive pieces of data in our application. Things that, and this is just a small list, of course, and it's by no means comprehensive, but focus your attention on what you deem in your threat model to be the highest risk areas, right? So I'm not a risk guy. I haven't spent years doing risk management and such, but there's a value to that too. And threat modeling really spotlights the risky parts of our software. So focus your attention more on some of those highest risk areas, right? So even if you're doing code review on every single line of code in your repository, every time you do a code commit, you're scanning every line of code. That's great, but turn your attention to the highest risk areas and focus some additional attention there. So let me give you an example. This was from a threat model I did a few years back, probably 5 years or so. A client of mine wanted me to review, they told me an iPhone app, right? So, okay, great, we'll take a look at it. And I don't need to name the app, it doesn't matter. Let's just say it was an app through which a consumer could purchase a service and get that service, right? So we looked at the app, right? So we threat modeled it, and during the threat model, a couple things came out. It turned out that, when we were just looking at the functionality of this software, you had a typical iPhone app. You could go in, create an account, do some shopping, purchase this service, order the service, and it would get fulfilled, however that happened at the back end. But when we're just looking at those user stories or use cases, there were several things that we didn't notice. For example, during the threat model, it turned out that they were storing their payment information locally on the iPhone, on the mobile device. Another thing that came out of that discussion was that they were storing the stuff locally. They also had a parallel application for Android, and they actually had a Windows version of it too, a Windows portable or whatever the version of Windows on WinCE or whatever it was at that time. That probably not as old as WinCE, but my point is they had a Windows version, an Android version, and an iPhone version. So that drew our attention to the parts of code where they were storing that credit card information. Okay, fine. When we looked at it on the iPhone, it looked weird. First of all, it was code that had not been previously reviewed, right? So they were doing their nightly builds, nightly code reviews and all that, but this piece of code had not been separately diagnosed and analyzed. My point is there are several APIs just on the iPhone, for example, that we can use the keychain, for example, for storing small amounts of sensitive data and let the platform do the encryption of it. Why didn't they put this stuff in a keychain was one of the discussions we had during the threat model and the corresponding code review. Turns out they had good and valid reason for not using the standard API, and they had written their own functionality for doing that encryption. The primary reason was that code needed to be fairly transportable across the different platforms. Now, Android, they're writing in Java. On the iPhone, they're writing in Objective-C. So it's not like they'd be able to take the code one-to-one, but the basic logic of the code, the flow of the code, they wanted that to be consistent across the different platforms. And I'm not judging them on that, right? So we're going to judge them on how well they protect the data in our threat model and our code review. The choices they made like that wasn't for us as the threat model team to be judging. So we looked at this. It turned out that they wanted the code to be reasonably portable. Okay, fine. They accomplished that. They needed it to be encrypted locally, and we looked at that bit of code. So what we ended up doing was we ended up doing a manual code review of, I'm going to say it was about 500 lines of code versus the multiple tens of thousands of lines of code on different platforms that went into this entire app product and the services around it. Those 500 or so lines of code mattered greatly to the security of this application, and that's where we focused the manual level and the human judgment of code review rather than simply relying on tools to do that job, right? So that was an example of something that came out of the threat model. It was hugely helpful to us, and just having that discussion around that piece of code was something that we probably wouldn't have noticed if we hadn't done the threat model and that discussion had come up as a result. So testing activities, same thing. Let the threat modeling guide us here. So I'm a huge fan of that. So let's talk about this a bit. So again, focus on the areas of highest risk in an application. Look at doing validation testing of those things. I'm a huge fan of validation testing. So for example, if we have, we're doing encryption, we're doing network level encryption in transit, storing things at rest, whatever, we'll probably during the threat model have some discussions about key management. How are those keys generated? Where are they generated? How random are they? You know, things like that might come out of a discussion around the threat model. Hopefully they do. Hopefully you're diving in pretty deeply into details like that in your threat model. In our testing, let's go in and verify, validate those assumptions, right? So if we have key management that's being done over here, let's make sure that it's behaving the way we expect it to. If one of our requirements for the security of our application to work is that our keys, maybe our session keys, for example, need to be random and unpredictable, let's go in and do validation testing of that. And a lot of that should be coming out of our threat model discussions. We can also do some fuzzing of APIs, and I'll talk about an example of that here in a couple of minutes. But all of the things are security assumptions, are security discussions that we have during the threat model, where we need specific things to behave properly to protect the highest risk parts of our software. Those should come out of the threat model, and then we should drive our testing from that. So let me give you an example here. So this was a payment system, a credit card payment system at a major hotel chain that I was involved in. I did the threat model part of it. And one of the discussions that we had during the threat model, we were talking about various different potential threat actors that would have access to different parts of this application. One of the concerns we had that we discussed during the threat model was, what if an employee at one of the small hotel branches is able to exploit the API through which a central storage system of credit cards, payment information, hotel billing information? What if they're able to exploit that API and harvest massive amounts of data by harnessing that API? So that was a concern. Now, first off, we threw that over the transom to the test team, and they went and tested some of these things. Some of them turned out to be kind of not very realistic. Other things turned out to be pretty darn realistic. So out of that discussion in the threat model, and then subsequently in the testing of things, we kind of validated how serious some of these threats were, how easy or difficult it would be to pull off some of these attacks. That resulted in this particular payment system getting what we call a velocity checker, which sat in front of the central credit card database. And it looked for things like an individual hotel branch that, you know, might have, say, 100 customers on a given weekend, all of a sudden generating tens of thousands of queries that would be completely out of the normal for them. So we built in a velocity checker that initially would flag massive statistical anomalies, but it also had the ability or the potential to even throttle those things. You know, one of the principles we had there was don't impede business. So initially, that velocity checker would just send a warning to the security team saying, hey, this is out of the ordinary, somebody needs to take a look at it. So that worked really well, and that came directly out of the threat model. So also, one other discussion here as we move on down the field. So production issues. In our production environment, wherever we're putting our application, oops, went one slide too many here. All right, here we go. In production, the threat model, we should be again focusing our attention on the most dangerous parts of our application. So configuration things, look at encryption that is required, look at configurations of SSL, TLS stacks. So, you know, if we have, say, for example, a highly sensitive part of our application, maybe an administrative connection to our application, and we need to make sure that a specific level of encryption is being used there for the data in transit. Maybe we're storing some things in a container someplace, in a bucket someplace. We want to make sure that that is being properly encrypted. Let's take a look at those assumptions, those requirements for our production environment, and let's make sure that those are being done properly, not just once, but periodically. I know in my experience with my customers, they almost all do periodic scanning, vulnerability scanning, for example, of their production environments, right? So all of that's fine. Just like we want to code review, do some static analysis of every single line of code that goes into our repository. In the production world, we probably want to do daily, weekly, whatever vulnerability scanning. Well, let's ratchet that up a little bit out of our threat model discussions. So another example, let's talk about this one. So in this particular one, I was doing a threat model, and this was just a few months ago. A client of mine was building an analytics application. That's all we need to discuss about that part of it. But it was being deployed in a popular cloud environment. And when we did the threat model and discussion about this, there was some very sensitive data, things like multi-tenant issues regarding this cloud application, where they would be doing analytics of multiple customers' information. And there was a lot of sensitivity about data potentially leaking from one tenant to another, things like that. So there was a lot of encryption in their production environment on things like storage buckets in S3 and whatnot. So, and I'm not picking on any particular cloud platform here, because this would have been pretty much the same for anybody. But in the threat model, we talked about some of these different concerns. That translated to specific requirements for their production, their container configurations and such. One of the things that came out of that for this particular customer was to have a script, basically, that their threat hunt team uses to verify configurations of those things that mattered the most, to make sure that their storage buckets are using, let's say, disk volume encryption or whatever data encryption they're using. Let's write some scripts that look to make sure that those things are particularly being followed in production, right? So we probably tested those. Test beds are great, but we want to make sure they're actually being done that way all the time in production. So if any changes creep into their code base and something gets undone accidentally, that threat hunt process, those scripts should pick that up in the production environment. And even though they're doing daily vulnerability scans, some of these things were highly specific to the most risky areas of their application. That discussion came directly out of the threat model. So I've found that by using our threat modeling in different phases of our process, benefiting from the discussions that we had during the threat model, you can get a lot of, I'll call them secondary benefits, other than here's a shopping list of all the things that we need to fix. That's fine and well. Let's think about where we can use those things to our benefit as well throughout our process. So this sounds a lot like a risk management approach, and it is. So there's nothing wrong with that. And even though I said I'm an operations guy, I'm not a risk management guy. We're very much focusing on risk when we do this, and the threat model brings that to the surface. So I think we're right around the end of my talk time. So let's make sure that we are leaving enough room here for questions and answers. So questions and answers, anybody?
And I'm looking at the audience to see what kind of questions we have. Until then, I have some questions.
Sure, let's hear them.
So you mentioned that tools. I know a lot of organizations wants a tool to help them with this. But you stated it's really important to have motivated, technical or expert people in their field that want to come together and do this activity early. But you didn't talk about necessarily how often do you repeat this activity, right? With the DevSecOps mentality, now that we've identified, we want to add in testing, we want to add in validation. When do I revisit the threat model based off the information I'm getting as we're developing and deploying and monitoring our solutions?
Yeah, that's a really excellent question. And, if we were following a basic waterfall model from the 1970s, we'd probably just do that once and move on with it. My approach to threat modeling that way, and I'll use the example that I just used with the cloud-based application that I threat modeled a few months back. They're still working on that. It's an ongoing thing. It's not done yet. I would expect they're going to revisit that threat model from time to time. I would expect them to, depending on how rapidly they're developing, right? So if this is a multi-year process and they're not spitting out huge amounts of code at this, I would expect them to revisit it maybe every 6 months or so and see what's changed, right? So just ask that question with regard to our threat model and the concerns that we had when we had the first discussion. What has changed? What new code, what new functionality have we built into our software? What new features and such user stories have been built onto there, and do those things affect our threat model? So you can kind of do the iterative approach where you're asking that question about your threat model. What's different now than when we started this process, when we first looked at our threat model? That's the way I would approach that.
Excellent. Yeah, I know it's a topic on it. It's heavy on everybody. We know we want to do this. I think organizations do struggle with who should be in the room, right? Who should be participating in the threat modeling? And what is our real output from this, right? What does it look like? How does it enhance the testing we do? How does it even dictate the way we go about validating those things?
Well, we want to build a lot of automation into our process wherever possible. So that's one of the things I hear a lot from my customers that are doing DevOps and DevSecOps. Automate everything we can. If you do it more than once, automate it. All of those sorts of things. And some of what I'm talking about kind of contradicts that. So, but at the same time, I'm saying embrace the automation, do the code reviews on everything. And let's not do manual reviews on everything, because that would be crazy. But where there are the really high risk things, let's spend a little bit of time looking at those and make sure that those are correct. I looked at, I should point out that probably fewer than 10 years ago, I was not really a believer in the agile methodologies and DevOps and DevSecOps, but I did a review at one of my client sites, a large insurance company, and they had software developers at their headquarters element that were very much following old school waterfall-like processes. And they had acquired a smaller company a few miles away, and those guys were all about agile. And I spent 2 days with that team looking at how they're developing their code. And I walked out of there a believer, because the difference in innovation and enthusiasm and the results they were getting between those two organizations, I hope that small little agile island is affecting the headquarters waterfall folks in a big way, because they were really putting out some neat stuff.
Certainly, yeah, we're big believers in fail fast. So, but with threat modeling, it's not a bolt-on at the end, right?
No.
This is pre-planning phases of your agile development.
That's a good question too, because you can do the threat model in different areas of your development process. So if you're following the standard sort of infinity model of our DevSecOps, you want to put threat modeling in one place where you're reviewing designs, but you're iterating, so you're coming back to that frequently. But you can do that early on, thinking a big picture now. You can do it early on in a project or later on. I've done threat models of applications that are in production and just going through the barest of maintenance cycles. And there's still been value to doing that, because you end up finding things that you might not have thought about before, or not really focused critical attention on. And so it's not just an add-on for me. We can do that anytime we want throughout the process, and you can still find value in that. I'm a huge believer in that.
Certainly. Let's see if we have any more questions. We don't, not yet. I have another one, since I got you for another couple minutes. So with the latest vulnerability that's hit us lately, can you maybe give some insight into the kind of modeling that might have helped this, the area of focus here?
Yeah, so that's a really good question. Should threat modeling have found this Log4j vulnerability prior to the world finding it last week or so? That's a really good question, and I don't think that threat modeling would likely have found that. But some of the discussions around sensitive information and such, because in the Log4j engine, you put specific strings in there, encoded or otherwise, but you put specific strings in there, and you get the Log4j system to misbehave in spectacular ways. We'll leave it at that. But so it's a data validation issue. It is a data interpretation issue. It is what you do with that data in the Log4j engine. There's all sorts of things going on there. Would those have been discussed in a threat model? So I don't honestly know if they would have. Where you might have focused some attention to Log4j in a threat model wouldn't have been, oh, we log that stuff, right? So it might have been in discussing the sensitivity of your security logs. You could say, okay, we're logging everything. The SOC is reviewing that stuff. In my threat model, I probably would have spent some time thinking about, let's talk about the logs themselves. How are those logs being encrypted in transit? How are they being stored in the SOC environment? Are they being encrypted? Are they being archived? Are we using those logs potentially later on for evidence? And if so, how are we protecting that potential evidence from being tampered with? Would we have considered unexpected features like JNDI in there? Probably not. So let's be honest, what we can and cannot accomplish with threat modeling, we're looking at intentional design issues. This was a very much an unintentional feature of Log4j, and it probably wouldn't have come to the surface during a threat model. So being completely candid and open, I would have been surprised if anybody had ever found this through threat modeling.
Certainly, thanks for your insights. I do think we'll be looking at that, though. It'll be a big learning lesson for how we might go about it in the future. But
yeah, without a doubt.
I think we got to wrap up before we go on break. Ken, thanks for your talk. Really appreciate you spending some time with us today.
Thanks for having me. This was great.
All right, with that, we will go on break. Thank you.
we see many different type of implementation in terms of DevSecOps practices and in terms of the different understanding, as this subgroup is really helping the common understanding of what the DevSecOps culture should be in the DoD context, like maybe describing the playbooks, describing the framework, describing the vocabularies, describing acquisition perspective, and it is giving a guidance to the rest of the DoD, follow it. Remember that the software factory concept we discussed, we are looking for the same practice, the same process, a different implementation. This is exactly DoD DevSecOps working group we would like to do, which is doing it already. There's already, we can post the URL into the YouTube channel, and people can download the latest version of DevSecOps framework and playbook and some other guidance that come from the US CSO Air Force as well. It's going to help us to understand what the commonalities of building up a continuous improvement, what the key capabilities are. You're looking forward to what the DevSecOps pipeline means, what the continuous integration means, what the continuous authorization means. So it's going to describe the vocabularies and describe the common understanding, and also giving some reference architecture. Let's say you would like to use the Kubernetes and Docker, here's a reference architecture for you as an organization. You can follow that reference architecture, build up your own Kubernetes container-based DevSecOps environment. And then another things also, it's important to mention here, Shane, and a little bit about the container as well. It's also offering hardened containers, so rest of the DoD folks can use the hardened containers. What really means, and in the DoD context, we always would like to have an approval for the software. Without having an approval, none of the software and system will go into the production environment. It is requiring authority to operate, which is AO, and then we are adding a continuous ATO. So continuous ATO, authorized to operate, is continuously requiring a constant evaluation, constant check of the libraries, dependencies, application with respect to security. What the DoD DevSecOps initiatives is really building as hardened containers. The hardened containers has already approved dependencies libraries for one of the modules that developer might be using it. That module can be a Node.js, can be one of the pipeline component, can be a GitLab, can be a Jenkins, maybe data science using some Jupyter, some other tools, has approved already in the available public platform. And then people in the DoD users, they can pull that libraries from the common portals and use in their application context. We can cut the reapproval process in our approval component. So we can use the approved containers to speed up our approval process so we can go faster. So that's another thing as the DoD DevSecOps initiatives is helping. There are many other activities as well as part of this group. And there is embedded software development group is happening right now. We haven't really published as yet every output, so still is building up. How can I use the embedded software development DevSecOps context? And there's another studies happening as part of DevSecOps group. It's about digital engineering. And there's another connectivity between digital engineering and DevSecOps. I think there's a webinar we did a couple months ago. And there is a direct connectivity. How we're setting up our digital engineering ecosystems on a software pipeline, which is DevSecOps pipeline. We can go back and use in the digital engineering concept using a source of truth. Other component will be part of it. So it is giving a good guidance and DoD. At the same time, a lot of industry folks also using that. How can I use a typical DevSecOps framework in a highly regulated environments, like the health industry or the finance industry are good examples of consumers of the DoD built DevSecOps framework.
Hello, this is Doug Reynolds. We're back with our next session. I'll be your moderator. I'm going to introduce our next speaker. His name is Kayra Otaner, and he's the director of DevSecOps of ADP. And he has a lot of experience with different things like PCI, SOX. He's a Linux fan for sure, and also has a lot of experience in the DevSecOps world as well. He's going to be talking about DevSecOps lessons learned from the COVID-19 era, which I'm sure most of us can associate with that in some aspect, because it's been a definite change for a lot of folks. And I will let Kayra take it away, and you can kind of give us a little bit more intro on his presentation.
Hi, everyone. This is one of the first events that I'm attending in last 2 years or so. I have been attending a lot of meetups, and it's very hard to do presentations when you're not looking at people's eyes or faces, but I'm going to try to do my best. So thank you for attending this event. I do not see your faces or your names, but I'm hoping that you're going to enjoy this event. So we're going to talk about DevSecOps lessons that we are still like learning from the pandemic that we are all in. Let me just start by introducing myself very quickly. As Doug mentioned, I'm a Linux fan. Have been with a lot of enterprises in fintech space, mostly WPP, FICO, and more recently I joined ADP as director of DevSecOps. And I happen to write very first MySQL and PHP book in Turkish. As you might not know, I'm from Turkey. I also helped Turkish Navy to develop their cybersecurity solution that competed in Lock Shield in Estonia in 2016. I have been delivering speeches on DevOps and DevSecOps. You can see the list over here. I don't want to go into too deep into that discussion. And to be frank with you, most of my talks are mostly technical. I talk about honeypots, full packet capture, network situation awareness, mostly zero trust, and all the stuff that happens in cloud infrastructures. Today, I'm going to be sharing some fascinating observations that I've been making since COVID-19 started back in January of last year, and I hope you will find them interesting as well. So high-level goals of this talk. You might say again, like, we don't want to talk about COVID-19 anymore. Even in DevSecOps, we still get to hear COVID-19, but I guess you're really going to find that interesting. The first half of this presentation is we're going to talk about what pandemic taught us in general, and what we can learn from pandemic approach to improve DevSecOps culture. As you know, you guys are attending this conference. It's a big moment, big pattern, big movement, hopefully that is shaping our cybersecurity in general. So let me start with COVID-19 timeline. There is a web page at cdc.gov /museum timeline. The URL is listed over here. Most likely you guys are going to see this on the PDF file when I share this. It lists I'm looking at the major events, timeline of major events that happened last year. December 12th of 2019 is the very first patient, right? January 29, White House Coronavirus Task Force is formed. And March 11, World Health Organization declares it as a pandemic, right? February 4th, FDA approves first diagnostics tests. May 1st, FDA approves remdesivir for treatment, right? And December 11 of 2020, almost like a day short of a year, FDA approves very first vaccine, Pfizer. And this is an official info. You can see that on cdc.gov. So when you look at COVID-19 and change it with log4shell timeline, which only became visible last Friday, or actually last Thursday, we have been fighting that pandemic since last Thursday or Friday. You're going to immediately see that a lot of similarities between a vulnerability exposure and a pandemic track, right? The first disclosure of the vulnerability, what sometimes we call it 0 day, right? And then the next step is typically a creation of a task force to understand the coordinate efforts. These are typically like a research post, a blog post, or a Twitter message that starts talking about that, and you start focusing on this. And MITRE or MVD or some other vendor assigns a CVE, Common Vulnerability Exposure ID, to the problem, just like, you know, World Health Organization says it's a pandemic, right? There's an assignment of an official ID authorized by a higher authority, right? And we start seeing that, you know, after assignment of an ID, some vulnerability scanners having the signatures to detect that from outside or from within the server itself. So that is a testing phase, just as we have seen in the FDA approving first diagnostics test. So if you'll start mapping those, first patient goes to first disclosure of vulnerability. If you map World Health Task Force, White House Task Force to a blog post, you can also map pandemic declaration of WHO to a mapping of MITRE's assignment of CVID. You can also map diagnostics test to vulnerability assessments for signatures for you know, easy detection. And you see a release patch, which is the first treatment option, right? Officially released by a vendor or some other hot fixes. And then you have a permanent, semi-permanent solution, the vaccine, that is always typically in the form of a method, a pattern that gets deployed to prevent similar vulnerabilities if possible. So the vaccines are not 100% accurate. As you know, COVID-19 is 95%. As far as I know, Pfizer vaccine is on 94, 95% accurate. The methods patterns are also like similar. So a lot of similarities between a pandemic and, you know, a vulnerability tracking in our, you know, cybersecurity space. And if you start looking at what COVID-19 introduced to our lives, we see that, you know, CDC and Fauci, right? The terms or concepts that has been introduced. We have silent spreader. These are interesting concepts. People without symptoms but still spreading. Social distancing, contact tracing, and I'm going to add herd immunity to this. It's one of the slides. These are all individual slides. These are individually introduced concept that wasn't in our life before, and it's easy to see that, you know, World Health Organization maps to MITRE, right? Even their websites kind of look alike, like NVD or MITRE. Their websites look alike, and they do perform the same function. They organize, coordinate all the vulnerability tracking and remediation tracking or advices, you know, provided by them. So CDC maps perfectly to MITRE or NVD. If you go to the next slide, we have an interesting concept, silent spreader, right? The silent spreader term, that I wasn't aware of this term before, is for people without symptoms, but still spreading in a lot of ways. It looks like vulnerability, but not exploitable system. So we do not treat or cure people that doesn't have COVID-19 symptoms, but we ask them to isolate themselves, right? So you might have the virus, you might be carrying that virus, but no symptoms, no fever, whatever. So in DevSecOps, we have almost the same. We have, just because you have a vulnerability found on a system, this doesn't mean that it's exploitable, right? We just need to treat or cure that system, but more important than that, we need to isolate that system so that it's not easy to access. So putting in a micro core, micro perimeter, a container solution, properly container solution makes sense. So we should treat certain vulnerabilities in certain systems as a silent spreader. So we didn't have that term, but it kind of makes one-to-one mapping. And when you look at from the COVID-19 exposure or terms, it is easy to map. And we also have another concept introduced to our lives, social distancing, right? So it's a practice of keeping distance between yourself and people that you don't live with. So it doesn't completely prevent spread of the virus, but it makes it very hard to jump from one person to another. And the first sentences of these things are what I've copied from cdc.gov or some other official site. So these are not something that I made up personally. So in DevSecOps context, this is simply using containers, because containers provide a bubble, right? Process isolation, Linux namespaces, and it's around each app. So it is not easy to access when properly configured from outside. Containers make lateral movement very hard for attackers, right? So it's like a bubble and you keep distance from others by putting a micro firewalls per se around each container once properly tuned, right? So it is social distancing that what we are doing in containerized spaces, right? That's also very good mapping. You know, from the beginning of the pandemic, you know, what we have been observing is like we are trying to prevent COVID-19 spread, right? That has been the biggest challenge. How do we prevent? You know, we know that we cannot kill the virus yet. It's gonna stay. We cannot kill it by, say, injecting disinfectants, but treatment efforts to cure people also not efficient, right? We have a lot of efforts, but not 100% accurate. So if you look at preventing COVID-19 spread, you will going to see three major actors. We have the virus, we have the victim or patient, and the spreaders, right? Once you start mapping COVID-19 actors to cybersecurity space, virus is a vulnerability, right? The computer vulnerabilities are behaving like very much like viruses themselves. And the patients who got sick because of the vulnerability typically comes in the form of a VM or firmware, and now in DevSecOps space, let's say they are Docker containers, right? So you have a virus, a vulnerability that you built, you have some sort of spreading actor spreading that to a container, right? So it is easy to see and map these two concepts very easy. But what about spreaders? You know, the spreaders does not easily come to the picture unless you change the spreader with the developers, right? Developers are the actors who spread the vulnerabilities into the containers, right? Once you look at the picture, the three actors, the preventing COVID-19 spread becomes securing your software supply chain, because we want to prevent the spread of the virus. Your software supply chain have a lot of actors, first-party code, third-party code, operating systems, etc. They might become vulnerable. You have a developer typically bundling things together, right, and creating an artifacts. So from secure software supply chain, there are so many correlations can be drawn from this conversation. And another interesting concept that this is actually where it all starts getting more interesting. So contact tracing, I never heard of this term before COVID, is in public health. Contact tracing is a process of identifying persons who may have come into contact with an infected person, but a subsequent collection of further information about these contacts. When you look at contact tracing, right, we do perform guiltless tracing. So you might be responsible for bringing a virus to your school, to the office, and God forbid, you might be indirectly responsible for some people getting sick, hospitalized, and worse, right? But we do not blame people for bringing the virus to the workspace or office, because they are also victims, right? We have guiltless tracing. We do not blame them, and authorities do not track people to prevent further spread of the virus. But we are only interested. They are not interested in charging people for careless sneezing, right? You might be sneezing and causing sickness all across your department or company, but because you are both victim and the cause of this virus, spread of this virus, no one blames you. At least that's my personal observation. You're not getting blamed. I never exposed to virus. I had so many friends got exposed to virus, and we never knew who brought that virus in, but we had suspicions, but we never blame or look with the different eyes. So when we talk about tracking movements or a behavior of a spread, and when we try to bring this conversation to the developers, saying that we want to track you guys for introducing vulnerabilities to our infrastructure, introducing vulnerabilities to our applications, there is a negative sentiment in a lot of other avenues of life. So you might be a bad driver, you might be responsible for like traffic accidents and whatnot. Your driver ID is tracked, and you get points, or your insurance premium goes higher or lower based on how safe driver you are. And same goes with the use of credit card numbers. You might be financially irresponsible, and might cause getting mortgages and not pay them back enough, so that you might be indirectly responsible for real estate market to collapse or other major events. But we do track these kind of habits or behaviors in real life with the drivers and the credit card usage, and it affects the individual who is being tracked in a negative way. But we do not see that with COVID-19. You are not officially tracked and you are not officially responsible because you are also the victim, right? So that is one of the interesting observations that we have been doing, because when you look at DevSecOps, right? We always talk about like shifting left, make the testing earlier. You have to test security tests, scan your application earlier when it's on the dev environment, or even on your local environment. Actually, shifting left means focusing on developer, because that is the actor that brings the vulnerability as a human. And we can do this in a guiltless fashion. We do not have to mark people with this, scars saying that you brought this log4j vulnerability to our infrastructure. You did, cause this SQL injection, our first-party code. You are responsible for our data leakage. We do not do that. We do not have to do that, because it is mainly the nature of the business and the vulnerability itself that makes you sick, and also you spread it. So what we have started talking about in a lot of companies, and in my current position as well, we started looking at some interesting KPIs, right? By looking at the SCM, source control management tools, we can track how many commits are made per developer, right? That data is already available if you are using GitLab, Bitbucket, whatever the tool you are using, or GitHub. How many lines of code change per developer? How many third-party vulnerabilities are there on a separate system on that application repository, mostly using SAST tooling or SCA tooling? How many third-party vulnerabilities are there, right, in that repository, and we can map that to the developer? How many first-party vulnerabilities? That is, these are the ones that are specific to your source code, not coming from a third party, that like SQL injection, input validation, all those OWASP top 10 type of stuff that you can only detect if you are using proper SAST tooling. And we can also look at the change boundary, how many vulnerabilities that was there yesterday versus today, divided by how many commits were done yesterday and today. All these KPIs is very similar to all this spread of the virus, like how many people got infected, how many people spread per person, how many people got sick per million, and all those metrics that we have been following on COVID-19 related information sites. We have mapped most of them to these following KPIs. So one interesting angle on this COVID-19 fight that we are all in is that unfortunately in US, here in US, we have 800 people as of December 12th has died. In China, it's around 4,000 people, right? It's officially listed on the website. And some of these numbers are not reliable. I'm not saying that 4,000 is the real number, but they attacked this problem with a survivalist approach. They locked their doors down. They were very agile in preventing the very first bomb area, when the very first immediate area that was being observed, right? And unfortunately, just because if you have looked at all those other things that I've tried to map, unless we take survivalist approach to this vulnerability problem, this is not a winnable war. We will end up having 800,000 casualties in cybersecurity space if we do not treat vulnerabilities in with proper perspective. Like, mandatory COVID test for all international travelers is like software bill of materials for first and third party code. You have to ask every single application to have that. You have to have SBOM. We need to know the software composition analysis of all applications, both first party and third party. That's testing, right? It's mandatory, right? You cannot travel from anywhere to anywhere. You cannot even fly to Hawaii, which is a state, right? They treat you as if you're an international traveler. Social distancing, right? Containers and DIE. I'm not sure if you heard of the term DIE, and that is distributable, immutable, and ephemeral operating system underneath. We have to have everything containerized or converted to DIE to make that social distancing real. These layers, once you add them up, is what is making our COVID-19 fight winnable, right? But like COVID vaccine for non-citizens is a mandatory thing, as far as I know. If you're coming from another country, if you're not a US citizen, you have to have the vaccine. You know, you cannot mandate vaccines to your citizens here in the States, but you can ask non-citizens to do that. So it's like mandatory SBOM for all third-party codes. So we know you are well protected. We know way in advance, before even you take the flight in, coming from Europe, coming from other places to States, you have to have SBOM. We cannot let that sneak through, right? It is mandatory. Contract tracing, right? Which is the major theme that I'm trying to make over here. You want to cross-reference commits with vulnerabilities that are introduced in first and third-party code to developers. That is what we should be focusing on. Developers has to be in the focus. That is what proper shift left says. Without contact tracing, the spread of the virus is going to stay, right? We cannot control the area that, if you do not track when that vulnerability was introduced, when was it deployed, and who introduced it, what other repositories that he might also like the same framework or logic that he or she has typed in the code. That's very important. And this has come to my attention only today, and I wasn't able to map it properly. Herd immunity, right? So if you look at this slide, I'm not seeing your face, but it's very funny that someone tweeted about this yesterday, a couple of days ago, that we don't need everyone to upgrade log4j, just enough for herd immunity to take over. And you know, it depicts, even in a joke, kidding aside, you know, it is a very important point that a lot of similarities are out there between the viruses, pandemics, and vulnerabilities, and how we are approaching to that problem. So we have to have herd, you know, we have to have a lot of other things looked at with the same perspective and same angle. So, and ultimately we have a contact tracing problem, right? WHO and CDC maps the MVD, National Vulnerability Database, and MITRE. Diagnostics tests like Nessus, OpenVAS, OVAL-based tools, they are all there. Genetic testing looks like, you know, SAST, because you're looking into your DNA. If you're vulnerable, if you are, you know, possibly you got infected, like your application's DNA is in the static application testing, you reveal that over there with SCA tools like Checkmark, SonarQube, X-ray, whatever, 3V, Anchor, and these are very good tools, by the way. COVID testing and vaccine requirements together is zero trust. We are not just asking people to the COVID testing. We also ask people to vaccine if they are coming from international travel. That is zero trust. We do trust but verify. We did do trust but verify before, but since 2013 or so, we have zero trust. That means we do not rely on just testing or just vaccine. We have to do both. That's very important. Zero trust meaning not doing one thing, doing all of whatever you can to prevent that happening. Contact tracing is shifting left to directed to the developer directly. So that's the end of my presentation. Any questions? I guess we are quick, or we are not quick.
Oh, I think we're good in time here. I don't think we have any questions yet, but I have a couple things. So we see this word zero trust being kicked around a lot, and can you throw us out and let everybody know what zero trust is for folks who aren't familiar with the term? Because it's not a new term, but it seems like the last 6 months everybody's been zero trust this, zero trust that, and not everybody probably knows what that is. So maybe you can elaborate on that a little bit.
Yeah, I mean, zero trust, I don't have that in my slides right now, but if you think in very simple terms, the outside of a firewall is typically said untrust. And underneath the firewall, if you look at the network diagrams, you see the trust. You know, the firewall interfaces have trust interface and untrust interfaces. That is, inside you are trusted, you should be safe, and outside you should not be feeling safe because that's outside, that's public internet and whatnot. That network diagram since 2013, and that's what happened with the NIST asked, I forgot the name of the company, to come up with a better approach to this problem, this cybersecurity problem. They said we should not have any trust zones. Trust zones should not be even you're inside your behind your firewall, you should not treat anything inside your firewall as trustable or trust zone. That's when people start talking about we should trust but verify, which is like saying, right, in English. But then in recent years, we start saying focus on zero trust, treat everything inside as if also they are compromised. Because what happens is you have Log4j your infrastructure that is behind your firewall. You think that it's safe, that no one can gain easy access to it. But what happens if someone brings their own device or a MacBook or a Windows environment gets infected, and they're already behind your firewall, and they will going to be easily do really lateral movements, jumping from one host to another, and because you are treating them as trustable, you miss that's a blind spot, right? Zero trust kind of creates micro firewalls around every single thing, every single application, which is why we talk about the containerization, proper tuning of those containerized environments, proper tuning of the OSs underneath those containers. So technically speaking, that's a game changer, but it's not easy to implement because as humans, we tend to trust things, right, in life. But that's another lesson that we should learn from the COVID-19. We do not even trust our teachers or coworkers, and we want them to wear a mask, right? I know you as a person, but I do not trust you. You might unknowingly get the COVID-19. You have to wear a mask, right? You have to wear a mask all the time so that, I do not spread the virus unintentionally, or I do not get sick because you're not wearing a mask. So
yeah,
mask might be a good candidate for a zero trust mapping.
Yes, that's a good model. Yeah, the zero trust is becoming much more important because a lot of folks think that, oh, I'm behind a firewall, everything's good and everything's safe. But in all actuality, that you're just one wrong move away from not being safe and having your data exposed. And folks sometimes have a hard time, conceptualizing that, considering, how technology's moved in the past couple of years. And the SBOM, the software bill of materials, is another good concept because that's a lot of people that's really starting to be aware of that because, hey, what are things made out of? So once you do have a software bill of materials, like how are people tracking that to make sure that when they do have like a Log4j, they can easily find out what tools and software, has that problem? Is there tools or spreadsheets, or what sort of things are people liking?
There are a lot of interesting open source projects out there that you can easily deploy them. I can give you a couple names. Cyclone DX is a SBOM specification. We prefer Cyclone DX over other specification, and Cyclone DX can be used, or these are all open source, by the way. Dependency track. It's a tool that you can upload your Cyclone DX files to see which application versions you have throughout your enterprise, throughout your organization. And we have Heimdall from Mitra organization, HDF. Heimdall has a UI that you can also compare your findings, that is the software composition analysis shows your applications and their third-party or first-party dependencies versions, and you map them to a vulnerability if they are vulnerable, and then map them to an NIST controls. Heimdall is another nice tool that you might be able to use. But one of the biggest problems in Java space is some of the most commonly used package managers, Maven and Gradle specifically, by default do not track their third children or grandchildren dependencies in a log file, right?
Yes.
So it is not easy to find the children, grandchildren, or even like grandchildren dependencies by looking at the file. So you have to build applications, pull those live dependencies in, and look at the artifact. Then SBOM becomes SCA because software composition analysis looks at the artifact that is compiled, and it is not always reliable, just like COVID-19 testing. So SBOM is more accurate. You have to upgrade your Java applications to use the proper children, grandchildren versioning so that you have much more accurate first-party and third-party data right off the bat.
All right. Well, I think we're out of time right now, but it was really good to hear your talk on comparisons. There's a lot of good info in there, and you have your contact up on the screen. So I appreciate the time and your presentation you've given us. And I think we're getting ready to head for a short break until we're back with the next person. So thank you very much, Kayra. Appreciate your talk.
Thank you for your time.
You too.
So the software factory is not a new term. That came about 1971-ish, like when we are building up our softwares, when we are writing a code. So software factory is going to help us, or as a concept, as an umbrella, and we may use the multiple pipelines. Right here, we have a multiple pipelines that we can edit, so we can produce a software, or we can produce a system. So let's a little bit open up here. Just going to come back shortly. So you may have software factory here. So you may have various software delivery environment. You may call it DevSecOps environment. Let's make it a bit shorter so we can make the graphic better. We may have a DevSecOps environment here. We may have another DevSecOps environment here, and then here. Because each of this pipeline that you are building has a specific requirements for the system, maybe the components that you are building. Maybe you are building some of API here. You may have some other complete system probably you're building. So the combination of the multiple pipelines is constructed and building a software factories. So software factory will help us use the same practices. This is important. We're using the same practices, same process. Like process are, we have to check in, check out, we have to connect it, we have to create an issue tracking, we have to create a case, we have to create a commit message. These are the more about practices and process. But however, we may be using a different tools to establish that, because DevSecOps pipeline sometimes depends on technology we are using. Like one example, C++ build process is different than packaging a Java code. You need a different type of build agents to build up the C++ code versus packaging about the Java libraries, differences. So still we are building a software, but because of the component has a different needs, we may have a different pipeline. So software factory consists of multiple pipelines, but enabling using the same practices and same process. As an organization, we can do. One quick example, going back to the first question again, because it's hurting us. It's hurting us specifically. If I don't have a good practice of getting the libraries, it is more organizational policies, more organization practices. As an organization, we should help or guide the developer pull the libraries properly from open source, or manage the artifact catalog in an organization. We can use it over and over again in the pipeline, which is a practice. Or if I'm writing any type of stories, it doesn't matter what type of tool you might be using it, think about the security knowledge at the beginning, and then organizational policies, organization practices. So software factory is the combination of multiple pipelines, and letting us use the same process and practices. We can deliver an applications, or we can deliver apps as a result of these combinations. So single DevSecOps pipeline is not. One quick example here before going to the next question, like AWS or Amazon, they have hundreds of pipelines. Hundreds of pipelines. They design the pipeline for a specific needs. Maybe they're creating one of the microservices, they might be creating the pipeline. So technically, like Google or Amazon, there's a typical software factory they are talking, building a software. But say they're using the same practice. If you look at that, Google has a good software engineering practices everybody's following. It is not a Wild West, everybody can do different things. No, use the same practices, process and practices, we can deliver that. Actually, a definition of DevOps is also a set of principles and practices that enable Dev and Ops, including other stakeholders. This is a quick definition. It's going to tell us again, set of practices and process, such as continuous integration, such as continuous delivery, such as continuous feedback, IAC. These are the common principles.
Hello, everyone. So we are back again into the DevSecOps days and events. So we are the next session, which is kind of between lunch and important topics. So we'll be talking about the threat modeling for agility and business value with DevSecOps. This is actually about the 2.5 years of study, and we work as a team together to build up the maturity model, the threat modeling concept, and how it is going to work out, what the concepts are, what the components are. So we will be talking about today with the panel members and Simone, Lotfi, and Arun, and also Altaz. And we were talking about how can we use the threat modeling agility business value with the DevSecOps context. Because there was another talk happened this morning as well, how it is really important, what is important with DevSecOps capabilities. Actually, one talk was very interesting with that topic. And he said, if I'm going to do the single things in my career, he had a long history about the software engineering and security domain. He said, I would like to threat model as one thing. If I'm going to read it again, I will threat model it. But there are a lot of challenges we'll be talking today, how we can do the threat modeling with the concept of agility, what the value it is for the business value, what the value is about agility, how can we tie together under DevSecOps and make it more actionable content. So without further ado, I would like to hand over to the Altaz, and he's going to run the show, and then we're going to discuss an overall threat modeling DevSecOps. Altaz?
Wonderful. Thank you very much, Hasan. I appreciate it. And thanks everyone for participating in the presentation today as well. Please keep the questions coming. This is a community effort, and it represents our own retrospective that we conducted in the area of threat modeling. So I think initially it would make sense for us to introduce ourselves, tell us a little bit about who we are. So Simone, if you want to go first, and then we'll go right down through the slide.
Thank you very much, Altaz, and welcome to everyone, and thank you for having us. I'm Simone Curzi, a principal consultant from Microsoft Services. I'm also the author of a tool on threat modeling, and yeah, threat modeling is definitely my passion. So, thank you.
Lotfi?
Thank you, Altaz, and thank you, Hasan, for the invitation. I'm pleased to be here today and talk. My name is Lotfi Ben Othmane, and I work as assistant teaching professor at Iowa State University. I teach software engineering and software security, and threat modeling is one of my passions. So one of the topics that I have been doing research on for a few years. So I will be pleased to share some of the knowledge that I have today.
Wonderful. Arun?
Hey, hi, hello everyone. I'm Arun. I'm a senior consultant at Security Compass. I primarily focus on product security and DevSecOps. And yes, today the talk is about threat modeling with DevSecOps. I'm very excited to talk about this along with the other experts in the panel.
Thanks, Arun. And I'm Altaz. Just my role at Security Compass is Director of Insights Research, where I focus extensively on collaborations and participating with folks in the industry and in academia to try to push the bounds of security and to address emerging issues that are coming out. Please feel free. This is a community effort. You're welcome to reach out to us. We've got profiles on LinkedIn. Don't hesitate. If you want to come in, participate, help us create something together collectively, it's all good. And we can continue to do things that help us make this world a better place from a security perspective. A little bit about the agenda today. We're going to start first by talking about the landscape of threat modeling. Where are we today? And then we'll go in and talk a bit about the current challenges with threat modeling. Where do we see gaps? What are the challenges facing practitioners in this space? And then we'll talk about evolving threat modeling. How do we fill in some of these gaps? Where do we see threat modeling headed in the future? And then we'll talk about some next steps as well. For those of you that might be interested, we do have the white paper that we have created. You can download it for free at the link below. So you can view it in the recording. You can view the presentation after. Feel free. We invite you to come in and offer your thoughts and your feedback. Again, anything that we can do to continue to improve this would certainly be a good thing from our perspective. So let's first of all talk about the different perspectives of threat modeling. Arun, you want to talk a little bit about this?
Right. So thanks, Altaz. So these slide talks about the different perspectives in threat modeling, the different approaches that are taken by the threat modelers when it comes to implementing the threat modeling activity. There are a bunch of different categories that we have put up over here, the methodologies, approaches, what are all the different implementation techniques. So we look at each one of them. So at first, like there are different methodologies for doing the threat modeling. The STRIDE is one of them, which is has been followed predominantly by a lot of threat modelers today. PASTA is one among them. There is also this concept of attractories. So if you look at these methodologies, they primarily give directions to the threat modelers on how to go about enumerating the different threats in the application, or for that matter, the product which they are doing the threat modeling for. The threat modelers primarily try to get a lot of these security principles from these methodologies and try to discover the different threats that are applicable for the application. So the methodologies are primarily going to help from that perspective. When it comes to the implementation techniques, there are a good bunch of tools that do the threat modeling today, and they automate some of the important steps in the threat modeling activity. There are, this concept of diagramming is another implementation techniques. There is a possibility where like the threat modelers could actually put up the different blocks in the architecture, different components in the architecture, try to understand the data flow and try to discover the different abuse cases as it applies to the design. So these are some of the implementation techniques that the threat modelers will have to look into. And another thing that's happening today is like the different approaches. People or the threat modelers try to discover the threat from an adversary's point of view, the attacker's point of view. What are the different entry points in the application? Can I try to hack into the application? So looking at things from the adversary's point of view is going to help the threat modelers come up with the different threats. These are some of the approaches, but one of the things that is coming up and becoming very popular today is the developer-centric approach, where the security professionals doing threat modeling are looking at things from the developer's perspective, as in like one of the key thing that's coming out of the threat modeling is the remediations that are being suggested, right? So threat modelers try to see if the remediations that are being recommended are practically actionable or not. So looking at the things from the developer standpoint is another approach with threat modelers are taking these days. And finally, there is also the outcome. So one of the key outcome from the threat modeling is, of course, the different threats that are coming up. But people are also trying to look at threat modeling from the perspective of how it adheres to the regulation, whether it is in compliance to some of the best practices, standards, the regulatory requirements or not. So this is also one of the approach that people are looking into. Managing the risk. It's not about just giving the threats and then do and deliver and go, but it's also about whether the risk is being addressed or not, whether the risk is also being ignored or is it being transferred to a third party. These are some of the different outcomes which people are looking at these days. So if you see the different perspectives, a threat modeler will have to consider many methodologies. They will have to think about different implementation techniques. There are many different approaches which threat modelers will have to follow. So if someone who is actually new to the game, or if someone is trying to approach threat modeling from this perspective, what is the best approach for them? I would suggest the best approach completely depends on the scenario, the complexity of the scenario, the different type of solutions that you are dealing with, which is exactly what we are going to talk in our next slide.
Great, sounds good. So you've kind of set us up here, Arun, to talk about the different perspectives. Many times we find people getting caught up in, we have to use one specific methodology. Well, what about implementation? What about the approach? What about the outcomes? These are all things that need to come into play as we consider threat modeling. So now kind of looking at it, even the application space itself has evolved. And there's been an impact on that from the perspective of threat modeling. Lotfi, can you talk a little bit about this slide here?
Thank you, Altaz. Indeed, applications have evolved over the years, and that evolution should have impacted the threat modeling knowledge base. So back in 2000, with the evolution of the internet, we started developing web application. These web applications, they expose the network of the companies or of the organization. And a security expert at that time, for example, Schneider's and Stack, they started developing, they worked on methods for threat modeling, for identifying the threats to these systems, and how actually it is possible, how is it possible to mitigate the threats. So as a community, we worked with these methods but the applications have evolved from a web application to a cyber physical system with the connection of physical systems to the internet. Like, for example, here, the smart city connecting the traffic lights to a cyber system made also opened those systems to new attacks, and that almost around 2010 we started seeing this problem. Now, doing threat modeling for cyber physical system may not be the same as doing threat modeling for web application. And especially here, we talk about what type of threats should we consider and should we address. Because for the case of web application, we might mostly focus on data and processes. Now the focus is on, if you have a smart grid, you don't want the attacker to do anything bad with it. If we are talking about connected vehicles, we don't want the attacker to take control of the car. So we don't care whether the attacker, they know the data exchanged between the different components of the car, but we care that they are not going to cause an accident. So the application domain evolved, and now with this new era, we see that we have a lot of sensors and drones that take pictures, sensors that take data. And we started using machine learning to infer knowledge out of these sensors and out of these data. Also, with the evolution now of brain waves, so project like Elon Musk and so on, we're going to put those microcontrollers on the brain. And are we ready to do threat modeling for systems that are going to start now talking with our own bodies, our own reasoning? So talking about machine learning, the evolution of 2020 and application 2020 and the use of machine learning, we're going to see in the future the real artificial intelligence application where automated systems are going to collect knowledge, but also are going to act in the environment. And it is important to think whether the knowledge, the threat modeling knowledge base, threat modeling techniques that we have back in 2000 and that has been evolving, is it ready to identify the threats that we need to consider when designing and developing these kind of systems.
Great, thanks, Lotfi. So we've talked initially about just the context, what are the different perspectives of threat modeling, and now we've talked about the evolution of our applications, and what does that mean from a threat modeling standpoint. It would be great if we could just dive in now into what are some of the biggest challenges, the biggest pain points that we see with our traditional approaches to threat modeling. Lotfi, you want to just carry on your discussion and talk a bit about this?
Yes, thank you, Altaz. So now with the complexity of application and the size of application, as a community, we started to rely more on automated tools to identify information for threat modeling. Also, the threat modeling that we have so far, they are the approaches, they are siloed approaches. In addition, we often rely only on diagrams to do threat modeling. So So as experts, probably you're gonna meet with people who use the application, then design a given system, and then you extract information, and then you draw diagrams that show the flow of information, the flow of data, and that diagrams would be used to identify the threats and to identify the countermeasure. But obviously, these diagrams are not sufficient simply for example, social networking threats. So there are a lot of threats that you would not know, though we would not identify them using the diagrams. Also, the processes, they are kind of the processes that we would use for threat modeling, they are kind of static. But the development processes that developers use today are often agile, and people need to push their application probably every day. That is common, but let's say a few times a day. Would it be possible to do threat modeling for these different versions? The next pain point is, so far we do threat modeling at the beginning of the process, of the development process, or at a stage of the development where the stakeholders might see challenges, security challenges, and they would need to do the threat modeling. They would ask for threat modeling. The threat modeling at that, if it is done once, it is going to focus on the final product. But guys, we are not interested in designing a solution for a final product that is going to be there probably in 5 years. We need to have a threat model for a system of today, for the system of tomorrow, for the system that we're going to deploy in 1 month, and probably for the system also that we might deploy 5 months. Would threat modeling approaches that we have today allow for that? I doubt that we do. The last pain point that, in our opinion, is important is the approach of using a checklist to discover threats. While this approach is great because it allows novice to identify threats, at least they would identify a good number of threats or common number of threats using the questionnaires and so on, it is not sufficient simply because it does not consider known threats. If you go to the previous scenario, back in 2010, we had applications that deal with cyber physical systems. We do not want an attacker to take control of the car, for example. But in 2020, we started having applications that use machine learning, and we started thinking about attacks on how to mislead the machine learning techniques. And in the future, with the age of robotics, with the age of brainwaves and so on, the attacker probably they're going to have a different set of potential threats that they are going to use against AI systems. These threats, they will not be in the checklist. So the checklist is a good approach to start with, but we have to be careful and know that this is not sufficient.
Mm-hmm. So if we look at these biggest pain points with the traditional approaches, then the question becomes, okay, what do we need to do now? What is the desired outcome that we would like to see? Arun, can you speak a little bit about the shift that needs to occur?
For sure. So that's right. I know we have been having a lot of pain points and challenges, and Lotfi mentioned quite a lot of them in the traditional threat modeling. So we see that there is an increasing demand for evolving the threat modeling that we are doing. So the first scenario, if you see over here, primarily talks about many of the projects and products that are developed today are following the Agile and DevOps methodology. So what's happening because of this is that there is a lot of expectation for the teams to work in close collaborations, and the security team is no exception to that. And threat modeling, which is a key activity over there, also expects, it is also expected that the threat modelers will have to work in close collaboration, which means like there is instant feedback that needs to be given by the security team to the developers. that is continuous feedback that the developers would seek for from the security professionals doing the threat modeling. So the close collaboration is an important thing. Now, if you go back to the traditional threat modeling process, we were having a very static process, and it is more like you discover threat first and then do the remedies and then report it. Well, that kind of a process is certainly not going to work. So that is definitely a demand to evolve the threat modeling process according to the DevOps and Agile methodologies. The second one is all about the use of advanced solutions, which we are dealing with in many of the architectures today. And if you see, go back to what Lotfi was talking about, he had a very complex architecture, and it uses a lot of these emerging technologies like the machine learning, the distributed ledgers, that is use of the cloud and mobile platforms. So for these kind of technologies, we cannot still, we cannot definitely apply many of these stride approaches or some of the traditional techniques, implementation techniques that we were following. That is certainly a lot of new threats, different kind of attack patterns that are emerging, which a lot of these adversaries are making use of different kind of exploit methods for getting into these kind of solutions. So traditional approaches and traditional implementation techniques which we were following in the waterfall threat models are certainly not going to help at all, and we need to evolve threat modelings from that perspective. And if you look at the third point, we are dealing with a lot of minimum viable products. That is a lot of periodic releases. What's happening with all of these is that developers have been asked to develop the features faster, and as a result of that, there is a hit on some of the security. So the demand is that we've got to balance both the feature development, and at the same time the security features will also have to be inbuilt into it. We cannot just compromise on the security just because of the go-to-market demands, right? So if you look at the traditional threat modeling process, we do not have a very flexible process that accommodates all this, the concept of balancing the speed and security. So we certainly will have to make the process a lot more flexible, and we got to think of developing a scalable threat model. It's not about you just do it once and then you move on, but it's also about doing it in the first sprint and probably come after a few sprints or come after a few milestones and then doing it again. So the threat modeling process, the activity, they all will have to be very scalable. And if you look at the point number 4, which talks about the key principle of DevSecOps is to codify the security controls. Just like how we have infrastructure as a code, same way we also have to do security as a code, policy as a code, and we have a lot of codifying security requirements in the DevSecOps. Now, what does this mean to threat modeling? This means that the mitigations will be at the core. It will be the key activity that will have to be performed in threat models. If you see the traditional threat modeling, they have been focusing more about discovering the threats. Of course, the remediation was given, but then the key emphasis was given to the threat enumeration, discovering the threats, and all of this. Now, the mitigations will have to be the core activity and the key activity in the threat modeling when it comes to DevSecOps. It means codifying all the security controls, trying to implement authentication as a code, trying to implement authorization as a code. These are some of the key things from a mitigation standpoint, and the threat modeler's job extends to trying to do or recommend mitigations from the codifying security principle perspective. And the last point which you see over here is there are several stakeholders who are interested in the threat modeling activity today. It's just not about threat modeling, is just not about the security person's activity. If you see about a decade ago, a lot of security professionals only talk about threat modeling, and the threat modeling that they talk about wouldn't be focused on many of the important values which are considered by the leadership. So the threat modeling that we do today is something that is deeply looked into by a lot of leadership and other stakeholders like the regulatory auditors, and it goes beyond just the security team. So the focus is just not on threats and controls, it's also on some of the key attributes like the risk, the return on security investments, and importantly, how the threat modeling activity is going to be of how we can establish the value to the business. So those are some of the key things behind threat modeling. And as Lotfi mentioned, we had a lot of pain points in the traditional threat modeling activity, and now we are even seeing the scenarios and the key expectations from the stakeholders on how the threat modeling will have to be improved. What are all the key areas in which like the threat modeling will have to be evolved?
Now this is getting really interesting. So we started talking about the different perspectives. We talked about how applications are shifting and changing. We talked about the challenges with current threat modeling. Now we're starting to look forward a little bit. What are these desired outcomes that we would like to see? And so now the question is, okay, what does effective threat modeling in fact look like? Simone, can you talk a little bit about this?
Absolutely. Really, the topic of making threat modeling effective is extremely important because we have a lot of complexity in our world. We have a lot of different attacks which may happen, and threat modeling as a practice is one of the most expensive because it requires competencies to be put on the table. It requires experts. So how can we make it valuable? How can we increase the return of the investment related to threat modeling? This is really the question that we have nowadays and where we need to spend our thought. So we have identified a few different aspects that we consider as key to achieve this return of the investment, how we can increase the quality of the threat modeling experience. And the first will be the application, the adoption of the threat modeling as an approach involving different types of competencies, different roles, to discuss together a system, to get a better understanding of the system, and to get, therefore, a better quality identification of the potential attacks to that system and how to remediate those attacks. And this analysis needs to be done in a layered way. Why? Because, first of all, you needed to have an overall vision of the system. And this will provide this high-level vision about the system, contributes to provide a holistic view of what happens in the system. And then you go more in depth as you can. Now, there is a typical question. How much security is enough? How much work you should do? Of course, threat modeling is expensive, as already said, and you need to identify the right level of going in depth, because each level that you go deeper will cost more. So what it will provide to you? It will provide more precision. It will provide more threats. But at the end of the day, a lot of value is already identified typically in the first levels. So depending on the type of solution that you have, on the type, on the risk appetite of your organization, you may want to go more or less in depth. And for example, in Microsoft, I can bring some of the experience of my company. You know that we have very different projects and very different type of solutions developed. If you wanted to analyze the security of something like Windows, you will need to perform a very thorough threat model that will require a lot of months of work. But if you have to analyze a very minimal service, something extremely limited, then perhaps an iteration that will require a few hours will be enough. And this is extremely important as a concept. A second aspect is related to threat modeling as an integrated experience. Well, you know, the story of threat modeling in the past, if you think, for example, to Stride, sorry, I keep returning to Microsoft approaches, but this is what I know best. If you consider Stride, this is based on 3 main steps. The first step is to analyze the system, then to identify what are the threats, what are the potential attacks, in other words, on the system, and then what you can do to mitigate the risk over the system. But it stops there. But really, it is only just the start of the analysis. You needed to go much more in that. You needed to select those activities. And we are here because we are talking about DevSecOps, of course. So we should remember that even if you identify mitigation, that activity to be done is nothing up until you put that in the backlog. So the process needs to be integrated. And we are talking not only about the integration with the DevOps systems, issue tracking, and whatever. We are talking also about a much deeper integration with risk management systems, asset management systems, to get information, consume, but also to provide information. What is the residual risk for a solution, for example? That's something that the threat model can provide. And we see really threat modeling as having a very important role in that. Other aspect related to the previous one, so I will not spend much time about this, actionable outcome. If you don't go in depth with the mitigations, describing clearly at the level that they are executable, and you do not make sure that those mitigations that are selected are inserted in the backlog and then prioritized, and then you get feedback, you are not doing anything. So having threat modeling as an experience integrated, focused on the mitigation and their execution, their implementation is a key need nowadays. Threat modeling, we have already anticipated. Arun was saying at the very start, you have different ways to perform that. But a very important concept when you apply that to projects, and again, we are talking the DevSecOps days now, so this is the main focus. You need to ensure that threat modeling is applied during the duration, during your project. And you know, when you analyze a project, when you work on a project, in particular when agile methodologies are applied, you have something that evolves continuously over the various iterations, sprints. So threat modeling must evolve as well. You need to get information about the changes in the design. And when the implementation starts, perhaps you will find the problems. You make the decisions, you go in different directions. Threat model must take care about that, must consider what are the implications and also direct the implementation of the right design of things. So from that point of view, if you think about threat modeling in this view, you will start to think about threat modeling as a design tool for security. And this is really what it is all about. And the last topic is related to value. And Arun finished the previous slide talking about value. And this is really what we think is key. If we don't demonstrate, if we are not able to show, to provide value with threat modeling at each and every phase, essentially we are not doing our job. We need to optimize the value that is provided. And this value must be focused not only on the business stakeholders, but must be focused also on the development team. So we needed to ensure that we are not blocking the business, we are enabling the business, and absolutely threat modeling can and must be that enabler.
Yeah, interesting. So now we've got these principles around effective threat modeling, and it sounds like it really is going to take in some kind of an integrated approach. Can you extend what you were just describing now, Simone, into this integrated threat modeling? You know, what does this all mean? Where is this taking us?
Sure, absolutely. This is our vision, really. Threat modeling, putting threat modeling at the center is already related, and some of the concepts that you see here are obvious. Threat modeling has a strong relationship with security, is born for that purpose. But it can have a strong relationship also with the other activities. Let's consider, for example, operation. A big part of operation is related to understanding what is happening about your solution that is in production. A lot of situation, too many projects I've seen are focused really on the analysis of the events produced by the infrastructure, and that's it. So the infrastructure will provide information, that those events are fed to a SIEM, and then their magic is performed. But what about the applications? What about the situations in which an attacker is trying different payloads, one after the other, and at a certain point manages to compromise your solution? If you don't get those events, if those errors due to the fact that you're receiving things that you are not supposed to receive, and you are not feeding that information, I'm receiving that message that is malformed, then another one, you're not raising events to the SIEM, and the SIEM is not prepared to understand that this is something bad that should raise an alert. Then you're covering only half of the world. So threat modeling can help in this direction. This is just an example of what can do a threat model for operation. The same consideration could be for the system architecture, could be for the culture. System architecture, for example, threat modeling can help to design the right system architecture, can be a designing tool for the enterprise architecture. And also the system architecture, the enterprise architecture, all those can inform the threat model. We can define policies to determine how we need to handle those systems. We needed to manage the solutions in production and so on. For the culture, a very important topic related to that, threat modeling can really change. This is something that I've seen again and again, can change the way we think about threats, about attacks. The main problem with best practices with checklists is that they are focused on mitigations. But why? Why are you doing them? If you don't know why, you may spend your money where it doesn't matter for your solution. You may waste money instead of spending where there is a need. So you need to start from what can go wrong and focus your few resources there. And this is why threat modeling is so important. I've seen security experts I have taught, I have mentored, really changing the way they think about security when they start looking at threat modeling. I could continue for hours. I know that we have a limited time. I just wanted to add a couple of concepts here related to knowledge base. The importance of ensuring that we, as Arun was saying, have knowledge bases that are aligned with the updates on the technology, on the context. They needed to have knowledge bases that are tailored for our specific solution. So it's also fundamental to have information, to rely on information that is correct, updated, but also focused on our context. But also, as said previously, it's extremely important to ensure that we use our brain, because knowledge bases will tend to provide just a very limited view over the system, and that's going to help up to a certain point.
Yeah. So we've talked about the principles around threat modeling that we need to consider And we've taken it one step further to say, okay, what are the capabilities or practices we need to put around those principles? Let's take it one step further. I mean, this is going to take some kind of implementation. So rather than getting into specific tools, we can talk about broadly the tool categories that we need to consider when we talk about threat modeling now and kind of where it's headed. Arun, can you talk a little bit about the tool categories that we had discussed?
And Arun, Altaz, if you don't mind, I have a questions. Maybe it's time to interject, because I know the answer will definitely help the rest of the slides as well. The one question was, how can we scale threat modeling, keep up with the continuous delivery and release cycle? Since we are talking about a tool, and I'm assuming that if we maybe try to answer that question while we are talking about the slides, that'd be great.
Yeah, absolutely. The whole idea of value streams and efficiencies as we go through the pipelines. Absolutely. So we'll keep that lens in mind as we go through the rest of the slides. Great. Arun, you want to talk about the tool categories?
So I'll quickly go through this particular slide. So what Simone mentioned was like it gave us a really good picture. It gave us the baseline on how to derive the different tools. Like we have been talking about how to evolve the threat models, how to carry it out effectively, but the how part of it is going to come from the different tool categories, and that's exactly what we have elaborated in our research also. So if you look at some of them, they are these are the different tool categories or the attributes when you want to evolve your threat models. And if you look at some of these tools, they are going to be, most of these are directly related to the the core threat modeling activity itself. For example, the tools like the mitigation categorization or the dashboarding and reporting, or for that matter, the severity calculator, they are directly related to the threat modeling process itself. Now, what we wanted to go do beyond this is like we want to see how threat modeling can actually fit into the pipeline, how threat modeling can get integrated into the continuous integration and delivery process. And when it does, you see that there are other security activities that are also carried out in the pipeline, right? Like, for example, your SAST, that is also your DAS. There are tools like tools that does threat intelligence and feeds into an external repository. So we have talked about some of the tool categories, like, for example, the value stream alignment, the static threat model analysis tool. These are going to play a key role in giving inputs to your threat modeling process. And these are going to be some of the attributes which the threat modeler will have to consider to continuously improve and continuously make adjustments to the the threat modeling process itself. So we are going to talk about this in detail, but at a high level, these are going to be the different tool categories to effectively improve your threat modeling process.
Yeah, just to hone it back and sort of tie it back to the question that came in, so Simone talked a little bit about this only really has material impact once you're able to get it into, say, an issue tracking system and drive it through into your DevOps pipeline. So in a similar way, when we take a look at what's happening in the production side, if we've got something that came in, maybe we're considering the OSINT tools and they're extracting some meaningful information, the feedback loop very much in a DevSecOps way brings it back for the assessment. And if there's anything that impacts our systems from a vulnerability perspective, we're able to quickly remediate that and get this out into that production environment. But it takes various connections, various integrations for all of these tools in order to facilitate that. So one suggestion is to consider the artifacts and consider how these artifacts make their way through the pipelines. Think about what needs to be modified. Certainly, there are a number of different groups that are working on reference architectures to help identify what these key artifacts are and how they move inside these DevSecOps pipelines. But that would be an indication of how you might go about doing something like that. And if you really would like to have a further conversation on this, even after this presentation, if we still haven't answered that question, feel free. You're welcome to sort of intersect with us as well, and we'd be happy to talk to you. Perhaps this next slide, when we talk about a day in the life of someone who is in this space, might help to bring some of this out as well. So I guess as we look at a day in the life, Simone, could you talk a little bit about what that might look like?
Absolutely. Before delving on that, let me just add a simple comment related to the previous slide. You may have noticed that the list contains some obvious systems which may be integrated with threat modeling, or maybe not. But most of them are not really integrated right now, but you may find more or less from a conceptual point of view, their location. There are others that we have identified which are more advanced. Essentially, we have tried to understand what are the needs for threat modeling, how that could evolve over time, and what are additional tools like static analysis of the threat model itself, which is something that is present in multiple tools to evaluate the quality of the threat model from a formal perspective, but having a static, why not a dynamic? So having the possibility to simulate in some way the threat model and how it works. Returning to the topic of this specific slide, as I was discussing previously, the main phases you will find as a threat modeler are related to understanding the system. This is really the first phase and probably the most important, to understand really the system. And this is done by performing interviews, by reading documentation, and essentially by identifying, analyzing how the different parts of the system interact with each other and interact with the external systems. It's very important in this phase to interpret what is provided to you and try to really analyze it from a security perspective. I've seen a lot of diagrams provided which were focused on different aspects. Very rarely the security was considered, and this may lead to big mistakes if you don't analyze the system from a security perspective. This typically lead to a diagram, not necessarily, but a diagram can be a good way to have a good representation. The second phase is the identification of the threats. And there are typically two different phases where you do that. The first phase is during the discussion. So during the discussion with the team, you will identify some weaknesses, some aspects, and this is done considering the system as a whole, typically. Not only the different parts, the different components, how they interact just in a very limited space, that service, how these interact with the other service, like in this case, this diagram, how the mobile user interacts through the cloud with the gateway, and you focus only on that without considering anything else. So instead, trying to get a sense of the solution, trying to get a sense of the business need or on the business aspects, like what sort of data is handled, where it is handled, what happens if that data is stolen or is tampered, and so on. So an analysis that will take some time, yes, but typically provides the best results. Then those knowledge bases. We have already spoken about those knowledge bases. They are a necessity. I will define them as a necessarily evil at this point, but they are a necessity. We needed them to ensure that we are not missing important things that need to be considered. A lot of tools, I cannot say all of them, but all those that I know tend to analyze a system considering tiny parts, and then to use the knowledge bases and to identify the threats and possibly the mitigations, considering only those parts through automation. I cannot say that all behave like that, but it's like trying to understand what is happening in a huge room while you are looking from the hole in the door. So it's extremely hard to perform this, and we cannot blame the applications, the tools, to do a job that is not perfect. So what you do with that at this point is to have a good understanding of the potential attacks, a good understanding of options, of alternatives to do what you can do. And typically you may want to have different types of controls at this point identified, because, you know, if you have preventive controls in place, you are essentially buying time. You are essentially blocking some categories of attackers, but you are buying time to yourself, because a determined attacker will compromise your system. There is no way around that. So typically a preventive control will not be enough. You will need to have a detective control to detect when the attacker is still trying, is not is trying to compromise your system. And then corrective controls to execute them, to stop the attacker and to prevent the damage. And finally, you may have recovery controls to restore your system at operative state after you have been compromised, sorry. Whatever you do, you will not be perfect. You will not remove the risk. Well, that's not entirely true. There is a way to zero the risk. And if it is, if you avoid having the solution. So if you don't build a solution in the first instance, zero risk. So that's essentially the greatest option that you may have. In fact, sometimes I've heard CISOs telling me that they want to avoid totally the risk. And this is a situation where, well, you understand that perhaps there is a need to have a discussion about what the risk is. So you will have some risk. Those risks will be technical. Yes, you will identify technical risks, but they are associated to business risk. Because if some information is stolen, you will have a business loss. If you have a system that goes down, you will have a loss of productivity. If you have users impacted or customers impacted, you have what is called essentially the loss of your company brand, brand loss. But this, at the end of the day, is nothing else than a loss of market, which you need to, which will require some investment to gain back your market. So it's money again. So it's nothing else. So you need to consider that potential loss. If it is acceptable, then okay, you can go in production. So this is essentially the process. And threat modeling is a part of this process. We want it to be to have a bigger part in this risk management.
Yeah, makes sense. And to tie this discussion with the question that popped up earlier, as we talk about the preventive controls, detective controls, and corrective controls, the issue right now is that a lot of these controls are somewhat fragmented. But if we tie in, for example, detective controls through knowledge bases that might exist, maybe through MITRE or OWASP or any of these communities, being able to translate those into what's happening in the DevOps pipeline. So we translate them into atomic requirements or stories that our DevOps teams can now execute against. Similarly, when we get into production, we've got things that are being detected over there, maybe through something that's coming out from, again, what maybe perhaps MITRE is putting out. The ability to take that, translate that back into these atomic stories that our teams can execute on. This is where we're headed with this. It's the ability to integrate natively security into our DevOps pipelines, thereby shrinking the amount of time that it takes to conduct a lot of these manual efforts. Once you've got it in the form of an atomic requirement or a story, you can now move that through, conduct your testing against it, ensure that your code doesn't regress. But from a threat modeling perspective, it it extends the bounds of what threat modeling is. It is no longer just a design activity anymore. It in fact now extends all the way across the entire software development lifecycle. We are threat modeling at all stages, and we're influencing what we do from coding and testing and deployment all the way through as we consider how our artifacts are changing from a requirement to a build artifact to a test requirement and test cases all the way into deployment and so on and so forth. So that's kind of what we're talking about here. And again, this is not something that is unique to what we discovered as a team. We've had conversations with others out in various communities, and they've also been considering similar types of things. So there's a convergence that is happening around these types of concepts. And really, as we look at this, and we look at the tools, because there will be multiple levels of maturity. What does it mean from the tools that we've got, whether it's risk management or value streams or knowledge bases? How does that tie in to ultimately producing this goal of stakeholder value? So perhaps, Simone, you can talk about the risk management side of things. I'll jump in and talk about from a value stream perspective, and then Lotfi can talk a little bit about the knowledge base. So you want to take the risk management side of things, Simone?
Yeah, but apparently we are almost over time.
I don't know how the time is flying, right? We almost.
Yes.
Oh my goodness.
So I guess we needed to cut a little short.
Yeah. So maybe if we could just quickly kind of go through this, and then we'll bring it to a land.
Yeah, risk management, again, is a very important pillar for the analysis for threat modeling. And it's important to ensure that we continuously learn about the risk, about our experience, and make it a continuous improvement experience linked with everything.
Yeah, and I'd like to add that really from a value stream perspective, it's aligning it to standards, frameworks, policies. This is where the business value is going to come in. Not only that, but value stream implies creating the feedback loops that assist us now with an ongoing assessment. If every activity we do adds some value ultimately back to the stakeholders, then we're on the right track. So Lotfi, you want to talk about the knowledge base?
Thank you, Altaz. Thank you. The knowledge base, having an intelligent knowledge base is very important for threat modeling. It is possible to have, when we run a system, there will be threats that we did not plan for. And monitoring production systems allows potentially to identify threats, to identify attacks, and we would learn new threats, we would learn about new threats. That information needs to go back to the threat modeling process. And that helps to improve the maturity model. Also, an organization that have high maturity model needs to monitor threats and attacks, whether that's threats that are published through Twitter or in a conference and so on, and to update their knowledge base on the threats. That applies also to security controls and to the use of the applicable attack patterns in the threat modeling.
Yeah, makes sense. And so really, when we look at the next steps, what we recommend, just walk before you run, start small, learn, grow from there, mature your threat models over time, involve multiple subject matter experts as you discover all of this. And this is how eventually you will grow. And what we've done is we've identified 4 different levels of maturity, everything from starting in a whiteboard to doing really adding more technical elements to it, and going all the way to level 4, where you've been able to achieve this continuous improvement and your practice is really becoming mature in that sense. We invite you again to go take a look at the white paper that we've produced. It goes into much more depth about what's involved with each of these 4 levels. And with that, we'd like to thank everybody again for taking the time to listen to our presentation today. So Hasan, over to you.
Thank you, Altaz. Thank you, Simone and Lotfi and Arun. It was a great talk. I didn't know how the 1 hour went through. It was a great, because that's really an important thing is becoming more important with the Log4j problem that we are hearing. It was great to discuss and be ready. I know we don't have enough time. I actually have time to ask more questions, so unfortunately we have to move on. And thank you for all of you for great presentations. We're looking forward to having you in the future event. So at that said, we will go to the lunch break shortly, and we will continue in our keynote session at 12:45 p.m. in Eastern Time. So we're going to discuss and talk about open source policies and SBOM and other component from Linux Foundation. Derek, this will be our guest. And thank you. Looking for the next session.
Oh, that's a good one. Actually, I'm going to give an example from my son. So he just this year he was in the 9th grade, actually 10th grade, and he's doing more about the Python learning. So high schools, it's a good opportunity to let the people explore what the programming that we discussed, what the contexts are. So high schoolers, and I really advise that, enable the students to see how they are capable to use a new building of the code and how we can write the code. Actually, and I give the analogy as well, like we are in the digital native right now because most of the kids, most of the students are learning or exposing the digital environment day number one when they go to the schools. Like they can use the ecosystem such as mobile devices, they can use the tablet, they can use the laptop, they can use everything as a computer. So the high school, they should really give an opportunity how this system is working behind the scene. How can I make sure that the students are learning, basically collaborating with the Google Doc as an example, maybe writing a script on Excel file as the macro, maybe writing a basic script of get their job done. So like building the concept of how it is going to work, and I can really get the students be ready of understanding the reason behind it, understanding the cloud, understanding the operating systems, understanding the basic coding. And basically, like you can use the Python code as my son, he used it this year, writing a Python code and start to build up a specific example or the application for them, he can learn. So when we go into the higher level and the college level, we also think about how can I make sure that I'm building a software system eventually will be used in the bigger context. So in the college, we always teach about the algorithms, databases, and other components, which it is good to have it. We should have it. No question about it. We need to understand the fundamentals. We need to understand how things are going to work out, what the best algorithms are. How can I really use the better memory? How can I communicate in a short messaging system? So we can learn that the college level, but at the same time, we have to tie ourselves how it's going to use in the industry practice. We should connect ourselves more about experience, more about trying something. I always encourage the students, if you're in high school, try to build up something for yourself. Maybe you just can automate your document sending to your teacher. Like try to automate that if you can. You know, maybe you're writing a basic PowerPoint, try to write a basic macro in your PowerPoint and try to automate some of the visualization and graphics in your PowerPoint, which is doable. So think about how can I look, it's going to tell you to start some knowledge of the scripting. So when you go to the high school, the college, now you're going to get, how can I build up something that I can use and using my GitHub environment, open up a space in the GitHub, try to expose more realistic scenarios, more realistic example. So what we are learning, we can apply in the real world scenarios. I see a disconnect between, because even though my students, I saw sometimes they know the fundamentals, but it's not as realistic in the real world scenarios. How can we manage that? How can we manage the users? How can I manage some complexity? How can I manage, basic writing code versus writing on desktop or sharing somebody else? It is more about experience. So I want them to think about out of box, think about how can they use different contexts, more realistic. When they go into the more realistic example, they will learn how to build up the software. They will learn how can I speed up the pipeline, which goes back to software factors. They will learn how can I reuse my code over and over again, because they're going to write the code. They will see the similar code again, and they will think about how can I make it a little bit modular of my code that I can reuse again in the futures. So this is basically going that direction. And then in low code, no code, that one of the part in the questions, it's more about the reusable of existing application for over and over again without writing so much code. And most of the, even though sometimes we use that, like we're not writing the code, but using a shared code as an example. We're using other ready solutions as either drag and drop or connecting dots without writing much code, but just reconfiguring an application to serve our needs. That's going to help us. So most of the students are already using that directions.
Another great answer, Hasan. Thank you for that. We've got a good question in the chat from Vijeth asking, how does container technology change DevSecOps?
All right, that's another good question again. Love that discussion. So let's talk about what the container means, so we can maybe come back to DevSecOps a little bit. So I think that let's go this way. Like DevSecOps is a set of practices and principles for us. We are building continuous integration, continuous delivery, continuous feedback, all this continuous term in the DevSecOps practice. So what the container is, as the little bit background, container is giving a process and isolated from operating system for serving a specific needs. So it's basically specific to the app content and isolated from others. I have an app 1 here. I may have an app 2 here. Both are isolated to each other's. I can do that. So going back to the continuous integration, as we said, we would like to automate a build as fast, as quick as possible. And also we would like to deploy without changing much in the production environment. So automation and deployment are the key element is helping us make it a containerized applications. If my application is more container, more isolated others in a small size of the Docker file or the specific features, then I can automate the build and I can deploy without affecting others. So in this context, is really helping to speed up delivery, speed up testing, speed up automation. Because I can stand up at different test harnesses for this container separate, this container separate. I can run 2 of them in the same environment. None of them is going to be interacting each other as they're using different, maybe using a different libraries, different versions, same libraries. It's going to help us to deploy quickly. So how can we use this container? I think we should discuss a little bit more as well. It's about architecture element. As we said at the beginning, so you may be creating a one service as an application 1. It may be one of the microservice that you may be writing here. So because you are getting more specific to the service and how application 1 or app 1 is communicating with others. Same thing for A2 and communicate others. So you may be writing a microservices. So microservices is the way of architecting. You are packaging your services in the container so you can push into your pipeline. So like pipeline is we established, now we are adding an architecture components of the system that we are building and packaging as a container and calling as a services. That's the relationship. I can deploy it. Maybe one of the messaging services that I may have, maybe some of them are payment related, some of them are report, and some of them has possible maybe sending some message to other components. Some of them is just a database communication. So it depends on the service type. And we are packaging the service and put in the container and then ship into the production or deliver into the staging environment. So it is helping the DevSecOps go much faster by using continuous integration, continuous practices. If you don't have a container, yes, we can do the same DevSecOps practices, but we have the right test automation. We have the right deployment packages. Maybe we have the right different build packages. Maybe have a multiple pipeline, we set it up. So in that connectivity, it is helping to go much faster in the context. But it is important to make sure that we are writing the right container files to meet our needs. But we don't want to creating a container file that's about the 1 gigabyte size. It's not going to help. So make sure that you are following the best practices, how to make sure that we have a right layer architecture in the containers. How can we write a very minimal size of the containers, we can go fast in the DevSecOps deployment and test cases. So we can enable the reusable of the components in the libraries that we have the layers of the container, we can use that. It is really important to make sure that we have a right container architecture that we are following and we can use over and over again. Because otherwise, put everything in one container, make it a 5 gigabyte size, it is not going to serve the needs of the DevOps perspective. It will be late to deploy. It's going to be problematic to deploy into the production environment. So when I really give what really DevOps means, there is a 4 fundamental principles of DevOps. And one is the collaborations that we do. And the second one is the infrastructure as code. We kind of call it the IAC. And third one is automation. And fourth one is about the monitoring. So this is kind of like more about the common principles that we were talking. I know there are dependencies. So what really means this core component for us? I know you people heard about the culture as the one of the elements. I kind of give the analogy of building up a DevOps is, think about that you are really driving a car on a highway. Like you just go fast as much as you can in a highway, but you were looking for a good highway, right? If you don't have a great highway, no matter what type of car that you have, no matter what type of brand that you have, you cannot go as fast as you can. So let's think about this analogy in here and take a look at perspective. So we need a highway, we said, right? We need a really good road. In this road, we can drive car fast. So what means in the software world, we would like to really build up the code, we deliver as fast as we can, and end of the day, we can safely arrive our production environment, which is our destination, right? We would like to go into production at our destination. To achieve this road, it's really requiring to build up a great infrastructures. It is important to build up a right infrastructure, which is give us a ability to automate and give us a repeat the same environment over and over and again. It's going to give a high degree of assurances that we don't have any intruders that go into the road, so kind of block that, which goes back to the S1 that we discussed. So we can really block anybody goes into the highway, which is kind of build a highway. And how are we going to build up the highway? We have to understand our team, which goes back to the collaborations. Like teams are, people are going to use this environment. People as us, like a users, like we would like to use this highway. We would like to use the application that we are building. We have to really collaborate with the team to build this infrastructure. At the same time, we can use effectively with this infrastructure, requiring the stakeholders. So collaboration is all about the stakeholders, and the stakeholder has a visibility or has to say something in the software lifecycle that we are looking for. So let's look at the other two elements with automation and the monitoring perspective. Let's build up the highway. Teams are agreed on it, and we have drivers, we have users, we have developers, we have architect. Everybody is kind of a part of that, our discussion, our team, even though we have a cops on the road, which is the security people usually, right? Cops are looking for anybody goes high speed or anything else, we can trap it. Same analogy in the software world, we have cops. Cops are actually helping us to go as safely in our destination. So with that concept, now we would like to automate that. What we are automating is, we don't want to have, if you're going too fast in a highway, like, you have a great car, you're going to maybe, 75 miles per hour, whatever the speed limit is, because we don't want to go about the speed limit, of course. So within that condition, we would like to go as fast as we can. How can we go as fast as we can means we have to automate that some of the steps. What automations are, let's say we go through the, the payment system, like, we have to go through the ticketing system, probably in your highway, or you may have other checkpoints in the highway. Same thing for the software world is true. We would like to go fast by building the components, by compiling, by testing, by delivering, by deploying. It's requiring a automation. So we build up IAC. Let's go a little bit layer. So we have the infrastructure as the first layer, we build it. So now we put the code and application on top of here. To make sure that it is going fast, we have to use automation in our deployments. So like we can test it, we can build it. So we have this combination, we automate the build and deployment. Now, next one is, how are we doing well? Like, how are we targeting a time goes into our production environment that we have? The production environment, or we may have other testing, or we have a staging environment that we do. So go into these things like how we are doing well in terms of how we're driving. We can improve our practices, we can improve our knowledge, we can improve, and some performance of the system is requiring a monitoring. So we have to really monitor our progress, how we are doing well through the life cycle, we can get better. And also monitoring is also loaded term. We would like to monitor how application is behaving well, and also we can collect the feedback. So feedback is from stakeholders, from our users, we can collect the feedback. We can monitor those, get into our team that we were talking about. Let's go a little bit up. So teams, it's going to be our collaborations. People would like to share that. So like fundamentally, DevOps is building up a good way of building the software that we have to speed up. When we go fast, We have to use automation practices to go fast, because otherwise we cannot go fast. But to automate some of the component that we are building, there's another dimension in the DevOps, which is more architectural element. Like if you cannot really architect your system well, you cannot automate some of the practices. If you don't have, you have a great road, you have a great turnpike, you have a great the component that you build in your pipeline as your road. If you don't have a good car, that you cannot go at higher speed, which is the similar analogy. Like you need a good car, you need a good architect, you need a good component, so you can drive fast. Yes, it's a really growing topic right now, Shane, for the SBOM, especially for dependencies or open source, whatever you call about it. I think let's define what the software bill of materials means. It's basically all the software components, that is including open source, including any type of dependency in the application that you're using it, and make them as visible, make them as traceable throughout the life cycle. When we say like a traceable, it's basically we have to know what other components are we are using it, what the versions are we are using it, where we are using it. That's actually a couple of things, like what the version that we have it, and where we are using that libraries, in which context, like maybe a server, maybe some of the dev, maybe some of them is a build package, some of them is runtime package. If we know that where it is we are using it, so we can be ready for any type of incident, any type of vulnerabilities it's becoming for specific vulnerability for that libraries. Because if you don't know where it is, if something happens for a specific libraries, if you don't know what we have in our infrastructure or the build process or environment, it's very difficult to find that and patch that, because we are racing against the time. And like there's a concept of the 0 day, even though the vulnerabilities exist, like identified older in the community, as an organization, if you don't patch that vulnerability timely, that within the application, it is going to be a 0 day still for us. So we have to be very effective with that. How can we do this effectiveness? It's really a good software delivery environment, such as doing a good DevSecOps end-to-end, will help us identify those vulnerabilities, identify this type of libraries easily, or we can keep track that libraries throughout the life cycle. We can go and patch that. I know we're going to discuss most likely, I'm guessing it, because this is going to continue. We're going to see how we can build up SBOM as part of continuous integration. How can we build up the SBOM using a single source of truth as an example? How can we connect the dots? So once we go to the further dive into the question, I will come back again and answer that specifically. Overall, using a good practices and end-to-end life cycle with DevOps component will definitely help us to speed up and be aware for any type of vulnerability, any type of the med dependent we are using in life cycle.
The SCI is a research organization on the cutting edge of cybersecurity and software engineering.
We are based at Carnegie Mellon University, a global research university annually rated among the best for its programs in computer science and engineering.
We serve the nation as a federally funded research and development center, sponsored by the U.S. Department of Defense.
Using proven software engineering principles and practices, we serve as a national resource in software and information assurance, cybersecurity, and data modeling and analytics.
The SCI offers a diverse, inclusive environment that fosters collaboration to spark innovation.
Our employees are excited to work together to solve our nation's toughest problems.
It's an incredibly exciting time to be in the software field. Software is not only one of the biggest challenges that we face, but also where innovation lies.
The SCI is the birthplace for cybersecurity. The CERT program started in 1988.
This resulted in the establishment of the first computer emergency response team right here at CMU.
We build on a strong foundation of theoretical research by creating prototypes, conducting demonstrations and real-world pilots, developing training, publishing our findings, and delivering capabilities that organizations can use.
We are driven more by the desire to address complex, long-term problems in an innovative way, rather than selling a specific product or service.
As a part of my work, I serve as a liaison between academia and the government. The motto of our center is to make the recently possible mission practical.
So one of the things I like the most about working here at the SCI is the ability to kind of choose your own adventure. You're given the freedom and flexibility to take a body of work and make it your own. Make it something that's suited to your skills and interests, and apply your unique talents and techniques to ways that can benefit the DoD.
It is also very rewarding to be a part of a world-class university in computer science and engineering like Carnegie Mellon University.
A global research university with more than 13,000 students, 100,000 alumni, and 5,000 faculty and staff.
Our community bridges the art and engineering worlds, is a world leader in robotics, and is home to one of the world's best schools of drama.
The ability to be part of this community and collaborate with the diverse research talent on campus really sets us apart.
And really, the Pittsburgh area has something to offer everyone. We have lots of arts, sports, outdoors, and I get to be a part of that here on campus.
At CMU, I have the ability to continually expand my skills in the latest cutting-edge research and technologies and use that knowledge in my work.
So one of the great benefits of working at CMU is you get to take any classes that you want completely for free.
I've been able to take advantage of the tuition benefits to continue my education while I work here at the SEI.
If you're a student looking to expand your education beyond what you can learn in school and earn money doing it, we want you to come work with us.
The interns I manage do real work, writing code, analyzing data, and collaborating as valuable team members.
As an intern, I've had a wonderful opportunity to work with many SEI experts.
I could see myself transitioning fairly easily into any sector that they would want me in.
We are at the nexus of academia, the Department of Defense, and government. Our people make this exciting. I joined for the mission, but I've stayed for the people.
I am.
I am.
I am.
I am the SEI.
We are the SEI. Come join us.
The work that we do directly impacts our nation. For more information about available career and internship opportunities with the SEI, please visit our careers website at sei.cmu.edu/careers. We hope that you'll join us.
Hello, everyone. We are in the afternoon session of the DevSecOps Days DC virtual event. And I know we have done so much talks today so far. And we're going to continue with our keynote speaker today with Derek Wicks. He's from Linux Foundation. So Derek, he will be talking about securing the development and supply chain of open source software. Derek serves as a senior vice president at the Linux Foundation, supporting DevOps, security, cloud-native computing, and other technology segments. Prior to Linux Foundation, Derek served as the vice president at the Sonatype, where he focused on open source security and championed research for their annual State of Software Supply Chain report and DevSecOps Community Survey, and 6 years running, which is back-to-back running. We were part of that survey as well with Derek. And Derek has been nominated to the various awards, such as DevOps 100 by TechBeacon, DevOps Evangelist, and also he was an Executive of the Year from ATAC as well. So I know Derek for a while, and he has the passion on open software policies and supply chain perspective. And floor is yours, Derek.
Hello, I'm Derek Weeks, Senior Vice President at the Linux Foundation. While I had previously recorded this presentation, I felt the need to update it with a short amendment about the Log4j remote code execution vulnerability that was announced last Thursday. As you know, Log4j is a very popular logging library used by Java developers around the world in their applications. When the news broke last Thursday, it was also apparent that adversaries were actively exploiting this vulnerability very shortly after the news. This is a common occurrence in other open source vulnerabilities that have been announced to the public, to see adversaries quickly within hours, often within 24 hours, exploiting these new vulnerabilities in applications that are fairly easy to find and sometimes easy to exploit as well. Now, while the adversaries are very fast to react to these vulnerabilities, if you don't know which open source components and libraries and their dependencies that you're using in your applications, in sometimes very large application portfolios, when you hear of this news, your teams kind of have two choices of the things that they do, depending on how you've managed your open source components within your application stacks. One is you can begin a scavenger hunt. You don't know what open source components or what versions of those components you've actually used and in what applications they exist. The reaction to this can be a days, weeks, or even months long scavenger hunt through your portfolio to identify what components you've actually used, where they are, and if they need updated in the environments. For other organizations, they take a more managed approach to the open source components that are flowing through their software supply chains and into their application bases. They take an inventory of these components, and they know exactly which components are used in which particular applications. And when vulnerabilities like this are announced, while they're not good news, these organizations know exactly where to target their highest priority activities for remediation. Now, thankfully, the Apache Foundation made notice that there was a new version of Log4j available that had the vulnerability remediated and allowed people to update to that particular version of the library. So when you think about these new vulnerabilities coming out, is your organization ready for a scavenger hunt, or do you have a prescribed approach and inventory of the components that you're using? The remainder of my talk talks about software supply chain security that I've been addressing with audiences like you for many years. So thank you very much and enjoy the rest of my presentation. Hello, I'm Derek Weeks, Senior Vice President at the Linux Foundation, and today I'm going to talk to you about a subject that I have been researching, studying, and publishing reports on for the past 8 years. Today I'm going to talk with you about securing our software supply chains, what software supply chains are, how we're incredibly reliant on these software supply chains, what adversaries are doing to attack those software supply chains, and how we can better enable ourselves to defend against those attacks and make adversary attacks less successful over time. So with that, let's get into a story that I heard on the radio last week while driving around in my car. I heard that they were recalling red, yellow, and white onions across the United States from restaurants, from grocery stores, and from consumers that had purchased these. There was an E. coli outbreak in 37 states. These onions that were at risk or had E. coli contamination had come from some crops in Mexico. And we were able to wage a full-scale recall of these onions across the supply chains that supported them, because we understood where those onions originated, we understood the distribution chains that they went to, and we understood the consumers who were buying them and were tracking what was happening to consumers in those particular states where the old E. coli outbreaks were noticed. And when they were, there were effective communications sent out, including the radio announcements that I had heard, to say, hey, if we had purchased these onions and didn't know the source of them, or saw the source of them and they came from Mexico, that we were to throw those away. Whether we were a restaurant or whether we a consumer or a grocery store. So they have, in the food industry, managed supply chains. The same goes for the auto industry. Autos ship all the time. They include thousands and thousands of parts. One of those parts happens to be airbags. And in the case of Toyota and other auto manufacturers, they had been shipping Takata airbags in their vehicles for many years, and these were known to be safe parts without any defects. But over time, defects had been discovered in these airbags, and we found dangers to consumers that little bits of metal would come out when the airbags were deployed and put consumers or drivers like me and you at risk. Now, Toyota, when they found out about these problems, understood that what parts or what vehicles, makes, models, years these airbags went into. They understood where those cars were shipped through their supply chains, to which particular countries, to which particular dealers, and they know which consumers had purchased those particular products. That were now known to be defective, and they mounted a recall to this. They're able to do this because they have managed supply chains. They know every part that goes through their supply chains. They know every part that goes into their products. They know what version of part went into what version of vehicle and what model year. And they can trace those through. So if there are ever defects with that automobile or the parts within the automobile, they can effectively stage recalls that then protect consumers at the end of the day. Now, when it comes to software, our software supply chains do not work in the same way. Software today is developed using a number of parts that we don't always write ourselves. Those parts flow in from various supply chains around the world that we rely upon. And because we lack visibility into these parts, it puts our software supply chains and the applications that we're building or the services that they're running upon and the consumers that they're relying upon more at risk. Now, how do auto manufacturers, food suppliers, pharmaceutical companies, electronic companies understand their software supply chains? One is they have visibility to every part or product moving through their software supply chains. They have procurement decisions that help them understand and evaluate all of the parts going into their products, and they keep visibility on those particular parts. They don't not only keep visibility on what parts are we procuring or bringing into our supply chains, and feeding through supply chains, but they're also tracking and tracing those parts or products over time. So if any defects are found later, or any vulnerabilities or any flaws or any bacteria like E. coli, then we need to understand how it's impacting those parts, tracking and tracing them, and then effectively doing recalls to remedy the situation where possible. So let's now take a look at open source software development and how software supply chains work within software development. You might realize that applications today are no longer written from scratch. In fact, developers around the world are leveraging more and more open source components to build their applications. These software components are made by developers in the community, maybe a single developer or maybe a large group of developers, and made available to anyone around the world to freely and actively download those. In fact, there are over 40 million known open source software components and versions of those components available. And it's expected that by 2026, we'll have nearly 10 times that number of open source components and versions available to developers around the world. Just in the past year, organizations that manage these large open source repositories around the world have shown us that there are over 2 trillion downloads of open source components that are generated by software supply chains and developers using software supply chains to help them grow and build their applications. Now, there are only about 30 million software developers on the planet. So when we're talking about 2 trillion package downloads in a year, there's a significant consumption of these components through your software supply chains. And you know what? You actually have more than one software supply chain in your environment. You may have software supply chains for Java open source components or JavaScript open source packages or Python packages or Rust packages. You may be downloading containers from the internet from various container registries that are out there, making these components or containers available to your developers that they are then using to build their applications or organize and build their IT infrastructure that runs those applications. These components feed from internet-based repositories down to your developers at no charge to your organization, and then make their way through the software development process where they are then made available to the consumers of your applications. Now, with 2 trillion downloads coming from multiple repositories into your organization, what this means is that the average organization is consuming hundreds of thousands of open source components a year into your application development processes through your software supply chains. And effectively what that means is that 90% of the applications that you're building today, in some cases if you're in the financial services industry, in fintech, 95% or more of the application that you are building today or your developers are building is built from these open source components that are coming in. This is code you did not write yourself, but borrowed from others who may be experts in building those pieces of technology, whether it be a logging framework or a web application framework or a cryptography library. Now, let me provide some perspectives on these software supply chains, because innovating using open source components or containers and leveraging those that are free because they were developed by others and offered to the community to use accelerates innovation tremendously, and we are all benefiting from that. We are able to build and deploy applications faster than ever before. But not all of these components are created equal. When we look at those 90% of the application that we're building from open source components, we have to recognize that some of these components have known defects. In fact, of the most popular components that we're using, 30% of those have known vulnerabilities within them. For the less popular ones, the average is 6.5%. Now remember when I said your organization may be consuming a couple 100,000, or if you're a large organization, say in the Fortune 2000, you may be consuming millions of these open source components and containers. Imagine that 30% of those hundreds of thousands are known to be vulnerable. And they're working their way into your applications and through your software supply chains. Now, how does this happen? How do we just download something that has a known defect and put it into our applications? Well, if you think about traditional supply chains and the procurement that happens in them, imagine we're at Toyota and we want a new airbag or a new brake pad or a new type of engine or spark plug or whatever that part may be. We have a procurement office, and that procurement office goes out and looks for the very best suppliers that can supply us the highest quality parts at the best price. And we utilize those suppliers to build the products at Toyota or wherever we might be. But that procurement department vets the best components for us to use within our manufacturing process. Now, let's take a look at how software development works and these software supply chains and the easily available or readily available open source parts and containers that are available to developers. If you have 100 developers in your organization, you effectively have 100 people in procurement. Those developers can usually make any decision they want about any component and any version of that component, and it may be one that they've used for many years on end. They know it works, they know it integrates well, they know how it integrates with other components that they may be using or downloading, and they're comfortable with those. If you have 1,000 developers in your organization, you have 1,000 people in procurement of these components. And there's no particular vetting that goes along. When they select a component, it doesn't tell them immediately this is a good one or this is a bad one or this is known to be vulnerable. They're just trying to do their work and meet their next deadline or their next sprint deadline in order to produce this application and meet the go-to-market requirements of the organization. There is no procurement function in this kind of supply chain. And because of that, it can leave us at risk. Now, the other thing that we need to understand about supply chains is that when we are focused on building our applications from these components, and we've shifted from writing a lot of code ourselves that was all custom code to effectively manufacturing or assembling our applications from these reusable, freely available parts. The adversary community has also recognized that we've shifted our approach. So the adversary game used to be, especially around open source components, if we think back to things like Struts vulnerabilities in that web application framework, or if we think about OpenSSL and Heartbleed, the adversaries acted in this wait, discover, and pray kind of scenario. They would have to wait for new security vulnerabilities to be discovered in these open source components. Once those were discovered, then they moved as fast as possible to try and identify exploits against those vulnerabilities and to try and find applications that were reliant on those particular open source components, and then they would wage their attacks. And if we think back to OpenSSL or Strut vulnerabilities that impacted Equifax and many other organizations, just a couple of years ago, 4 or 5 years ago now, those were the wait and pray kind of, or wait, discover, and pray scenarios. But the adversaries, actually knowing that we are more and more reliant on open source supply chains and software supply chains than ever before, have changed their game. They understand that open source software is developed by having a community of contributors that are improving the code, making contributions to that code, and improving it for others that use that code within the community. So the adversaries have actually figured out not that they want to attack applications at the end of the supply chain, but they can be much more efficient by contributing code at the very beginning of the software supply chain. So when we think about this, the adversaries are becoming developers where they are contributing to open source projects, and in some cases contributing known vulnerable code into those projects. The projects don't necessarily have to have security experts on staff. They're just happy to have people in the community contributing to these projects. Once they do, and the adversaries contribute their vulnerable code into these supply chains, they share it. It is then put in these central internet-based warehouses and distributed immediately to any developers around the world that want the newest, latest versions. Now, because of this, adversaries are effectively injecting 0 days into these open source projects that are then distributed sometimes tens or millions of times a week, where they can then prey on those organizations that they know or recognize are using that code. That changes our whole reliance and safety around software supply chains that we are relying upon. So if you think about a circumstance earlier this year, a researcher, Alex Burson, had figured out that various large organizations were using proprietary packages they developed themselves in their applications. But he also recognized that the way the build systems worked was it would just look for the latest version of that particular package. It would look for it in internal repositories as well as external repositories. So if Tesla, for example, were building its own package, and Tesla called that package Tesla 1 or Tesla version 1, their build tool would go and find the latest version, in this case version 1. But if it was set to look for the latest version and someone made Tesla version 2 and put it in the NPM repository, and Tesla's development pattern followed this look for the latest version of the component internally and externally, it would find version 2 out on the internet and then bring it into the development process and put it into the latest version of the application that was being built. Now, this was a pretty interesting use case that this researcher came upon, but when he published that particular use case, within days, literally days, a couple of days, there were tens of repeat or copycat adversary attacks using the same technique that Alex had published in his research. Within a month, there were over 10,000 copycat attempts in the open source supply chains that all of our companies are relying upon. So the adversaries have changed their game from waiting and praying downstream to injecting known vulnerabilities in software supply chains upstream that we are all feeding upon. They know that we have hundreds or thousands of developers in procurement, and that checks aren't readily being done on software flowing through these software supply chains into our applications. It's making the adversaries much more efficient from their attack vectors. The adversaries are not only looking at the components flowing through the software supply chains, but they're looking at every step of the development process along the way. Where can they in particular inject vulnerabilities into software that we're feeding upon or into the tooling that we're relying upon? Can they compromise source control systems? Can they compromise the build platforms? Can they compromise our package repos? Can they bypass the CI/CD processes that we're using to inject various code throughout the software build cycle, which is also part of the software supply chains that we rely upon? And what we've seen is there has been an active increase in those software development processes or in those software supply chain attacks over recent years. And in fact, in the last year, we see a 650% increase in the number of software supply chain attacks that have happened across the industry. So what can we do about this now, or why should we be doing anything about this now? If you think about software supply chain attacks and what is happening out in the industry, we have to recognize open source is at center stage of the innovations that we are creating, that we are all reliant upon, that is moving our economies and making our companies more profitable. But at the same time, security is critical to all of us. And at the moment, our adversaries are winning. They understand how we build or effectively manufacture software now. And they're paying attention to it in some cases more than we are ourselves, because they understand how these supply chains work and how they can be more efficient in attacking them. And because we're not paying attention enough as a software development industry, and our adversaries are paying attention more and taking advantage of that, governments are now demanding action. We're seeing cybersecurity legislation and policy being introduced that impacts and recommends new actions on how we build our software and how we track and trace these components in our software supply chains. And the reality is, for all of us that are building software or relying on software, bad software with known vulnerabilities in it is bad for business. Now, again, when we think about software supply chains, we can think about supply chains and parts and manufacturing processes elsewhere. Do people want to differentiate their products not only based on how quickly they can bring them to market, but what the quality and security of those products are in the market? So if we look at a company like Volvo, it differentiated itself on the safety of its products in the market. It was something that they didn't have to do, but they wanted to do as a company. In some respects, because of all of the work that had been done in grassroots movements in the auto industry through people like Ralph Nader, through people also like W. Edwards Deming, who ask auto manufacturers to build quality in, to build the best capabilities into their products, to improve how they were innovating, to lower their cost, to create competitive differentiators. And now we have not just Volvo, but other manufacturers that are constantly in front of us saying, we have the safest products on the market in our particular market. So security can be a differentiator for those of us that develop software through our software supply chains. Imagine someday that an organization like Microsoft compares itself to IBM and says, we're more secure. The software that we're building at Target is more secure than what Walmart's is, or the software that we're putting into our vehicles at Ford is more secure and of higher quality than what Tesla is doing. You can easily see, because other industries have done this, that security can become a differentiator, and managing what is flowing through our software supply chains and the tooling that we rely on in our software supply chains, and the education and best practices that we can give our developers can help us differentiate our software supply chains and the products that we produce through them to make them more differentiated. So now that we have this background context, what can we do about making our software more secure? First of all, we can understand we are reliant on software supply chains. We are not building all of our code from scratch anymore, and we can produce a software bill of materials. The software bill of materials is effectively a list of ingredients, both proprietary packages or components that we're building internally, as well as a list of those that we've sourced externally from developers that are not our own. We can keep that list of ingredients to evaluate and understand which of those components are good, known to be good, which have known vulnerabilities in them, and if they do have known vulnerabilities, we should fix those before our products are made available to the market. We can also keep this software bill of materials, or effectively a list of software ingredients, so that as new vulnerabilities are discovered next week, next month, or in the coming years, new vulnerabilities discovered in the parts we've used, we can track and trace those through our software supply chains. At the Linux Foundation, where I work, we've worked across industry to help standardize a software bill of materials definition that is now an ISO standard, and that is SPDX. That standard is freely available to anyone in the industry to be able to use. Now, in software development practices that we rely upon, we also need to understand that there are certain practices for which components are better or worse, and there's been a lot of study on this. In fact, in the years prior to the Linux Foundation, I worked at Sonatype, where I led the research for the State of the Software Supply Chain report. And in that research, we found that organizations using the latest versions of components ended up using components with fewer known security vulnerabilities, and therefore producing higher quality applications from those. If you look at a particular component or open source component like the Spring Framework Spring Core, there are hundreds of different versions of that open source framework that are available to developers. But it also often releases new versions of that component many times throughout the year. And if we're going to improve the security of the software we're building, we can migrate to those newer, safer versions, higher quality versions, even higher performing versions to make our software better. Now, as a result of these kinds of practices, what we see are there are kind of three different types of software development practices that you might have. And those can be looked at from those organizations that have low frequency updates to their software and that aren't deploying new changes to their software frequently, as well as those organizations that have frequent updates to their software and use the latest versions of those. In some cases, latest versions could be beta versions or early release versions. So there is a difference in speed of deployments, but there's also not only a difference in speed of deployments, but the quality of packages going into those. So you can have low quality choices of these components that flow through your software supply chain, as well as higher quality choices. Those that are using not the latest version, but almost the latest version of software and updating frequently these open source components that they're using actually end up having much higher quality outcomes for their software. We can also look as an industry to collaborate on prioritizing fixes to common or popular open source components. We as an industry have seen certainly at the Linux Foundation, organizations contribute security tooling to open source projects to better improve and identify known vulnerabilities. At the Linux Foundation, we've also introduced better education and best practices for software development to improve our secure coding practices. And we've also introduced things like new standards like the SPDX SBOM standard to enable organizations to better understand how to build higher quality software as a result. Now, the result of these better practices and adopting these in collaborative efforts across the software development industry means we can have innovation and security at velocity. It is possible. Software security is difficult to do right, but it is doable, and we can use that to improve our software supply chains. Our adversaries today are winning, but it is inevitable that we have to fix the problems with our software supply chain. We have to produce more secure software to thwart adversary attacks. We have to make it more difficult for them to breach our applications and steal the data behind those. This will take a collective effort across our industry, and I invite all of you to be a part of it. Join in with what organizations around the community are doing. Join into the work that we have at the Linux Foundation with organizations like SPDX or the Open Software Supply Chain Foundation, and be part of the solution to better managing and better securing our software supply chains. Thank you very much.
It was a great talk from Derek, actually. It was very timely, and I was talking with Derek last week. Said what we have to do to cover up the content for the software supply chain perspective or SBOM that we have been talking. And then we kind of created the videos because it was really busy. And then suddenly the Log4j happened on last Friday. It was a perfect timing and for the topic that we were talking about. It's a bad timing for everybody else in the world. Like it's so important. It looks like maybe another awakening call for everyone, such as addressing Log4j vulnerabilities. It's very important to understand the open source community, what the components are, and how can we track those. So as Derek has really covered up what we have to do, right? I know we have been using the 40 trillion type of downloads that's happening everywhere else. What do we have to do as a software engineering community, as a DevSecOps community? Then he said a couple of things like that we should really collaborate, that we should really be ready. So when we look at the security perspective, it's about the readiness. It's about finding something in our infrastructures or the component that we are using. It's becoming ready. Yes, we would like to use why the auto industry is ready, why the food industry is ready for any recalls, because they are following the guidelines and process. They are following from the beginning. But when we look at the software engine perspective, as Derek said, there are hundreds of procurement people in our software development lifecycle. Like every developer would like to use one of the open source tools. It's much easier to use that, right? Even I was teaching the course at the CNU, When I ask my students, hey, can you write application for a such testing or assignment, immediately goes to the Google Stack Overflow and copy it, paste and something, get it done. So we are living in that nature right now. It is the how we are building, it's kind of becoming more assembling the parts. So the question is, how are we going to keep track those? Biggest problem I have been seeing it, as Derek laid out as well, we are not ready. What ready means that, yes, we would like to use it. That's what the business says. That's what the business functionality says. That's what the mindset of the developer is. Let's get it done because it's going to save my time. At the moment, we're just looking for the useful either Docker container or the base image, whatever we are using it from the libraries that we would like to use a framework because we would like to get things done, which is it's more functional perspective, more about the business oriented. At the moment, we kind of ignore, yeah, I can do later, and probably I can take a look what my content is. I'm just going to move on because I would like to get it done. Instead of spending a little bit time at the moment that we are looking for a third-party libraries or we are looking for dependencies, as a developer, our mindset is we can do later on. Time is moving. Time is going so fast. With the DevOps mindset, it is getting even faster and faster because we would like to deliver capabilities to the end user as quick as possible. Which happened last week, we learned again, Log4j. The problem is very easy to fix. But the biggest problem is finding where it is. Finding which server has that libraries we are using. Finding which application has that type of libraries we're using. It's very difficult job because we don't know what it is. If you don't know what it is, how are you going to deal with the problem? As Derek said at the beginning, it's going to be becoming a scavenger hunt, like we were looking for the problems, finding out the solutions, but we don't know what it is. It takes time. If you don't know where it is in your application that you develop, if you don't know what the components are, you cannot really fight with adversaries. That's exactly what adversaries are working because they know the problems. They're attacking based on that vulnerabilities. They can find out, and then we are late in the game. Why we are late? Because we are trying to taxing our libraries and dependencies after the release, after the deployment. It is too late. Why we are talking about the shift left concept, we are trying to go to the left side as much as possible. We have to do the same thing for dependencies. Honestly, the first thing we have to think about, what is my dependencies are I'm going to use? Record this. Do we have to use this specific format, like a SPAN format, maybe SPDX, maybe CycloneDX, maybe SWID? There are multiple formats available. But the content is important, like it comes from the developer, it comes from the people like us, it comes from the community. Let's pause it, spend a couple of minutes, not a big deal. Record this libraries that you're using it into your script. If you don't have the kind, write it in a text document, open up another page, say, I'm going to use this one. Then use the other automation techniques, such as mainly infrastructure as a code. As the DevSecOps community, we are using infrastructure as a code. If we put our content that we're using into our practices, that's the time we can do. We can automate those. We can find that. We can use the script. No manual stuff anymore. It should be automated. It should be automated means like our deployment practices automated. When we look at deployment practices, if you are using any type of deployment tools, maybe Ansible, maybe SoulStack, maybe Chef, we can write a script. That script will have the library's name in it. That's what we're expecting. We need to know where the libraries is. We need to know what the dependencies are. Create the list when you are building an application, when we are architecting the application, think about the framework, record into the context that you are going to use, because the context can be used over and over and again as part of your build steps, as part of your release and deployment steps that can be used into your context they're using. The context can be specifically for deployment practices you might be using it. Like one specific example, then it's going to save a lot of time from each of you. Let's say you would like to use one of the base container images running in a production environment. If I know which version that I'm going to use as an image, it can be the image can be verified from your IT infrastructure people. They can verify image based on the stick, based on the patching, based on the version. Then we can all use as a developer community that for our application or our organizations. Then when we are adding a new feature into our application that comes with application layer, let's find out the framework or name or the location that we are building. Now we can build the dependencies as you start writing the code in the first things in the day. like write it, put it in store. Again, you can use the formatted application. That's perfectly fine if you can, but build up as you go. When you try to go back and address the dependency, it's too late. If you are kind of late in the early stage as building and architecting, then you can think about your build steps. Your build should not pull anything from outside your organizations. Find out your manifestos on your build. So there are two types of dependencies, like a build dependencies and a runtime dependencies. The build dependencies you can easily look at in the build steps, which is your build manifestos. You may be using a Maven. You might be using a kind of a compiler language, maybe using the packaging of your code. You might be using a specific language component connecting third-party libraries. You may be packaging the Python code. So whatever you do in the build manifestos, look at that perspective. You can tie the build manifestos that you created as Spawn, which is going to be another connections. Now you build the application content that you know what its ingredients are. Now, next step is the deployment. That's the biggest problem, actually. When you look at the deployment, we always look in the package and then releasing to the operational team, and they were using it, they're deploying. But it's our problem as a DevSecOps community. We really have to look at what things are running in the runtime environment. That can be part of your deployment scripts. That can be part of your either Chef or SaltStack or anything you use. So we're using these practices already, but the problem is we are not able to track those. We're not able to find out where it is. So we're not able to get things together. That was a short summary of the Derek's talk that we discussed so far. We'd like to continue in our next session. Now we're going to deep dive into the static analysis, and that's how it's going to work out with DevSecOps environment. Look at the commonalities. Let's continue our next session. We will be there probably in a couple of minutes.
I prepped it actually. That's a good one. Because I know it's going to come up with the continuous integration. So we have been doing the integration of maybe years, like even though when I wrote the program probably 30 years ago, I was in integration. But what the continuous integration means, that's a little bit, going to come back to this graph shortly. So we have various team members, like the team A, team B, team C are building the code. And within their environment, eventually we have to merge this code. And then we have to build that. What build means, like we're just getting a code and then creating a binary artifact. So this binary artifacts, it's going to be used in the production or the testing environment, right? So this is kind of like a build process. We have to understand what the build means. Beta is going to get the code and then package it, and depends on the build steps and creating some binary artifacts so we can use for various things. So now in the concept of the DevOps or the modern thinking, we are adding a continuous term here. We are adding a C term. Like this is kind of like an integration level. Now suddenly we are adding a continuous integration. What the continuous integration means, so we're going to get the code. We will get the code from the repositories. Remember we mentioned about infrastructure at the beginning. So we will get the code plus other artifacts. Other artifacts is infrastructure code. Other artifacts how we're configuring system. Now build that. Now we are building, so creating artifacts, creating and the testing, and then eventually we're going to do the deployment shortly. So continuous integration will help us to gather any changes from repositories. We get from repositories that kind of get change happen in the repos and developer pushed it. A team pushed something and B team for the repo, for the person wise or a team. So we can grab the code from repository and package it and then make sure delivering to the staging testing environment. So in the build process, we're not again just getting a code, we are getting other artifacts because the software that we are building right now, there are so much dependencies in the software. That goes back to the SPAM question at the beginning. So we get the code, we get other artifacts, how we are creating a deployment as an example. How are we creating a dependent libraries as another package? And so we get all together. Maybe we're building the code, we're just going to push into production. We don't know what operating system requirements are behind it. And third one is, this is the first time probably you may be hearing that, write the code, we have the infrastructure, now we're adding a documentation in it. So you don't think about that we are creating a Word documents in the context. This is more about specific information about our system. Our system that we are building, maybe some specific user guide that we are creating. Maybe we have some notes that it is relevant to how we are configuring an environment. Maybe some notes that's specific to how we are writing the requirements for the code that we are building. So suddenly build is combination of the code, artifacts, and other documentation we can build it. Because as a result of the build, we are creating a artifacts. So artifacts is a binary, but sometimes binary is not enough to run with the production environment because you need other information for a security perspective, for a maintenance perspective. I saw so many examples and the bad practices in software engineering thinking. We are running in the build in the production environment. We're never able to go back and reproduce again because we don't have right build steps, right configuration, right documentation, right infrastructure code pieces in place. So the continuous integration is basically combining all of them. So let's look at the continuous delivery and deployment. Let me get bigger here. So I'm just going to give a quick example about just to set the stage SDLC. So we have the requirements that we write it, and we have the design, kind of like architect as well here. And we have a development and we have a testing. So we are in the deploy. That goes in the production environment. So typically, continuous integration is happening somewhere here as a continuous integration. So we got the code, we are building, and now we make sure that we have the CI. So continuous integration is going to get a build artifacts for us. What is next? So after build artifacts, there are two concepts. One is a continuous delivery, another one is deployment. It's often a confused term. So both of them intend to really go into the production environment. So deployment, get artifacts, and do some testing or requirement test, including security, and automatically pushed into the production environment. That's kind of deployment goes into the production, which user can see as live, as an output, as a result of the build. What the continuous delivery is, it is manual to production environment, but it is automated into the staging environment. So as an organization, we need once we build artifacts, we can go to test harnesses. We can initiate the different test harnesses. We can create more test cases, test environment. We can deliver the artifacts into the staging or test harnesses, so we can do more testing for the artifact that we build. When we are done, we can manually put this artifacts into the production environment. That's a continuous delivery, and deployment goes automatically. So next question we may think about that, can everybody do continuous deployment? It depends on the business needs. It depends on the system that we are building. Can everybody continuous delivery? Yes, we should do continuous delivery because that's the intent of the building a software. First, we can test more and more and more. When you're ready, you can manually get artifacts if you want to put into your production environment. Okay. So quick summary, continuous integration will help us to build artifacts from code, infrastructure, documentation, all information. We can package it, version it. Then we can test it, the content in the staging environment. Make sure everything is working fine, which is delivery. Then when we are moving into the production as the users that can see automatically, that's a continuous deployment. So deployment really is specific to the business need. Deployment is specific to organization needs, that is an example.
Hey, everybody. Welcome back to DevSecOps Days 2021. So I'm Doug Reynolds. I'm here to introduce our next guest, who is Dr. Chris Neer. He is the Chief Technical Officer and founder of Spectre Systems. And he is going to be speaking on the commonality and trends in SAST results. So, kind of the static code analysis. So naturally, Dr. Chris has done a lot of mathematical analysis of software and has pretty much done a lot of things related to static analysis and different sorts of software analysis. So I will let him kind of introduce himself and his presentation.
Okay, thanks. To start off with, I'd like to thank SEI for inviting me today. I'm new to this community, but been a long-time follower. A few quick things about me. I have spent the last 30 years doing research into the mathematical analysis of software. And that background gave me the ability to understand how SAST tools work and why they give the results they do. It's taken myself and my team the last 3 years of R&D to actually quantify this understanding of how the SAST works. So the goal of the work is to better understand the results that you're getting from your SAST tools, and then to use that understanding to enable easier management of the sometimes overwhelming quantity of results that you're getting from tools. So the talk, I'm going to focus on what we've seen, the trends in the results, how to exploit that knowledge to better manage your tool results, and the DevSecOps process in general really has to be another presentation. As you'll see in this talk, this work is extensive. It required a lot of manual verification along the way. It was really a team effort. So let me present the insights that I've seen in our study. Let's see. It's not paging down. Okay. So I'm going to start with the key takeaways from this presentation. First is, in order for SAST to really work for you, you have to use a lot of tools. I know that means tremendous number of defects that have to be managed, but it's the defect management is our goal, and we'll be talking about that later. Second, we really can't rely on the severity ratings that you're getting out of the SAST tools. Typically, about 35% of the defects are listed as severe, but in reality, for your context, it's much less than 1% of defects are truly severe. And of that 1%, most are misclassified as minor or not severe at all. Third, as we all know, there are a lot of noise in the results. And I've been able to quantify these noise levels. And that's what I'll be presenting in this talk. You know, C++ defects are most likely to be false positive. There are very few defects that are easy to exploit or cause highly severe consequences. So the purpose of the study is to kind of lead to an automated determination of these trends. And then we can use these trends to help manage the results. To start our journey, we have to understand SAST behavior. We need a large database of defects. We ran 10 different SAST tools against 8 large open source projects, 4 large C++ projects, 4 primarily Java, some JavaScript and Python. We found 700,000 defects in these 8 projects, which is just huge. 1 defect for every 10 lines of code. When you would run one tool, you'd get maybe 10,000 defects. You get the second tool, another 10,000, third tool, another 10,000. And there's almost no overlap between the results. And we'll be seeing that. So if you're really running only 1 or 2 tools, you're really missing a lot of what's there. So how do we know that there are a lot of defects? Well, that's a 2-step process. The first step is to normalize the defects. Each tool has its own language, its own nomenclature as to how it describes defects. Understanding one tool doesn't necessarily mean that you'll understand the next tool, because they're all discussing defects differently. So we must normalize it so that everything has a common language, common understanding of what the defects actually are. In going through the defects, we find errors in their descriptions, vagueness, say something's a code quality issue when it really has a defined defect. They used keyword searches to describe it, but didn't really look at the actual defect descriptions and so forth. So what we found in looking at every single rule out of these tools, we did 20 SAST tools, about 10,000 defects, that 61% of the defects were described incorrectly. So there's just no wonder why there's confusion from developers about defect reports. The defects being reported really don't align necessarily with what they see in their code. And hopefully this normalization work will get that alignment, and it'll be easier for developers to understand what's coming out of these tools. The second step is to use the normalization and try to find the commonality across the different tools. So you start with normalization of the defects, so we're all on the same understanding of what the defects are. Take out duplicates, look at common source syncs amongst the various tools, add in parent-child relationships, cause-effect relationships, and in the end, you can see which defects are common or found by 2 or more tools. And what we found was absolutely surprising to us. This was just a shocker. Less than 1% of the defects were found by 2 or more tools. starting this process, I would have expected 70–80% of the defects to be in common between various tools, but it was almost none. I mean, taking out the duplicates helps. About a third of the defects were duplicates. That's mostly in commercial tools. The open source tools tend to not have very many duplicates. If you were just to look at defect locations, about 10% of the defect locations are reported by more than 2 or more tools. But what really is happening is there's more than one defect on a given line of code. So it's more likely that you have 2 defects on the same line of code than it is for commonality between the reports of 2 SAST tools. And keep in mind that here we're looking at commonality across 10 different tools. So if you're looking at any pair of tools, tool 1 versus tool 2, it's just a fraction of a percent commonality between 2 of them. So they're all finding different defects. So if we want to ensure that we have safety and security, we have to be using a lot of tools. Now keep in mind, what I'm talking about now are the problems and the trends in the SAST tools. But there are solutions to using lots of tools, and we'll talk about that later. Lastly, I must say that we painstakingly manually checked all 700,000 defects to verify this commonality. So we're sure that confident about our results here. Now that we've have a normalized common set of defects, we can then start looking at different trends in the noise in the defect results. And of course, the most common source of, most discussed source of noise is false positives. To get after the false positives within the data set, we first just started by looking at the relative rankings of false positiveness, not absolute. So is one defect more likely to be a false positive versus another defect? Not that you've got a 50% likelihood. No, it's just one's easier to find and more likely to be true than another. Then we modified that based upon how broad or narrow the rule was. When you have very narrow rules, you know, you're looking at a constant going into a library, they're going to be right almost all the time. The more broad the rule, the more likely you're going to have false positives. But the bulk of the decision here is based upon my research in the mathematical analysis of software. Through my research, I've been able to enumerate 36 different mathematical issues that block the analysis of software from being free of false positives and false negatives. These issues affect the mathematical validity of the results, the path validity, and even the data values coming into the error location. What we found was we flipped that view around, and when a defect has more of these issues than another defect, it's going to be more likely to have greater false positives. So the more issues that you have in getting to the answer, the more likely it's to be a false positive. Then we applied the analysis of these 36 issues against every single one of the 10,000 defects and ended up being able to calculate the theoretical relative probability of correctness ranked individually, just 1 to n. Here's the defect that's most likely to be correct, ranked all the way down in order to the least. We verified the theoretical rules against real life data, decades of historical data, and found it matched more than 99% of the time. The places where we found the mismatch was almost always in our understanding of the breadth of the rule and not in the theoretical results. So in this chart, you see the 8 open source. For instance, Java 1 was the first Java open source. 71% of the defects had a high rating, so they're highly likely to have confidence in the results. A few medium, a few low, and no confidence means that basically it's going to be a false positive. You're going to have 97, 98, 99% of the time they're going to be false positives. So you'll see through the rest of the studies that the no confidence is kind of set aside because it skews the results. If it's a false positive, it doesn't really play a factor into the other pieces of the study. So when we look at the trends, just in the false positive piece, what we find looking at the yellow highlighted sections is that when the rules are applied to Java, the Java results are a whole lot higher confidence than the C results. C are most likely to be low confidence, Java high confidence. Where this comes about is that the Java rules tend to be very, very narrow. So you're giving up coverage and breadth of the defect rules as opposed to the accuracies, and that's what's going on. The second observation in green, there's almost no middle ground in the Java results. It's either highly confident or low or no confidence at all. The third result is that there's a fair number of absolutely no confident results that are just noise and shouldn't be there. In fact, there's even one SAST tool that had 20 to 25% no confident rates. They was just overly aggressive in trying to find defects. We looked at other trends, ease of exploit. So how easy it is to attack against a particular defect. We started this part of the study using the MITRE KPEC data. So it'll describe how to attack a particular defects that you have in code. We expanded upon that somewhat. It's not 100% complete, but that's the bulk of the place for the exploits. We did notice in the KPEC data that there were places where it required more than one defect in your code to be able to do the attack. You have to attack one place, obtain information, do a second attack or a third attack. And that's what I consider indirect. You don't get directly in. So having to have multiple defects in your code reduces the ease of the exploit. We verified these results coming through the CVE database to verify that, yes, it's consistent with what we're seeing here. Looking at the trends, the two kind of pop out. First is there's very few of the defects found by the SAST tools were easy to exploit. You see that in the yellow section. In the green section, it's almost all hard to exploit. So this is a tremendous amount of noise, source of noise in the SAST results. The bottom line is the ease of exploit is a big part of the noise in the defect results. And it really should be considered more heavily when doing triage or defect assessments. You know, CVS scoring does have some aspects of ease of exploit, but it's only a high-low trend. It doesn't have enough emphasis, accuracy, nor even degrees of separation to really pull this out. I should mention that we do have an application that helps us find these trends. So our application can find these ease of exploit trends in the data, and then we can incorporate those trends in our defect management and triage efforts. Same happens with the false positives. Our application can rank the false positives. You know, your defects from 1 to n, most accurate to least accurate, and that can be used for understanding your results and for triage purposes, which is much better than, say, a CVSS score for false positives, which just gives you a high, medium, low. The third aspect of trends that we looked at was with the severity of consequence. Typically in SAST tools, they'll give you 3 levels of severity: high, medium, and low. A few tools go up to 5 levels of high, medium, and so forth. But what they are looking at is it possible there's at least one scenario where it's severe? But some consequences only occur maybe 1/100% of the time. And if you have such a rare occurrence, I would consider that not severe. It needs to be fairly often that you have the severe consequences for it to be a severe defect. So we did a couple of things in our severity trends. First, we extended the consequence list. In the MITRE CWE document, they talk about 10 different consequences. CVSS scoring talks about 3 different consequences. We expanded it to 34 in this study. So we got a lot of precision as to what actually can happen across the defects. We then did a study for each of these consequences that can occur with the defects as to how likely they are to happen. And it's relative. Most of the time, consequence 1 happens over consequence 2. But by looking at the probability of occurrence of the consequences, we get finer granularity as to what really is happening and what the true consequences are. So out of the 415 different defect types that we're looking at, we were able to rank them by consequence 1 to n, and found a big breakpoint. It's kind of surprising, between number 97 and 98. So 97 and up were all high consequence, 98 below were medium consequence, and so forth. And we can see the trends here. Again, the bulk of the situations were very low consequence in the defects that these tools are finding. That's shown in the yellow. In the green, the C results tend to have more of the high severity of consequence versus the Java. Most of the Java ones were not consequential at all. So again, I should note that we do have an application that helps find these trends, and incorporated with the 1 to n levels of most consequential to least, and that helps us find what's going on with these tools. So what are the implications of all of this? Well, first is one I'm sure nobody wants to hear. To really make sure that you are secure, you need to be using a lot of tools. There's no overlap between tools. So you need to be thinking about lots and lots of tools. Of course, with that, you've got an extra burden. You've got so many more defects that you have to deal with, especially when you're looking at C++ projects, because there's such a high rate of false positives with those. So you've got an extra triage. And that's where this project is moving to, is to be able to use these trends that we find in the SAST tools and help you manage more accurately what's going on with the results. Third, yes, ease of exploit needs to be considered more heavily in terms of prioritizations. Otherwise, you're just chasing after defects that are going to be so hard to deal with. You're not going to find people attacking those. The attacks on how often attacks occur correlates very highly with the ease. The easier a defect is, the more likely it is to be attacked in the field. So you really want to focus on the easy to attack defects. And lastly, we need to really start thinking about the probability of severe consequences occurring, not just the possibility. If it's possible, but very, very rare, it may take our resources away from ones that are really going to happen more often. So we need to fold all of these trends together to help us manage our results. So that's where this study is moving. As I have mentioned, we do have a tool that can help find these trends within quite a number of SAST tools right now. But when you start looking at all the trends and combining them together, where you would have defects that you have high confidence in, that are easy to exploit, that have high severity of consequence, it tends to be a very narrow sliver of defects that have all three attributes, because each one is fairly narrowing. We find that less than 0.1% of defects are actually important in all three categories. So given that, even using lots of tools, it should narrow down to a very small piece that actually needs to be managed. Our next step with this is we're working through a comparative assessment tool where we can see these trends with the different vendors and put them together with a study of coverage of each of the defects.
So it looks like we lost Chris there. So he was just wrapping up his talk.
Okay.
There he is. Sorry about that, Chris.
Oh, yeah, I got cut off. So we it's fine. I don't need slides. So so the next thing is add coverage in to the defect analysis. And then we can talk about comparatively which tool is best for your application, one versus another. So in conclusion, I want to give everybody, all the listeners, an opportunity to try our triage trends application. If you contact us at cybersagacity.io, we can give you access to that so you can see the trends and the results that you're seeing in your projects. And what we're interested in is getting your feedback, seeing that the trends we're seeing is what you're seeing, and that technically things are sound and works. That's what we're interested in. Or if you have any other questions or want to continue the conversation,
So we have some questions now for you, Chris.
Sure.
So with all this research and analysis, so it's not just having like one or two quality vendor tools that you're paying for versus the open source tools. You're seeing this kind of results where you get a mixed bag of results with, both vendor tools and open source tools.
Yeah, absolutely. In fact, there were 2 open source tools that did better on false positive ratings than the commercial tools in the study.
Oh, wow. So
the 2 best in terms of false positives were open source, followed by the commercial, and then followed by more open source.
Interesting.
And the same thing with the ease of exploits and so forth. Each tool had what they were good at and not good at. And many of the open sources were just as good as a commercial. Surprising.
Wow, that is a surprise. So a lot of times you rarely see people who are dedicated to static analysis for code tools, like on teams and large teams. Do you think there should be like a large team that's like looking at this, or like a full-time person on this? Because it sounds like you really, just on that project, as it seemed like it was fairly large, you really uncovered a ton of vulnerabilities that need to be sorted through. Like, it sounds like you really put in a lot of time researching that.
Yes. Well, our goal here is to build a tool that can help manage it for you, so you can see it automatically.
Okay.
So yes, you should be using SAST tools. Collect as much data as you can, because the more you collect, the more likely you're to find those security holes, and then let the tool find what's important out of it.
All right.
Which things are easy to exploit, which things have the consequences that you care about, which things are likely to be true and have high confidence.
So basically you're saying, there's a lot of findings, but we only really care about ones that you can actually exploit them reasonably.
Right.
Okay. Gotcha.
And that becomes a very small sliver. So if you load up on open source free tools, get 100,000 defects, you're going to end up finding a few dozen that are important out of it. But it's free. But you're going to capture things that are missing that the other tools don't get.
So going on this, more tools, it seems like it's better as long as you can filter the results. But so I noticed you're saying that Java seemed to have the vulnerabilities were less prone to exploitation versus C. Is that something you see across, higher level languages like Java or dynamic languages like Python or JavaScript? Is that just seemingly the ability to exploit things is a lot lower with something, the higher up the dynamic tree you get, so to speak?
Well, it's not that the defects themselves are easier to exploit. It's that the defects that they tend to find are easier to exploit.
Okay. Like in C, you have all the buffer overflows and
right.
invalid pointers and whatnot.
So it's not the underlying defects in code that's different between Java and C. It's what the tools are finding.
Gotcha. It's just
easy, better at finding the easy ones in C than the easy ones in Java.
I got you. That makes sense. All right. Well, I think we're rolling up to the end of the segment here. So you have any other thoughts? Your website again, I don't have, since we lost the slides. It's cybersagacity.io. All right.
Use the contact us. It'll get to me.
All right, good. And you probably have that study up on there and some of the results as well, so people can kind of dig through things.
We do. And yeah, and I'll be glad to give you access to the tool and you can see it in your own data. See what's happening.
All right, that sounds good, because that's a lot of people I deal with. They're always, trying to look at that, try to find those exploits before they find them, so to speak. So, if you can sort through them and figure out the important ones, it's good. So
it's a needle in the haystack. Absolutely.
Yes.
And that's
all right, folks. Well, thank you for your time, Chris. I appreciate it. That was very interesting. This is Dr. Chris Neer. And I think we're going to roll into a break right now, and we'll be back in a few with our next speaker. And thank you very much, everybody.
All right. Thank you.
Yes, it's a really growing topic right now, Shane, for the SBOM, especially for dependencies or open source, whatever you call about it. I think let's define what the software bill of materials means. It's basically all the software components, that is including open source, including any type of dependency in the application that you're using it, and make them as visible, make them as traceable throughout the life cycle. When we say like a traceable, it's basically we have to know what other components are we are using it, what the versions are we are using it, where we are using it. That's actually a couple of things, like what the version that we have it, and where we are using that libraries in which context, like maybe a server, maybe some of the dev, maybe some of them is a build package, some of them is runtime package. If we know that where it is we are using it, so we can be ready for any type of incident, any type of vulnerabilities, it's becoming for specific vulnerability for that libraries. Because if you don't know where it is, if something happens for a specific libraries, if you don't know what we have in our infrastructure or the build process or environment, it's very difficult to find that and patch that because we are racing against the time. And like there's a concept of the 0 day, even though the vulnerabilities exist, like identified older in the community, as an organization, if you don't patch that vulnerability timely, that given application, it is going to be a 0 day still for us. So we have to be very effective with that. How can we do this effectiveness? It's really a good software delivery environment, such as doing a good DevSecOps end-to-end, will help us identify those vulnerabilities, identify this type of libraries easily, or we can keep track that libraries throughout the life cycle. We can go and patch that. I know we're going to discuss most likely, I'm guessing it because this is going to continue. I think we're going to see how we can build up SBOM as part of continuous integration. How can we build up the SBOM using a single source of truth as an example? How can we connect the dots? So then once we go to the further dive into the question, I will come back again and answer that specifically. Overall, using a good practices and end-to-end life cycle with DevOps component will definitely help us to speed up and be aware for any type of vulnerable, any type of the dependent we are using in life cycle.
Hello, everybody. Welcome to the next few sessions of DevSecOps Days. I am Jeff Hammond. I'm a DevSecOps engineer here at the Software Engineering Institute, and I'm going to be moderating the next two sessions. Our first speaker is Lotfi Ben Othmane. Lotfi is currently a professor at the Department of Electrical and Computer Engineering at Iowa State University, where he also leads the Engineering Secure Smart Cyber Physical Systems Lab. Lotfi has many years of experience and also is one of the early pioneers of the DevSecOps research domain movement. So without further ado, I'd like to kick it over to Lotfi. Lotfi, thanks for joining us today, and the floor is yours. Thank you.
Thank you, Jeff, for this introduction. I thank also for Hasan for the invitation. It is my pleasure to be here and to talk about a little bit about my experience with DevSecOps. And mostly I am going to talk about continuous threat modeling of cyber physical system. I come from academia, but my background is on the industry, and also my project, they are applied projects. So I hope you'll enjoy this. So we all know that in order to develop a secure software, we need to introduce a set of practices, security practices into the development lifecycle. And the early development lifecycle were kind of waterfalls, but today we develop software in iterative ways. And if you have this piece of code on the bottom, and I'm using file input output permission, and then the developer needs to change the permission state.read to, let's say, permission state.unrestricted. The question is going to be, what is the impact of this change on the security of the software? This become now really as unrestricted. And code analysis is not potentially going to change this, that there is a vulnerability that's impacted by this change. And if we do penetration testing, we're gonna do it only at specific phases of the project. So most likely changes like this, they will go unnoticed. So we asked the question, so we have this problem now, and in order to solve it, so we asked the question, how do practitioners deal with changing secure software? Before talking about coming with a solution, let's see people that have been working on this domain for years, and how do they do with this? So we conducted an empirical study. It consists of interviewing 11 participants that they develop secure software. They're involved in the secure software development lifecycle. So we applied the regular process for qualitative empirical study. So we developed an interview question. We invited interviewees, and we had about 11 participants from US and mostly from US and Canada. That they work in banking, they work also on cyber physical system, like so different, so I should not say the name, different cyber physical systems. Then we transcribed the interviews, We conducted the interviews, we transcribed them, then we applied the thematic method to identify the codes from the interviews. We grouped these codes to identify the themes, and then we analyzed the results. I'm not going to go more details into the result of this study. But mostly here I'm going to say that most of our participants, the 11 participants, they apply a process for secure code change that is more or less similar to the one that you can see here. So there is a change request. So they do kind of a risk assessment. What is the impact of this change? What are the risks of this change? Then the developer changes the code. Then there will be a set of tests to the changed code. And these tests might include security tests. Then there will be a test. If the tests are successful, then the change could be deployed. Otherwise, the code needs to be changed. We found out that some of the participants, they use some techniques for security assurance of the changed code. Some they do not. So the techniques, they range from reviewing the changed code and the design of the changed code. Using all of them almost, they do code analysis. So they run their tools, whether it's Coverity, Fortify, whatever tool they use on their full software. And then they address whatever vulnerability they found. Some they do testing, whether these are penetration testing or regular security testing, feature testing. We had one of the interviewees, they do they do search based on a set of keywords. The main thing is the cryptographic library. So you have keywords for the library, the cryptographic library that they use. And also the developers, they were instructed to add a comment when they touch a piece of code that is security related. They added a comment and they use a specific word, like, for example, security, authentication, authorization. And those scripts, they run through the code base and they identify pieces of the code that they have those keywords. So this kind of surprising, or probably not surprising, since we know that there is no really effective tools for changing secure software. But what was what was the most surprising is that we found that only few participants do threat modeling, and effectively doing threat modeling. Only one participant effectively do threat modeling. Some they try to do something on the fast, but really not an application of threat modeling in correct way. So we said, if people don't do threat modeling for secure code changes, and mostly this is dangerous in the case of cyber physical system, or at least cyber physical system is the one that we are concerned with. And our project, they were funded for that. So we asked the question, what are the practices of threat modeling for cyber physical system? Now we have one case, one participant one participant effectively do threat modeling of cyber physical system, and few others, they do kind of threat modeling of the subsequent iteration. What are the practice? It was kind of challenging. So we designed another empirical study. And again, here we want to learn what the industry, what participants in the industry do. Designed another empirical study, and we have friends in the industry, Altaz, and many in the industry. So we were able to get 11 participants. Again, 11. This is kind of a magic number, but we identified 11 number over a year. Of participant cybersecurity expert that work on cyber physical system, and they do threat modeling of cyber physical system. So we conducted the interviews. we transcribe the interviews. We apply the same thematic method to code the interviews. We group the themes, and we perform the analysis of the results. So while you might argue that probably 11 participants are not enough, but at least they give us some information of what is the practice of cyber-physical system. We come up with this conceptual model. So you can in the center, each organization uses kind of a threat modeling process. In that threat modeling process, they use one or a set of threat modeling approaches and threat modeling methods that security expert or people who do threat modeling, they are familiar with in general, like, for example, Stride and so on. So the threat modeling process does not involve only security expert, but involves a set of participant roles, like, for example, the developers, like the architect, like the business guys who are paying for that. Threat modeling also is concerned with cyber-physical system. We find that our participants, they are in general expert on a given cyber-physical system, like, for example, avionic or vehicles or smart grid. So they have kind of given knowledge on a specific cyber-physical system because they have been practicing with threat modeling on that particular system. We noticed that the threat modeling process in general includes continuous threat modeling sub-process that they have. And the threat modeling process and the sub-threat modeling process in general, they use tools. The common tool has been threat modeling tool, Microsoft threat modeling tool. So the threat modeling process for this organization, they focus on security properties, the classic security property of confidentiality, integrity, availability, but in some of the threat modeling process are concerned also with the safety and sometimes with other aspects related to attacks. So, and with the threat modeling, and the role of the threat modeling process is to verify whether the system satisfies these security properties or these safety or other aspect. So that is the goal of the threat modeling. So we found two approaches for threat modeling of cyber-physical system that our participants practice with. So participants who have control system background, who come from computer engineering, for example, or from electrical engineering, they focus on the malicious controllability of physical component. So how it is possible for an attacker to modify, for example, the gas pipes. So they control the gas pipes of the water control system or the grid. The expert that they have an IT background, that they have a training as IT, they focus on the classic threat modeling approaches, where they focus on the data, on the processes, and they focus on the confidentiality, integrity, availability of data and processes. The common method that we found that the participant practice are Stride, Pasta, Linden, and Attack 3. But we found that almost most of the participant, they do not use one method, one just method. They kind of use a combination of known methods and approaches, or a combination of threat modeling standards and known approach. They kind of make their own method based on their expertise, where these method or these approaches, they are based on one of the existing approach, but it is extended with other knowledge or other technique, like, for example, using, let's say, Attack 3, but using standards for control systems and so on. So there is kind of combination for that, which makes things challenging, because if you have another security expert is going to use another technique, then they might come with another set of threats. So the problems with threat modeling for cyber-physical system, the main one is that the focus for cyber-physical system is on exploitable system state and not on the security of data. The security of data is not that is the most important. CPS are complex. They require interaction of many component, distributed component, but threat modeling is time consuming. The average is people are telling us that they spend, let's say, 2 weeks on doing threat modeling of an application. And if you are gonna iterate, if you were gonna release one version of your software, let's say every 3 weeks, you need, if you're gonna do full threat modeling, then you need to repeat that. That is not practical. We also found that cyber-physical system evolve and change continuously with limited control. People, they just pack other software and pack other devices to the cyber-physical system, and that allows to give more features to the users, or the user, they added those the feature to their cyber-physical system, but that grows with limited control. So who controls the cyber-physical system? Let's say if you buy a car and you have connected car, and then you can buy other things from Amazon and just plug them to the car, and you believe that this is secure. That makes the application, it makes the system not secure anymore, right? Threat models are performed using a given architecture. So you have a given architecture that is on paper, and then you do, in general, the threat model is done on that architecture. So threat modeling is not practiced often on cyber-physical system, or it's not practiced often. So we came now to the question if people, they have a challenge with the with threat modeling of cyber-physical system and software are evolved. So we ask the question, have the code changes impacts the security of the software? And the answer obviously is yes, right? So as I show you the first example, or in general, so it is yes. So but threat modeling in general, expert, we need to gather information about the system and to have a set of diagrams that give us an abstraction of what is the flow of information inside the system and the component of the system, which we provide them in the form of a diagram. But these diagrams, they are in general outdated. So if I give you, for example, so here we have a threat model, for example, for Apollo Auto, which is an open source software for self-driving cars. And you can see that we have version 1, version 1.5, 2.0, 2.5. And the diagram, as you're going to see later on, the architecture diagram that are provided, they do not really reflect the recent version of the softwares. So we ask the question, if we have this challenge, can we automate the threat modeling of cyber-physical system? And that is a big question, very big question. But can we start scratching the surface and understanding what are the challenges of doing automation of threat modeling of cyber-physical system? What are the limitations of such activities? So we have here, let's say, Apollo Auto again, the open source, and we have the diagram of the architecture diagram of the system, which you can see that it has a perception, prediction, planning, control. It has also monitoring from the sensors. It communicates, the control communicates with the CAN bus that relates different controller of the car. And it uses HD map for the region wherever you're gonna drive. It allows also to use GPS, which allows to localize where the car is within that map, which allows to plan the next moves and how the car is going to work. So let's start by talking. So cyber-physical system, you have software, you have network, and you have hardware. So I come from software engineering perspective. My first look is, let's focus on the software at first. Let's work on the software stack. Let's assume for Apollo Auto, for example, we have the source code is available on GitHub, and that is given software code. So in order to identify threat model, I need architecture diagram. Can I identify the architecture diagram? Can I recover the architecture? That is the first question. So first task is to recover the architecture. And we need here to recover an accurate architecture of the software and not any architecture, not any diagrams, right? So that is a challenge, first challenge. The second one, I need a threat knowledge base that I am going to use in this system. And that knowledge base would tell me what threats would apply for a given component. While you might say that the threat modeling, the threat knowledge base is iterative and incremental and so on. So we said that we are starting the thoughts, the process, and those are limitations that could be addressed with follow-up research. So with those two information, the recovered architecture and the threat knowledge base, so we could we would extract the threat model, which is the goal. And the threat model could be revised with experts. So they have the diagram and they have this threat knowledge base. So they could be revised. And with that, after that step, we have the threat modeling. And then with the threat modeling, we could improve the knowledge base of the system. So how do we recover the architectural system? There are different approaches for architecture recovery, including using, let's say, text mining and so on. But the most solid one that we would use is to use the code itself. And architecture recovery is basically extraction of the architecture of the application from the implementation. The common approach is to extract the call graph, and the call graph, it models the relationship between the component or the method on the system. Like here, for example, we have method 2 is called by method 3, and method M1 is called by M4, and so on. So with code analysis, we could extract the call graph from a software. And then the challenge comes on clustering the call graphs into a set of cluster with the goal of having a large number of internal connections to the component and few connections between the component. So a common approach for architecture recovery is the bench tool, which we used in the research. So in practice, we compile the software. We obtain what we call intermediate representation. So these are terms from code analysis. Then we build the call graph. Then we cluster the call graph nodes using a given technique, given methods, machine learning methods. Then we obtain an architecture that we hope to believe that it represents the software. So we applied the method initially back in 2016 on a small Java application called Universal AI Ambient Assisted Living, where we have a client GUI application to turn on and off the light. That application has only 378 nodes. We used Bench to cluster the call graphs, and we've seen kind of success because we have a user interface, we have a backend, and then we could apply, that allows us to apply the things. So now we wanted to apply that on a cyber physical system, and we selected, as I said, Apollo Auto, since the software was available, and it is an interesting case for, at least for me, for the student to understand the value of threat modeling. So as you know, that attackers attack the cyber physical system through targeted interfaces. So they need an interface, and they need an entry points. And you can see here on the left, this is the given architecture, the diagram that is given as the architecture of this system. So my students, they spend time on working on trying to deploy the application, and they had a lot of challenges. And while working on that for over a year, they learned kind of the architecture of the application itself. So we identified here the target surfaces and the different components of the system, and we tried to map the component from the given architecture to the different target surfaces. So you can see the given architecture. Then we have from the other side the second column on this table, the ground truth architecture. So we have, let's say, 7 components, the same component that were given in the given architecture were assigned to the map. They are the same also in the ground truth architecture. So until we found that there are, in the given architecture, there is only one component that is gets input from the road, which is the maps, but actually in the ground truth architecture, the architecture that we identified, there are 2 components that they use the data entry from the map, because there is one component called V2X, and that component V2X was not in the given architecture that is in this diagram, but actually it is a component. There is a code there, and that code is used in the application. So unfortunately, our second try did not succeed. So we identified about, the call graph was about 690,000 node. And we put the code on laptop for a month. We were not able to cluster it. We put it on Amazon for X large. We were not able to cluster it. We took the GUI, and again, we were not able to cluster. So you can see in this diagram here the relationship between the number of vertices in the call graph and the number of clusters, which represents the number of components. And you can see that we go from 100 call graph, we have, let's say, 2 or 3 cluster component. Then we went up to 15,000 vertices in the call graph, and with 15,000, we obtain an architecture of 40 components. We still, as a user, I could reason about those 40 clusters. So the one with the GUI, the original bench tool, give me those 40 components, but the command line bench tool, so the one that we took from the one that we develop it, or we extracted from the original one by taking out the GUI component, give us something more than that a little bit. So here I have the runtime, and you can see that we run the bench on AWX large for a month. It did not come, so 2 times for a month, we did not get an answer. And the runtime here, you can see that this is exponential. When we reach 13,000, things start to be exponential. So rather than 1,000 second on 15,000 started to be, let's say, 2,500, but we went up. So we did not put it in the graph here, but it consumes a lot of time, and we had to stop that. So in conclusion, practitioners do not use effective security assurance method for changing secure software. They use code analysis, but that code analysis does not identify all the threats, as you know, all the potential attacks. Threat modeling, unlike code analysis and penetration testing, is not commonly used in practice. Practitioners rely on their own expertise to complement the outcomes of the use of the threat modeling method for cyber physical system, and the performance limitation of the architecture recovery using bench is a big problem for the automation of threat modeling from source code. So with that, so I think here some of my students that they worked on project related to this, Azmat Ali, Shifa Khan, Jian Li, and Amira Mohsina Jamil, they are now working on the industry, all of them. And whoever is interested in the papers related to what I presented, they would find some of the papers on the link below. So thank you. And if there are questions.
Thank you so much, Lotfi. That was a great presentation. We only have a couple minutes left in this session. So I just think a few things that that came to mind was, I think like the iterative approach. I like the iterative approach to this process. And on your conclusions, of course, a few things. I'm a software engineer. A few things stood out to me. Number one, of course, effective security assurance methods for changing software, right? That's the important thing. Things that change constantly, and that's where the threat modeling comes into play. But if it's not commonly used, it's not going to be very effective, right? So, but I enjoyed your presentation. Thank you very much. And I think.
Thank you, Jeff. Thank you very much.
I think that's all we have. So we're going to go to break. We're going to take a 5-minute break. Again, thank you for joining us today, Lotfi, and have a great day. Thank you.
Thank you, Jeff. Thank you, everybody. Bye.
Bye. Thanks. So we'll be back in 5 minutes.
So when I really give them what really DevOps means, there is a core fundamental principles of DevOps. And one is the collaborations that we do. And the second one is the infrastructure as code. We kind of call it the IAC. And third one is automation. And fourth one is about the monitoring. So this is kind of like more about the common principles that we were talking. I know there are dependencies. So what really means this core component for us? I know you people heard about the culture as the one of the elements. I kind of give the analogy of building up a DevOps is, think about that you are really driving a car on a highway. Like you just go fast as much as you can in a highway, but you were looking for a good highway, right? If you don't have a great highway, no matter what type of car that you have, no matter what type of brand that you have, you cannot go as fast as you can. So let's think about this analogy in here and take a look at perspective. So we need a highway, we said, right? We need a really good road. In this road, we can drive car fast. So what means in the software world, we would like to really build up the code, we deliver as fast as we can, and end of the day, we can safely arrive our production environment, which is our destination, right? We would like to go into production at our destination. To achieve this road, it's really requiring to build up a great infrastructures. It is important to build up a right infrastructure, which is give us a ability to automate and give us a repeat the same environment over and over and again. It's going to give a high degree of assurances that we don't have any intruders that go into the road, so kind of block that, which goes back to the S1 that we discussed. So we can really block anybody goes into the highway, which is kind of build a highway. And how are we going to build up the highway? We have to understand our team, which goes back to the collaborations. Like teams are, people are going to use this environment. People as us, like a users, right? We would like to use this highway. We would like to use the application that we are building. We have to really collaborate with the team to build this infrastructure. At the same time, we can use effectively with this infrastructure, requiring the stakeholders. So collaboration is all about the stakeholders, and the stakeholder has a visibility or has to say something in the software lifecycle that we are looking for. So let's look at the other two elements with automation and the monitoring perspective. Let's build up the highway. Teams are agreed on it, and we have drivers, we have users, we have developers, we have architect. Everybody is kind of a part of that, our discussion, our team. Even though we have cops on the road, which is the security people usually, right? Cops are looking for anybody goes high speed or anything else, we can trap it. Same analogy in the software world, we have cops. Cops actually helping us to go as safely in our destination. So with this concept, now we would like to automate that. What we are automating is, we don't want to have, if you're going to fast in a highway, like, you have a great car, you're going to maybe, 75 miles per hour, whatever the speed limit is, because we don't want to go about the speed limit, of course. So within that condition, we would like to go as fast as we can. How can we go as fast as we can? Means we have to automate that some of the steps. What automations are? Let's say we go through the payment system, like, we have to go through the ticketing system, probably in your highway, or you may have the checkpoints in the highway. Same thing for the software world is true. We would like to go fast by building the components, by compiling, by testing, by delivering, by deploying. It's requiring a automation. So we build up IAC. Let's go a little bit layer. So we have the infrastructure as the first layer, we build it. So now we put the code and application on top of here. To make sure that it is going fast, we have to use automation in our deployments. So like we can test it, we can build it. So we have this combination, we automate the build and deployment. Now, next one is, how are we doing well? Like how are we targeting a time goes into our production environment that we have? Production environment, or we may have other testing, or we may have a staging environment that we do. So go into these things like how we are doing well in terms of how we're driving. We can improve our practices, we can improve our knowledge, we can improve, and some performance of the system it is requiring a monitoring. So we have to really monitor our progress, how we are doing well through the life cycle, we can get better. And also monitoring is also loaded term. We would like to monitor how application is behaving well, and also we can collect the feedback. So feedback is from stakeholders, from our users. We can collect the feedback, we can monitor those, get into our team that we were talking about. Let's go a little bit up. So teams, it's going to be our collaborations. People would like to share that. So like fundamentally, DevOps is building up a good way of building the software that we have to speed up. When we go fast, we have to use automation practices to go fast, because otherwise we cannot go fast. But to automate some of the component that we are building, there's another dimension in the DevOps, which is more architectural element. Like if you cannot really architect your system well, you cannot automate some of the practices. If you have a great road, you have a great turnpike, you have a great the component that you build in your pipeline as your road. If you don't have a good car, that you cannot go at higher speed, which is the similar analogy. Like you need a good car, you need a good architect, you need a good component just so you can drive fast.
Welcome back, everybody. Again, I'm Jeff Hammond. Thanks for joining us today with DevSecOps Days. Up next, we have our last speaker of the day. His name is Paul Molin. Paul is a tech lead and a web application security evangelist at Theodo, where he also is a leader of the Security Guild. Paul is going to be discussing culture of security in a developer's company. So without further delay, Paul, I'd like to kick it over to you, and the floor is yours. Thank you.
Thank you. So thank you for being here for this last talk, where I will talk with you about building a culture of security in a developer's company. So who am I? I'm Paul Molin, and so I'm French. So perhaps you will hear, because it's getting late here, so perhaps you will hear my son who doesn't want to sleep. And yeah, I work at Theodo, which is a developers company. So that you get the context, Theodo builds web applications to help our clients to solve their business problems. And so we provide a team of software engineers who will build these applications with the clients. And so how, as a security person, did I come to join this company? So I was working in a hiring forum, and the person who would now become my CEO just coached me and told me, well, do you want to make some web development? And I said, no. And he was like, what do you want to do? Security. And do you know that you can do security in the web? So now, a few years later, I'm here with you to speak about security culture. So I'm really grateful for that. So how do you build a culture of security? First, I would like to talk about the lean practice. So you all know that the earlier you fix a security vulnerability and the less it will cost. So it is a fact that we have to shift left, but shifting left might be more difficult when scaling. So it's pretty easy to make some, to define some requirements and to help developers design their applications correctly when there are a few of them. But if you have to read and help 100 or more developers create secure applications, well, it starts to get hard. And so the lean is a practice that can help shift left at scale. So lean and the Toyota production system, it's a practice that aims to have customers higher customer satisfaction by empowering and helping employees to get better. And one of the key points of this practice is to fight against waste. And there are 8 types of waste, and at least 3 of them are interesting for us in DevSecOps. So the first one is defects. So if you do not do right first time, and that's exactly what we can see on the software development lifecycle and the cost of a security flow. All the rework you have to do to fix it and the impact that it can have on production is a kind of waste. Having security experts spend their time explaining to rereading some code and when you have 100 of developers fixing this again and again the same SQL injections is a kind of waste. And finally, when you have tools that are not properly configured and there are lots of false positives which are given directly to the developers, there's overwork that's done, extra processing. So the lean practice can help shifting left at scale. So what we need to start doing is to involve the business. I remember a few years ago when I was at the AppSec conference in London, I think, Tanya Janka, who was a speaker there, make all the viewers stand up and say that, repeat after her, that the definition of quality must include security. And so I can't ask you to do that now because of it's a virtual conference. So, but this sentence really sticks with me all these years. And so whatever is your definition of quality, it must include security. So for example, at Theodo, for the quality of our applications, we use the 3S framework, and the 3S stand for stability, which is the number of bugs and the complexity of the code you write. Speed, which is the performance of the pages of the application, and security. Well, I think you know what it means. So when they develop products, developers are constantly under pressure by the business to deliver quickly and to meet the deadlines. And so they have to spend times to save time where they can. So this is according to the business will give more importance to the things they can see and to which they can relate. So the features, the missing features, will be really important, and the business team that waits for these features will ask of them a lot. The bugs and the speed issues, although they are not at first something that the business team will expect to see, this will be visible. The bugs will be visible when you walk through the application, and any speed issues will be really visible. But the security issues are not visible at first because, well, you're not the breaches are not exploited yet. And the fun fact is that the potential impact of business and the business is not the exact opposite. So a customer won't won't know that a feature that the business team had wanted is not there. They will see the bug and the speed, but if there is a security breach and the data are leaked, for example, this will be known and the impact on the business can be terrible. So we have to make security more visible and to use visual management tools. So for example, one thing that we do is that we show every week to all of the stakeholders, of the project, a summary of where we are in each of the 3S, and especially on the security side. And so if you show that there are huge gaps that need to be fixed as soon as possible, I think that the business will ask you to prioritize them. And so to enable the developers to evaluate themselves on this scale, this is where you can help them by defining the requirements. The next step is the cooperation between developers and security and the security team. So on a day-to-day, what is a team? So the definition we use at work is that a team is a group of people who work together to achieve a common goal. And oftentimes security and development teams do not have the same goal. Developers are expected to ship often and fast to deliver new features to the end users, whereas the security, well, they are expected to make sure that the apps that are released do not have any vulnerabilities. So developers and security need to have a common objective, and the same thing should be expected from both of them. So the developers should be expected to deliver vulnerability-free apps, and the security teams should be expected to deliver the applications fast. And then when both of them are on the same team and share the same goals, they need to work as a team properly. And the first dysfunction of a team, according to Patrick Lencioni in his book, is the absence of trust. And often this trust can be fought against if the security team makes efforts to understand the context and takes into account the real impact of the flaws they spot. So, for example, an example that happened on lots of projects when I worked with the security team of the clients is in the security reports we were expected to add to secure and to set the cookies as secure and HTTP only, which is normal when it's session cookies. But if it's a cookie in which there is no sensitive data, so user preferences, for example, this is a nonsense. And so security and developers need to communicate on this. Another thing is that can go against the trust is when developers are fed with many alerts spotted by scanning tools, and when the real alerts are drowned out by all the false positives, they start paying less attention to the thing to which they should really be careful. So that was recently the case in an article written by Dan Abramov, who is one of the main maintainers of React.js. And in this article, he explains that oftentimes NPM audits shows lots and lots of vulnerabilities. And in fact, most of them are not exploitable in the context of the app. So for example, if you have an SQL injection in a front-end application, well, you don't care because you don't even communicate with an SQL database. So one thing that can be done is to work with the developers to leverage the tools they already use. And for example, for TypeScript developers, the ESLint tool that I think almost every developer in JavaScript uses, you can create and write your own rules. And an example of this is risks, which is a rule that helps you to detect XSS in React and Vue application. So in React, you can choose to bypass the default security protections of the framework to display HTML that is coming from a user input. And for example, if you have a WYSIWYG, you might want to do that, but the input should be sanitized. So for example, with Temporify or any other sanitizing library. And so what this rule will check is that one is not used without the other. And so you have to agree with the developers on, developers and security must agree on what are the problems they need to solve together, and use the tools they already use to solve them. Another example of that is so I check to make sure that no endpoints generated by API platform, which is another framework that we use, is missing access control rules. And so these tools can be added or already added in the CI/CD pipelines. And so you leverage them to empower the developers. And then what can help is making all of the other employees want to take an interest into security. So most developers are developers because they want to build things and to build things fast. That's the power of code. You can have an MVP in production in just a day. And they could have the false impression that taking the time to get interested in security will slow them. And in fact, getting better in the security field will make you a better developer, and improving at development make you better at understanding security. So you get a better understanding of how HTTP protocols work and how a database management system works. You get better at Linux and understanding properly how session management works is it's a really important part of the software development lifecycle. And the advantage that we have in the security field is that security can be really fun. If you have ever taken part into a capture the flag event on a game, it's really thrilling to be able to exploit the vulnerabilities in the application, and being able to be root in a simple application can be really enjoyable to do and to watch. So just showing the developers what is possible to do within a vulnerable application can bear lots of fruits. And so that's what we did. We built a capture the flag game at Theodore to show an application with some of the most common vulnerabilities that we found, and when it's as a game, it's pretty easy to getting them interested. And then you can start teaching, always with the gamification aspect. We started to make quizzes, and so so all of the developers of the company would meet on the Monday at noon, and there would be 3 or 4 developers with a buzzer who would ask as fast as possible to the questions we asked, and this way we can explain to them security concepts more and more difficult. And finally, as security is related to danger, another emotion, another feeling that we can use is the fear. And so there is a bias, which is the optimism bias. So people tend to believe that they are more likely to experience positive events and less likely to experience negative events. So as long as a security breach has not occurred, people will tend to believe that it won't happen to them. It only happens to other companies. And so how do we fight against this false feeling of security? Well, for as long as humans were able to talk, the thing we do is to gather at the fire camps to tell stories. And stories are a very powerful tool, and especially in security, as there are billions and billions of security stories of failures waiting to be told. So one thing we did is send a newsletter to all of our employees to explain a breach or a vulnerability that was found into an application that was publicly disclosed, and to explain where the developers are failed and how we as an industry can do better. And so you can use, you can have an inventory of these failures to help people understand why we do this, where we have to do these security requirements. And there are lots of perhaps preconceptions that developers have. The first talk I gave at Theodore many years ago, one question was, but we use frameworks, and these frameworks have default security protections by design against all major vulnerabilities. So what do we need to do? And in the model of the 4 levels of competence, first, you don't know that you don't know something, and that's often the case in the security field. So when there is something that you believe you know related to a negative event who will potentially happen, you can be biased in thinking that the antivirus you set up will protect you and that you have nothing to do. You don't need to be careful that the security protections of your frameworks will be enough. But in fact, if you don't use the ORM of the framework correctly, you will be vulnerable to SQL injection, even if there are ways to protect you by design. And another example is React and XSS as a template engine. React does protect against XSS in most cases, but if a user, in this case, chose as a URL with a pseudo protocol JavaScript, the application would be vulnerable to XSS. And when a user click on this link, they would execute the JavaScript in the payload. So you can use this storytelling to break these preconceptions. And then some tools that we use that can be useful on the long run. So to keep getting better, the way is to create a community of practice. One word that is often heard in the DevSecOps field is the security champions. So it's a group of developers who are interested in security and who will help you improve the security in their respective projects. And so in a community of practice, those people can meet regularly to share their learnings. So you can create communication channels to help the developers when they have security questions that are harder to answer using whatever tool you use in your company, and keep training and keep getting better with taking part into capture the flag events or passing new certifications. So that's all for me. Thank you for your attention. And if there are any questions, I'll be happy to answer them.
Thanks so much, Paul. That was a great presentation. And I think one thing I thought of as I was listening to you and looking at your slides here and all the great content was, say hypothetically you have a development group that is starting at square one with all this stuff. They have no, I mean, other than, you know, code scans that don't provide context, maybe they do like, you know, some sort of agile ceremonies here and there. Could you recommend some easy steps to start building in the security culture on a development team? Like, what are the easy early wins? If I look at your 6 phases, like you have the lean practice, get the business involved, cooperation, interest, and, you know, help people. What are some easy things that you can implement on a team to start working towards a security culture path?
Well, I'd say the thing that will pull everything else is to start defining the requirements, the KPIs, and sharing them with the business team, as often is the business team that will put the pressure and decide what's going to be done. So I think involving the business and explaining to them why it's important will pull everything else.
So kind of like more collaboration, early collaboration with all the stakeholders.
Yeah.
Okay. Thank you. Thank you. Yeah, I just kind of, you know, sometimes I deal with this in my day-to-day work here, and part of what I do is try to build a culture of security. So thank you for your opinion. I just want to get your opinion on that, because sometimes when you start working with a team, they don't have any of this implemented. So it's nice to look for early wins. So when you talked about 8 types of waste, one thing that I thought was interesting was, if I remember correctly, you had one type was unused talent. Is that correct? That was an interesting one. So could you elaborate that on that a bit? Meaning, to me, that means making people, or maybe not matching people's skill sets with their tasks. How does that apply to security culture?
Well, what I mean with this is when the developers are not empowered, do not have this culture. If everything lays on the shoulders of the security team, and they have to focus on things that might appear trivial, they don't have the time to focus on the more elaborate aspects of security. So
right. Okay, I understand. Thank you. And then I think that fits in nicely with when you showed, which I thought was really nice, how you kind of get developers interested and educate them on security when you had that quiz that you get everybody in a room with. So I think that kind of would help with, you know, the unused talent problem. We're at time right now, so thank you very much. Again, Paul Moulin from Kyoto, thank you for the great presentation. And we'll be back after a break. Thank you.
Thank you.
Hello, everyone. We are back into the final session of today. So we would like to wrap up what has been discussed so far, what we learned, so we can have some couple takeaways for our home that we are finishing up at 2021 this year. So we are finishing up DevSecOps Days as well. So let's go over to our visual recording, what we record so far. I would like to mention a couple words about what we learned from each of the discussion, each of the sessions, so we can remember those. So we talk about what is the DevSecOps Days community. It is basically supported through the various practitioners like you as a participants, as a speakers. Our goal is really sharing our experience, what we learned, what we have done so far, so we can build up a better community with respect to the security. So that's going to be our job. It is not you and I, it's our job to build up a secure software so we can collectively build up a better environment. And DevSecOps Days community is one of them. And we are going all around the world. As you can see, the sun never sets on DevSecOps. Honestly, I was kind of thinking the Tokyo Day event a couple of weeks ago. It was like the middle of the night here, but it's kind of the morning in the Tokyo section. That means it's not never stopped. Just keep going on. And we are looking for many other community events and within your organization or your city that you are living in, so we can expand the more community. People can share their information so we can build up better secure environment. As we start the first session, I was talking about DevSecOps for enhancing the security for machine learning. That was an interesting talk, because when we look at the machine learning element perspective, yes, we are going to use the DevSecOps environment to build up any model. But how much we can trust in the model? So we learn and look at the model trusting perspective, so we can look at as trusting that how the model is behaving and how the model is talking and how the connections are. Like we can eliminate any type of false data injections, or we can eliminate any data manipulation. And most important things, how are we going to make sure that model is the same model that we created and during our data analysis process or data curation process, the model creation. So we're going to make sure that model is actually an authenticated model that we are using it, which is a missing authentication authorization part of it. So we learned a lot of in this topic and make it a DevOps way. And how are we building the model? Make sure that how are we dealing with the application or in production environment using the model authentication as well as cryptographic hash or other type of techniques that we learned from that talk. As we are moving forward into the threat modeling, and Ken was talking about using threat modeling. I know we heard about today a lot threat modeling, but one thing he said really struck me a lot. He said, if I'm going to do the one thing, is one thing to make sure that we are building secure application. And Ken said, I'm going to do threat modeling. But there are a lot of challenges to the threat modeling into the DevSecOps concept. It was challenging even before. Now it's much easier with the DevSecOps concept. He said we can automate everything. Like we can automate, we can really look at what the risks are. We can build up our knowledge. That's kind of a good sense of connecting threat modeling with the DevSecOps so we can increase our knowledge. As he said, threat modeling is giving an opportunity for us to learn. How are we going to learn from the mistakes that we have? How are we going to learn from the adversary's perspective? Then we can put our knowledge into the application context and design context. So you talk about the important things is really building the concept so we can keep in the application, so we can build up a secure application, and then by doing the threat modeling as a quick summary. As we are moving forward to the interesting thing, like DevSecOps lesson learned from Kayra, and Kayra kind of did an interesting analogy comparing where we are living right now as a COVID environment. What is the reflection on the DevSecOps security communities? Like basically, and having a silent spreader, and basically like person is kind of doing something behind the scene which we don't know. The adversaries are really doing the silent spreader, basically putting malicious code into that environment. We heard from the Derek's talk, will come shortly, and sharing that information, and suddenly, and everybody will expose the malicious code in their environment, which have no idea. Then we really applied other techniques like we do in the COVID era right now. We all are practicing having a social distancing, having contact tracing. And I like the contact tracing, actually. I'm going to open up a little bit more, and we can really tie into our application content, tracing every dependencies. So we can do, and he said about the zero trust perspective. We put a good timeline and what happened last week about log4j and errors and what really happened right now and what we can do with respect to the DevSecOps community. So there's a lot of parallel things and try to bring that life lesson learned into the community so we can get better out of it. And while we are talking about threat modeling, we spend a good amount of time, is about an hour, and talking about the threat modeling with the business and value with the DevSecOps concept. Usually when we do threat modeling, we never really tie into the business value as a risk. Like we do the security analysis, the dynamic analysis, but the problem is we never see the value. If there's no value, and threat modeling become like a static thing and it will stay by this. So we learn in the session what the key concepts are in applying threat modeling in DevSecOps concept. What we should do to evolving threat modeling, make it more agile, make it more business oriented, make it more connected with the value and the risk. So, and the specifically talk was creating a threat modeling as a center of the security, so integrating with other stakeholders, which is a similar concept that we have been saying so far, having a secret in the middle so we can connect others. Now, how you're treating your repositories as an example in your DevSecOps pipeline, you can think about the integrating threat modeling as a center, talking with the risk management team, talking with the security team, talking with the operational team, talking with the tool structure perspective, building up a knowledge is important so we can have a threat modeling that's connected to our environment. Right? So when we are moving to the afternoon session, Derek Wicks from the Sonatype, and the Linux Foundation, he was in the Sonatype before, and I know him for a while. So he really talked about the software supply chain, and he has been in that space, and he has published many surveys and then paper as well with the software supply chain. He really said a couple of things is important here. Are we ready for any resilience? And are we ready for any outage in our environment by some vulnerable code we have in our infrastructure? Industry is doing very well. He gave an example from car industry or the food industry, specific for the onion history. So like we're able to do something in a real life with respect to supply chain. When it comes to software, it is real difficult. Why is that difficult? He said very specific things. He said it is difficult because in the software world that we are living in, every developer is acting as a procurement. Every developer is kind of buying the tools as a free into the environment that we're using. In industry, we usually have a process. We just go and buy something from a vendor or from the supplier. So we know the source, we are buying it, so we're able to keep track of those. But in the software, it is different. And here an example like having a 2 package download per year. And how can I handle this type of a load if you don't have a tracing, as Kayra said, a contact tracing, right? So here an example is using a software bill of materials, keep track everything as we are building. It's kind of like building more about the culture, more about automation, more about the mindset changes. So we can really build up as we go our dependencies. We can put into DevSecOps environment to automate those. It has to be static as the critical mechanism, but has to be as automated in our environment so we can build, we can automatically correct, and we can automate tracing. Because DevSecOps is going to give you a resiliency. If something goes wrong in the production environment, we should be able to go find out any dependence is vulnerable in our infrastructure in application context. Otherwise, will be a problem like what's happening right now with Log4j error, and a lot of people are struggling to find out which server has that vulnerable code running, what the version it is. If you don't know version, if you don't know where it is, it's going to be a problem. That's what they talk about a lot on the topic. So when we are moving to the more depth into the static analysis, and Chris talked about what the commonalities are, what are typical trends in the static analysis, and he shared his research. He looked at the various tools. He created what the trends are, what the commonalities are, and then overall he said, one tool is not enough. You have to have multiple tools to look at different perspectives, so you can really get a big picture about your application, what is really going on with respect to the static analysis. Looking for the normalization, looking for the duplication, looking for the common problems, and some of the relationship in the code, and see the cause-effect relationship, so we can build up an environment in the code, then reflect our static analysis into our application, looking for multiple tools. So the question is, how can we integrate multiple tools? We have to correlate the result. We have to aggregate the result. We have to look at different perspectives. That's what he shared. It was an interesting study, and I think he's going to publish the paper, so you guys can follow up later on the content as well. And then we had the replacement speakers, and one of our speakers was not able to make it the last minute. And Lotfi, thank you for him. He kind of stepped up. He said, "Hey, I have a slide. I would like to talk about threat modeling in practice. So we talk about a couple of things as to what the threat modeling it is with respect to DevSecOps. We learned evolving, and Lotfi specifically described how can we get a threat modeling into the DevSecOps environment, what the practices are. Like he basically gave an example. When we look at the security assurance techniques, we look at the code design, we look at the code analysis and testing and keyword search. But he said specifically, we have to really do the threat modeling as every code changes, so because our architecture may change. If our architecture is changing, that means we are exposing new attack vectors into our application that we are building. So based on architectural changes, we have to look at again, is this really something that we're using in a framework? Are we using something as a new tools and techniques? Are we opening up a new port? So we can do the modeling as we go and for any changes. And he gave an idea about using the standards and methods and techniques that we can apply into the living and dynamic threat modeling as throughout the life cycle. It has to be iterative and has to be as incremental as we're moving forward into the security domain. And always another thing that's strange here, that always outdated architecture diagram is always challenging for a threat model. If you're doing threat modeling, look at updated version of the architecture, look at architecture elements of your systems. We can do end-to-end and threat modeling with the life cycle that we are working on. So short story here, Lotfi specifically, we cannot have a threat modeling as a static and stay in the shell. No, we have to have a threat modeling as we move forward for any changes in our application lifecycle. As the last speaker of the day, and he touched about the culture, and of course, we never have any DevSecOps days without talking about the culture. And he gave a lot of tips about building a security culture, and so that we know what we are doing. We can share the knowledge. We can look at as the lifecycle perspective. We can actually share with the 8 types of waste. I really like that, the 8 types of waste, like the defects and overprotection, not able to spend the time, not able to sharing information, and not able to look at the problems closely, not able to find the reasoning. So he shared a lot of the waste because of the lack of culture, because of lack of the sharing information, because kind of we are giving an assumptions, oh, never something happens to me because I'm doing good, but what the good means. So we learned that good is like kind of a temporary things in the application security. It's just a moment. So now saying that I'm good and nothing will happen to me, then it's going to create a problem. And lastly, he said, we have to build up a training environment. We have to learn. We have to practice. It was a perfectly fitting our DevSecOps Day mission. We would like to learn from our mistakes. We would like to learn from our failures. We can train ourselves. And it doesn't mean something happened to our friends in an organization, nothing happened to us. No, it may happen to us as well. Learn from other organizations, we can get better in our application that we are building, so we can build up a good, secure team with a developer are coordinating together with the same goal, same mission, same vision. And how can we connect that, as we heard from Derek's about the sharing automation, as we heard from the threat modeling perspective, business and value, as we learned from the Ken about automation, and various talk was saying the similar things, sharing, learning, building up an environment we can collectively learn. As that said, we would like to continue our learning practices through the SCI website. We can get a lot of information and about the podcast or the webinar or blog post. Please follow us for adding any knowledge into your chest tool, so you can really get new concepts or new ideas, new attack vectors or new problem. So as collectively, we can use and build up as good secure communities. Again, that's our job and everybody's job to build up a secure environment. And lastly, I would like to thank our sponsors as the CME Sonotype and making this event as achievable. And so we are able to achieve all this work as their support. And I would like also thank you, our moderators and backend recording teams and then facilitators, and everyone. Well, I would like to thank you as well to make that event is real, so we are able to get job done in a time. Lastly, if you have any questions, please reach out to me and we can continue to discuss. Again, this is just the evolving things. We should be ready for anything that in our environment may think something goes wrong. When something is wrong, are we ready? So to shift to the left side, let's learn from our practice environment, and you can reach out at any time for any questions, as well as through the SCI website as well, info@sci.cm.edu. We are looking forward to hear your stories and experience as well. That said, I would like to thank you for your participation. Thanks for staying up to that moment. And I wish you happy holidays and looking forward to see you all in 2022.